Hello team, welcome to NGINX training. This is the masterclass NGINX certification training where we will learn about the basic to advanced on NGINX. We try to make the course more modular and easy to use for everyone who have some background knowledge of the NGINX and who don't have any background knowledge of the NGINX. So let's start with the introduction part and we will see what we are going to cover in NGINX training. So as a part of this particular course, we will learn about the NGINX fundamentals on Ubuntu machine, NGINX as a web server, NGINX as a reverse proxy, and NGINX load balancer. We will also learn about the HTTP protocol and HTTP protocol compression on the NGINX. This is Anshul Chauhan and I will be your instructor for this particular course. I am DevOps professional and have the extensive knowledge of the DevOps toolset. If you are not aware with the NGINX basic functionality, you have not worked on the NGINX ever, you don't need to worry about anything. We'll start working on the NGINX from very basic, from installation to the complete NGINX module setup. So this course is suitable for both audience who have some background knowledge of the NGINX and who don't have any background knowledge of the NGINX. We will start from very basic, even from the installation, and then we will move further for the advanced part. As I just stated, this course is suitable for the absolute beginners who are not aware with the NGINX and the NGINX functionality. We try to keep the lectures practical, relatively short, and up to the point. Although we will include some theory of the NGINX because it is mandatory to learn about the application and the basic point of the application. But 80% lecture in this course are going to be the practical lectures on which we will directly work on the NGINX as a tool. Here I am going to list out few topics which are going to be the section of this particular course. First, we will learn about the NGINX introduction, what is NGINX and why we are learning NGINX. After the introduction part, we will move to the installation and we will see how we can install the NGINX with the help of the package manager and from the binary itself. Then we will learn about the HTTP protocol, because if we are learning about the NGINX, we are creating the web proxy or the load balancer, then HTTP protocol knowledge is must. Then we will set up some labs on the NGINX and we will see some hands-on how we can manage and create the HTTP protocol on NGINX lab. After this, we will see how we can customize the configuration of the NGINX and how we can tune NGINX as per my application. Then we will learn about the performance and security of the NGINX. And then we will see the reverse proxy model of the NGINX and how reverse proxy model of NGINX make it different from the other web servers like HTTPD. After this, we will move to the load balancers and we will see how we can create the custom load balancers, software-based load balancer with the help of the NGINX toolset. Once we come up with the load balancer, we will see the NGINX as a cache management tool and how NGINX is helpful for the static content delivery. After this, we will learn about the static assets of the NGINX and then we will learn about the access management within the NGINX. We'll also see the logging management and logging monitoring of the NGINX. And finally, we will come to the HTTP compression and we will see how we can use HTTP call more efficiently in the NGINX. Then we will move to the modular architecture of the NGINX. Right over here, we will learn about the latest NGINX version and then we'll learn about the cryptography. So team, every topic which I mentioned over here is going to be a complete section in this particular course. This course will come with up to 12 to 15 sections and we are covering from very basic to very advanced of the NGINX. I would like to make sure we are not going to configure a website or database with the help of the NGINX. We are learning about the NGINX as a web server and the load balancer. So thank you team. This is all about the introduction. Let's start with the real knowledge of NGINX. Hello team, welcome back. Welcome to NGINX training and today we are going to discuss about the NGINX. We will see what is the NGINX, what is the use of the NGINX and why we should use the NGINX as a web server. So let's start with. First we need to understand that who developed the NGINX and why NGINX was developed. So NGINX is basically developed by the Russian developer called Igor Sisov. As the official statement, Igor Sisov was using to solve the 10K concurrent problem. Now we need to understand what is the 10K concurrent problem. So whenever we are opening a website, what we are hitting the URL. That URL is going to the web server and that web server is basically processing that particular URL. If 10,000 people are hitting the same URL at the same time, it means 10,000 requests are basically landing on the web server at a same time. That is called 10K concurrent problem. It means when a particular server is getting almost 10K concurrent requests at the same time, that is called the 10K problem. Igor Sisov was using the Apache, and with the Apache, Igor Sisov was facing this particular problem that Apache is not able to handle the large number of concurrent requests. So Igor Sisov started working in 2000 on some new application, and on 2004, Igor Sisov launched the NGINX as an open source tool in the market. NGINX is released as open source in 2004, and now you can assume how powerful and how popular the NGINX is. Today, NGINX and NGINX Plus is the commercial version of the NGINX, can handle hundred of thousands of concurrent connection. It means hundred of thousands of concurrent connection can be handled by the NGINX and the NGINX Plus. And NGINX and NGINX Plus both power more than 50% of the busiest site on the web. World's most famous site like Netflix is also using the NGINX. NGINX is open source software for the web serving, reverse proxy, caching, load balancing, media streaming, and more. So right now we are not aware with the web serving, we are not aware with the reverse proxy, caching, load balancing, and the media streaming. But you can assume that how powerful this application is. This is the open source software for all these purposes, and we are going to learn about each and every purpose in very detail. We will learn about the web proxy and reverse proxy. We will learn about the caching, load balancing, media streaming, and the other things which is related to the NGINX. Apart from these features, as a HTTP server capabilities, NGINX can also function as a proxy server for mail like IM POP3 SMTP, and reverse proxy and load balancer for the HTTP, TCP, and UDP protocols. HTTP is Apache server. Apache server is although have all these functionalities, but apart from the web serving, reverse proxy, caching, load balancing, and the media streaming, NGINX also have the functions of the proxy server for the email, right? And reverse proxy and load balancer for all these three protocols: HTTP, TCP, and the UDP server protocols. As I told you, the origin of the NGINX was to solve the multiple concurrent problem. So NGINX was created as a fastest web server to serve the concurrent large number of requests, which was the limitation before the NGINX origin. NGINX is commonly used as a reverse proxy and the load balancer to manage incoming traffic and distribute to the slower upstream servers. We will see how we can connect the upstream server with the NGINX and how NGINX will distribute the load between the upstream servers on same machine or on different machines. NGINX Plus and NGINX are the best in class web server and application delivery solution used by high traffic websites such as Dropbox and Netflix. Even more than 400 million websites worldwide rely on the NGINX Plus and NGINX to deliver their content quickly, reliably, and securely. So you can assume that how popular and how powerful NGINX become in such a short period. In 2004, that was released as open source. Now NGINX is a separate organization which have the open source and the commercial versions. Many top and high traffic websites are using the NGINX. Some websites are using the NGINX as a proxy. Some websites are using the NGINX as a front end server. Some are using the NGINX as a mail pop server, right? But most of the companies are using the NGINX. I believe if you have the enterprise application or the web application, then it may possible you are also using the NGINX as a subcomponent or the web server. As a software only open source load balancer, as I told you, NGINX is a load balancer. NGINX is less expensive. It means if we are going to configure the hardware load balancer, that is going to be the expensive one. But NGINX is the software based load balancer. And for the software load balancer, what you need to do, you just need to install the NGINX, tune your configuration, and it will be ready to serve the traffic. So by this way, NGINX is more configurable than the hardware load balancer, and it is designed for the modern cloud architectures. That is also the best part of the NGINX. Most of the cloud load balancers are using the NGINX. If we will talk about the AWS or the Google Cloud Load Balancer, although Google Cloud Load Balancer have the network software based load balancer, but internally somehow they are using the NGINX, because once you will configure the backend services and the backend port, you will see the configuration is same like the NGINX configuration. As I mentioned earlier as well, NGINX is the multifunctional tool. With the NGINX, user can use the same tool as a load balancer, as a reverse proxy, as a content caching management, as a web server, as a mail proxy. NGINX also supports the microservices or the HTTP2 protocols. That is the advantage with the NGINX, that NGINX support the microservices and the HTTP2 protocol. It doesn't matter that your web server or your connection is connected with some basic database or some older database. If you're using the microservices, NGINX will support your system. The another advantage with the NGINX is that NGINX is a Docker friendly technology, which makes it first choice for the cloud based applications as a load balancer. You can install the NGINX directly as a Docker. Even if you will go to the Docker Hub site, you will get the official NGINX image. And what you need to do, you just need to download that particular image and execute your Docker. That's all for the NGINX. Later on, you can configure your things in that particular NGINX image. You can take that NGINX image as a base image, and then you can put your own configuration on that particular image. That is the further part. But the point is, Dockerized version of the NGINX is very stable and very reliable. Most of the load balancer which are running inside the Docker container application inside the Kubernetes, they are using the NGINX load balancer. The another good thing with the NGINX is that NGINX support n number of open source third party libraries, which make it more flexible and the expandable. If you will Google for the NGINX third party library, you will get thousands of the libraries which can you attach with the NGINX. And that is the beauty of the open source framework, that mostly you will get the open source library to fulfill your work with the open source softwares. So that's all about the NGINX team. I hope you are pretty much clear about the NGINX, the application of the NGINX, right? And what NGINX is. So team, if you have any doubt, any question, then please let me know. Thank you team. Thanks for your time. Hello team. Welcome back. Welcome to NGINX training. And today we will discuss about the differences and comparison between the NGINX and Apache web server. As we know that Apache and NGINX both are the web server. So we need to know what is the difference between the NGINX and Apache, when we should choose Apache over the NGINX, and when we should use NGINX over the Apache. So let's start with. So team, NGINX and the Apache, which is also called HTTPD, both are the web servers and have their own characteristics. In some cases, Apache is good, and in some other cases, NGINX is good. So we are going to discuss about the characteristics of the NGINX and Apache, and we will see which web server is suitable for your application and which one you should use for your application. Very first, the main difference between the Apache and the NGINX architecture is the design. The both application have the different design. Apache or HTTPD uses the process driven approach and creates a new process or a new thread for each request. On the other hand, NGINX use the event driven architecture to handle the multiple requests within the one thread. So as I mentioned, Apache use the process driven approach. It means whenever you are going to configure the Apache, you also need to define the number of processes your Apache server can handle concurrent request. It means the number of concurrent requests and the number of processes should be same. If you are getting more number of requests, then these requests will be dropped by the Apache server. So for each request, Apache server will create a separate process, and that process will handle that particular request till start to endpoint. Where on the NGINX, the implementation is different. In the NGINX, implementation is one to many. It means all the requests, even they are 10,000 or 100,000, they will handled by the same and single process. In the NGINX, we have the single process which will handle all the requests, and it will not drop any request, right? And each request will be handled in a separate thread. So whether the Apache server is creating the separate process for each request, on the other hand, NGINX is have the single process but creating a separate thread for that particular request. So that is the basic difference between the Apache and the NGINX, and that architectural difference is the complete story which make the NGINX fast as compared to the Apache for the large number of requests. First, let's discuss about the simplicity of both the web servers. Simplicity of the Apache and the NGINX. So developing and invocating the applications on the Apache server is easy as compared to the NGINX, because one connection per process model make it very easy to insert modules at any point in the web service logic. So in the Apache web server, you can put up your own modules, you can put up your own web server logic, and as we know that single process can be handled by the single request, so it is very easy to maintain the modules. On the other hand, NGINX have the single process application which is creating the multiple threads. So whenever we are defining or we are creating the module inside the NGINX, we need to be more careful. It may possible that a single error can block the complete web server, right? If a single process is breaking in the Apache, right, then that process is just breaking that particular request. But if the process is breaking in the NGINX, that process is basically crash the complete server. That is the main difference. So Apache is quite simple as compared to the NGINX in terms of the module for the dynamic contents. Now let's talk about the performance. So as we have already discussed that NGINX is basically designed to provide the better performance. So Apache performance is better when hosting site that experience relatively low level of the traffic. So Apache performs better when hosting site that experience the relatively low traffic. Where suppose we have the 1,000 requests or few requests per hour, then definitely Apache perform better. But if we have the more number of requests, right, we have the large number of requests and the concurrent request on the web server, then NGINX performs better for the site that experience lot of requests simultaneously. Let's discuss about the reason of the poor performance of the Apache. And the poor performance reason for the Apache is the IO operations. Let's discuss about it a bit. So in the Apache server, we have the .st file. In this particular file, we will define the complete directory based block for each site. It means all the process which is being handled inside the Apache web server, all these process will read this particular file, because this is the core file of the Apache server, which will have the complete mapping of the URL with the content, right? Whenever we have the complete mapping of the URL with the content, suppose 1,000 processes are running in the Apache server, then all 1,000 process will reading this particular file at the same time. Whenever these process will be 10,000, it means 10,000 process are basically reading the same file at the same time. It will increase the input output operation of the system. By this way, you will get the CPU hike, you will also get the memory consumption, which is not the possibility with the NGINX. NGINX don't have such files, right, which will be read by the multiple threads at the same time. Although the NGINX has the advantage that NGINX will use the cache. So the recent URL which is being fetched by some resources, that URL will be kept inside the NGINX cache. And if the same request or some other request are hitting the same URL, then that response will be written from the cache itself. So by this particular way, we can understand that the performance of the NGINX is far better than the Apache for the large number of requests. In any website, you have the two kind of contents, right? The first content is called the static content and the second content is called the dynamic content. So if you are learning some tutorial websites, then definitely you are going with the static content, because that content is basically written in some database, some queries fetching that particular database, or it may possible that is a static HTML page and you are just hitting that particular page and web server is returning that particular HTML page. The second content is the dynamic content. Whenever you will send a request, the page will construct dynamically with the help of the programming language, and then it will represent to the user. Like the Google, YouTube, Facebook, they all are serving the dynamic content. Wikipedia, blogging site, they all serving the static content. So in terms of the static content, NGINX performed 2.5 times faster as compared to the Apache. Why? Because in the Apache, each request, either that is reading the dynamic content or the static content, that request is creating the separate process which have their own running cost. On the other hand, NGINX have the single process. Whenever a static page request will come to the NGINX, NGINX will directly return that particular HTML page without any process acknowledgement, which is far better as compared to the Apache. But in terms of the dynamic content, as we know that Apache create a separate process for each request. So once the request is coming for the dynamic content, Apache process dynamically content by embedding a process for a language like PHP into its worker instance. So that process will calculate the complete dynamic content and serve the customer. And this allows Apache to execute dynamic content within the web server itself, right, without having rely on the external component. It means if the request is coming for the dynamic content, Apache server will initialize some PHP kind of process. That process will work and get the request, and that request is completely served and processed within the web server only and returned back to the client. But in the case of the NGINX, NGINX doesn't serve the dynamic content natively, right? That is the basic difference. Dynamic content is basically served by the Apache natively, but dynamic content is not being served by the NGINX natively because NGINX don't have the separate process for the request. Once the dynamic content request will come to the NGINX, NGINX will handle that particular with the help of the PHP or other request using the external process. And that process will execute that particular request. It will send the response to the NGINX and NGINX will send the response to the application. That is called reverse proxy. Single process is running in the NGINX. Request will come to the NGINX. NGINX will create a third party process to process that particular request. Right, once the request will be processed, that process send the acknowledgement to the NGINX and NGINX will send the acknowledgement to the application. That is called the reverse proxy. So in terms of the performance, NGINX is much better because static content serving capability of the NGINX is far better than the Apache, and dynamic content processing power of NGINX and the Apache is almost similar because in the NGINX we are serving the third party libraries or third party processors to use that particular functionality. So as I told you, we was discussing about this, that three requests is coming to the NGINX server. The first is the PNG file, which is the static file. Second is the PHP file, right, which is the dynamic request, and third is the text file, which is the again static file. The static file will directly come to the NGINX within a single process, and NGINX will directly return these particular static file on the basis of the URI mapped in the configuration file. But for the dynamic request, NGINX will create the another PHP FPM process. For the dynamic request, NGINX will also create the another PHP FPM process, which process will serve that particular dynamic content and reverse back to the NGINX, and NGINX then reverse back the request to the client. That is called the reverse proxy, right? So for the static, as far as static content is the concerned, NGINX overpass the Apache as NGINX has the 2.5 better times performance as compared to the Apache. And in terms of the dynamic, both are great at processing dynamic content, right? Apache and NGINX both serve the dynamic content at the same speed. The next attribute on which we can compare is the OS support, operating system support. Apache runs on all operating systems such as Unix, Linux, BDS, and has full support for the Microsoft Windows as well. On the other hand, NGINX also run on several modern Unix-like system and has support for the Windows, but NGINX performance on Windows is not stable as that on Unix, right? So in terms of the OS support, Apache is better than the NGINX. Now let's discuss about the another configuration, which is the distributed or centralized configuration. Whenever we are defining the web server, we need to define the configuration within the web server, so that we need to make sure which request we need to process, which request we need to block. Apache allow additional configuration on the per directory basis by st.access file. As I told you that inside the Apache, you need to define the complete directory path, right? And the file path inside the st.access, that which request can serve and which request can process to which resource. NGINX doesn't allow any additional configuration. It means you don't define any additional configuration inside the NGINX. NGINX have their own configuration file, which is called NGINX config, right? But in that configuration file, you cannot mention that which request can be processed and which request can be blocked. Now let's discuss about the request interruption. How the request will be interrupted by the both web server, NGINX and the Apache. So Apache pass the file system location. Whenever request will come to the Apache server have the .staccess file. That file will have the complete URI and the document, right, which will work on the basis of the request. And NGINX on the other hand passes the URI to interrupt request. It means inside the NGINX configuration file, you will define the URI, and that URI will basically decide on which upstream that request need to be land. So in the request interruption, NGINX is far better as compared to the Apache server. So NGINX has won because the quicker interruption and the response time of the NGINX for the URI base. Next is the interesting thing, which is the feature module, right? Feature module are something which will come with the web server, that which feature that particular web server can carry and which feature that particular web server can't carry. So in terms of the feature module, Apache have 60 official dynamic loadable modules that can be turned on and turned off on request. All these 60 are not useful. Hardly you will use 12 to 13 whenever you are going to use the Apache server in your productions. And on the other hand, NGINX have the third party core modules. NGINX open source version don't have the any native core modules, but it have thousands of the third party core modules which you cannot dynamically load. If you need to include any third party module within the NGINX, then you need to include that particular module within the binary of the NGINX. NGINX provide all the core feature of the web server without sacrificing the lightweight and high performance quality that have made it successful. That is the basic reason of the NGINX successful, that NGINX is the very lightweight, because only single process is running in the NGINX. So resource consumption of the NGINX is very low as compared to the Apache, because Apache using the separate process for each request. So suppose you are executing the Apache and NGINX on same kind of configuration machine, and you have the 5000 request on the Apache and 5000 concurrent request on the NGINX, then you will see NGINX is hardly using 15% resource as compared to the Apache. Next one is the flexibility. Which one is more flexible? So Apache supports customization of the web server through the dynamic modules. As I told you, in the Apache you have the 60 dynamic modules. You can make them off, make them on, and you can do whatever you want. NGINX is not flexible enough to support the dynamic modules and loading. As I told you, if you want to load some module, then definitely you need to include that module in the NGINX library. Next one is the security. So Apache makes sure that all the website that runs on its server are safe from the harm and hackers, right? So Apache is a very secure system which will make sure that the website which is running behind the Apache web server, they will be harmless from any breach or the hackers. Apache offers configuration tips for the DOS attack handling, as well as mode-based module eavesdropping, HTTPS DOS, DDoS attack, brute force attack as well. NGINX is also a better security with the smaller code base. NGINX also support a very high security model, and the advantage with NGINX that NGINX code base is very easy, which will make it more secure over the Apache HTTPD. Now the question is when to choose Apache web server over the NGINX, and I hope now you can answer this question. So when we need .st file, you can override system-wide setting on per directory basis. You should go with the Apache. If you have the standard hosting environment, Apache works better because of its st.access file. In case you want some functionality limitation, you can use Apache, because Apache provides the custom module and dynamic module configuration within it. Now the next question is when we choose NGINX over the Apache. So answer is simple. If you need faster web server for the concurrent request, you should go with the NGINX, right? So fast static content processing is your requirement, then NGINX is the web server for you. And NGINX is also great for the high traffic website. If the traffic on your website is very high, you should go with the NGINX. Can we use both web server together? Is it possible or not? So the answer is yes, it is possible. And if this is possible, then what should be the application configuration whenever we are using the both web servers? So let's understand this. So user can use NGINX in front of Apache as a server proxy. So over here we have the client, we have the front end which is NGINX. Then we have the two other processes behind the front end, which is the back end, which is executing in PHP, and then we have the static content. So over here you can put up NGINX as a front end server as a load balancer. And behind this particular NGINX load balancer, you can put multiple applications, like we are putting two applications, one for the static content, which is again a web server, and another one for the dynamic request, which is a Apache, right, which is again a web server. So we have the client, then we have the load balancer, and behind the load balancer we are executing to another web server, which is NGINX itself and the Apache itself. So in this particular model, you can use the both server. This is solving your problem of the dynamic content as well. This is solving the problem of the static content. Plus, this is solving the problem of your multiple concurrent requests. So for static connections, NGINX will serve the files quickly as compared to the Apache. And for the PHP applications or for the dynamic contents, NGINX reverse proxy server will proxy their request to the Apache. With them, they can process and their results and return to the rendered page, right? So this is the way how we can use the both servers together. So team, I hope right now you are pretty much clear then what is the Apache, what is the NGINX, what is the difference in both of these servers, when we should use the Apache, when we should use the NGINX, and if we want to use both of them, then what could be the model of both of the web server we can use. So thank you team, thanks for your time. If you have any doubt, any question, then please let me know. I will be happy to answer your questions. Hello team, welcome back. Welcome to NGINX training. And in this section, we will see how we can install the NGINX on different machines. So as we have discussed earlier as well, NGINX provide the better performance on the Unix system. So we will install and follow all the labs in this particular tutorial on the Unix system. So don't worry if you don't have the Unix system, if you are using the Mac machine, you are using the Linux machine, or you are using the Windows machine, you don't need to worry about it. In this particular lecture, we will see how we can create a free cloud machine on the digital ocean. And that machine you can use to learn this particular course further and practice this particular course. So Nginx supports the Unix system better. So we are going to create the Unix machine on the cloud. The cloud service which we are going to create the Unix machine is the DigitalOcean. DigitalOcean is the public cloud provider on which you can create the droplet, which will be the Fedora machine, which will be the Unix Linux machine, or the CentOS machine. Team, I would like to make sure to sign up on the DigitalOcean and to create the droplet or the machine on the DigitalOcean to use that particular machine. You don't need to pay a single cent to the DigitalOcean. We will provide the $100 referral link to sign up on the DigitalOcean. If you will sign up the DigitalOcean with the help of that particular referral link, you will get the $100 credit in your DigitalOcean account. And that $100 referral is quite enough to complete this particular course even 5 times. Along with the referral links, we will also share some coupons, and these coupons worth will $35. So as a combination, you will get total credit $135 on the DigitalOcean. To get the referral link and the common, you need to follow the next lecture, right, which is a text article in which we have given the referral link and the coupon list which you can use. So over here I am showing you the next lecture. Here we have defined the step to registration on the DigitalOcean and get the promo code. You need to click this particular referral link to get the $100 credit in your account. Once you will click this particular referral link, you will go to the DigitalOcean. You need to sign up to the DigitalOcean, and for the safer side, DigitalOcean will ask for the billing detail. Over there you need to provide your credit card details, so that in any case if $100 credit will be finished, then DigitalOcean can charge you. But believe me, $100 or $135 will be quite enough to learn this particular course up to 2 years. While you will filling your billing info, you will get a promo code section, right? In that particular promo code section, you need to provide these promo codes, right? I believe out of these 12 promo codes, at least 8 promo codes are working, and maximum you will get the $35 credit from these promo codes as well. So ultimately you will have $135 credit in your account. So let's go to the DigitalOcean and let's see how we can create the machine on the cloud. So once you will open the DigitalOcean with the given reference link, you will land on this particular screen. Over here you need to click on this particular sign up and sign up on the DigitalOcean. Once the sign up will done, DigitalOcean will ask for the billing details. You need to provide your credit card details, and after that you will be able to use the DigitalOcean. I already have my account on the DigitalOcean, so it is not asking for my details. Once you will log in into the DigitalOcean, you will get a screen like this. Over here, the first option we are getting the droplets. So let's click the droplets, and it is saying looks like you don't have any droplet, so create a droplet. I will go and create a droplet. So over here you can see we are getting this kind of UI. It is asking for the image which I want to use. I want to use Ubuntu, FreeBDS, Fedora, Debian, or CentOS. And in the image as well, it is asking that which Ubuntu image you want to use: 16.04, 16.04.6, or 18.04.3. I will go with the default one. Then it is asking to choose the plan. I'm going with the basic one, right? And over here it is showing me the machine, right? This machine will cost me around $40 a month, right? This is going to the 8 GB machine, 160 GB SSD, and 5 terabyte transfer. I'm not going to create heavy machines, so I will click this particular arrow icon and I will go with the basic one. So basic machine is just $5 a month, which will be 1 GB, 1 core CPU, 25 GB SSD disk, and 1000 GB transfer, right? I'm going to select this particular machine. So you can see we are creating $5 a month machine, so you can assume that $135 will be quite enough to execute the DigitalOcean machine for 2 years, and the current course you can finish even within a month or 2 months. So the given credit is quite enough. You don't need to pay any single penny to anyone to learn this course further. I'm going to choose this particular option. Then it is asking that in which particular data center I want to create my machine. So suppose I'm going to create my machine in the San Francisco. Then it is asking for the VPC network. I'm not going to enable the VPC network. Asking for the IPv6 user data monitoring, no options. Then over here, please make sure we will go with the password. We are not going with the SSH key and we are going with the password, right? Authentication mode will be the password. And over here, you need to type your password, the password you want to set on your machine for the root user. So I'm going to type my password, right? And over here, it is showing your machine name. So you can change your machine name as well. So suppose I'm going to my machine name NGINX Ubuntu, right? And after providing your machine, you can see you are getting the create droplet option. If you are not getting this particular green icon, then you need to make sure that you are providing the strong password. Let's create the droplet. It will take some time. We have to wait until this machine will be created. And you can see my machine NGINX Ubuntu is being added over here. And this is the progress bar. This is spinning my machine. Once the machine will be ready, we will get the IP address to connect with my machine. The machine is ready, and over here we are getting the IP on which we can connect to my machine. So I will copy this IP, open the terminal. I will increase the size of my terminal. Team, if you are using the Windows machine, then you need to install some tool by which you can access the Linux machine. So either you can install the MOBA Extreme tool or you can install the Putty, which will help you to connect to the Linux machine. Over here, I'm going to execute a command SSH root @ then define my IP and hit enter. It is asking that I want to show, I'm provide yes. Now it is asking for the password. You need to enter the password you have entered at the time of the droplet creation. After enter the password, hit enter button and see you are inside your machine. Let's clear out the console and type host name, and we are getting my machine name. So over here we are present inside my Linux machine. So you have seen how easy to set up the Linux machine in the cloud. If you already have the free account of the Google Cloud, AWS Cloud or Microsoft Azure Cloud, then definitely you can go with that particular cloud as well. I personally prefer the DigitalOcean because in the DigitalOcean we will get the $100 credit, and it also provides the lowest cost machine in the public cloud. So team, this is the way how we can create the machine in the cloud. In the coming lecture, we will go with the installation of the NGINX. So thank you team. Thanks for your time. Hello team, welcome back. In the last lecture, we have created the cloud machine, the Ubuntu cloud machine. And today we will see how we can install the NGINX on the Ubuntu machine. For this, we will open our terminal and we will connect to the machine which we have created in the last lecture with the help of the IP. So here we are on our terminal and we will connect with the machine with the help of the IP, SSH, root, then you need to provide your IP address. Now I need to provide the password and we are successfully logged in inside my machine. Let's clear out the console. Once you will log in your machine, NGINX installation in Ubuntu is quite easy. Ubuntu by default have the apt package manager, and with the help of the apt package manager, we will download the NGINX and we will see how NGINX will work. But before this, we need to update our apt package manager. For this, you need to execute a command sudo apt/get update. Hit enter, and this will update all the dependencies of your apt package manager. Once the apt package manager will be updated, you need to execute a simple command to install the NGINX with the help of the apt package manager, which is apt install NGINX. In Ubuntu machine, apt package manager by this particular command will install the NGINX along with its dependency. Let's hit enter, and you can see it is asking for the confirmation. And over here we are getting the warning that the following additional package will be installed, right? So it will install these all following packages as well along with the NGINX. So you can see a list of packages are available along with the NGINX if we are going with the NGINX installation. I will press capital Y and hit enter button and installation will be done. So you can see the installation is completed. My NGINX is basically installed on my Ubuntu machine. I will clear out the console And if you want to check that if NGINX process is running or not, so you can execute ps all user detail and executable process on boot. Then put pipe to grep the process, and we want to grep the process of NGINX. So this particular command will show all the processes which are running on this particular machine, and with the help of the grep we are basically filtering out the process which have the NGINX in itself. Hit enter and you can see two process of NGINX is running. One is being running by the root and another is being running by the www.data. The first process is the NGINX master process. User sbin nginx-g daemon on master process on. This was the command which was executed when NGINX process was started on Ubuntu machine. And second process is the worker process. So NGINX by default creating one master and one worker process. This third one is my command itself. If you want to go to the NGINX configuration, you can go to the ls-l etc nginx. Over here you will get all the configuration which is required for the nginx, which is the conf.d and the other configuration file for the nginx. And over here you can see we have the configuration file nginx.conf. Let's open the nginx.conf etc nginx nginx.conf. Hit enter button and here is the configuration file of the nginx. If we will go through this particular file, then over here you can see this have some user www.data, then worker process is auto, then it is running some PID and including some configuration file from this particular library, which is etc nginx module.enabled, right? This should be present over here. So all the modules which by default are present in this nginx will be present at this particular location inside the etc nginx. Then we have the http server, then we have the http send files, TCP no push and other things. Right now you will get some error to understand this particular file, but once we will learn about the configuration, once we will set up the load balancer, once we will go through the custom configuration, you will be much aware with the configuration and you will get to know how we can configure and how we can tune the custom nginx file. Over here we are getting two directory locations as well. Access log is this and error log is this, right? So the log location for the nginx is where log nginx, access log, then error log. If we will go to this particular location where log nginx, hit enter, so you can see we have the two files access log dot access log and error log. Let's clear out the console, put ls again, and let's tail on all these log files. So tail -f asterisk. So right now both of the files are empty. Let's do one thing, let's find out the IP of my machine. So I will execute command if config, and here I'm getting the IP of my machine, although I know the IP of my machine because I used the IP to log in my machine. Once you will find out the IP, let's copy your IP, clear out your console, and again tail all the logs files, which is access.log and error.log. So both of the log files are empty. Now let's go to the browser, and in the browser paste your IP, hit enter, and you will see you are getting the default nginx page on your IP. So how you are getting your nginx page? Because nginx is already running on your machine on port 80, right? If you will go back to the terminal, then you will see you are getting the access log as well, and you can see you are getting the access log as well. That one get call is basically processed on your nginx. If you will again go to the browser and refresh your browser, you will get the multiple logs in the access log file. So suppose we will refresh this 2-3 times, 1, 2, and we will go back to the log file. We'll see we are getting the more logs. But over here there is a one difference, we have executed 3 get calls, right? We have loaded the nginx html page, which is the static page, 3 times. The first time once we accessed that particular page, we was getting the response code 200, but next 2 times when we was accessing the same page, we was getting the response code 304. Why this difference in the response code? So if you will go back to the browser and you will search for the 304 response code, so you can see response code is 304 not modified client redirection response. It means there's no modification in the request and the static page nginx is serving from the cache, not from the main file system. First time when I hit the request, the IP right? NGINX read that particular HTML file from the resource file, but once the resource file was read, it will kept in the NGINX cache, and every time once you will refresh this, NGINX will show you 304 until it will refresh it one more time or clean the cache. If you will go to the logs, you can see every time I'm getting 304, 304, 304. So team, this is the way how can you execute the NGINX, install the NGINX on the Ubuntu machine, and how can you access the NGINX on the Ubuntu machine. If you have any doubt, any question, then please let me know. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training. In recent lecture, we have seen how we can install the NGINX on Ubuntu machine. Today we will see how we can install the NGINX on CentOS machine. For this, first we will go to the DigitalOcean and we will create a droplet of CentOS. So you can see we are on DigitalOcean. One droplet is running, which is NGINX Ubuntu. I will spin up a new droplet by click on this create button and click on droplets. This time I will choose the image CentOS and I will select the version whichever I want. Currently I am going with the latest version 8.2. This is going to the basic plan. I will again create a $5 machine. I will choose any data center which I want. Inside the authentication, I will click on the password and I will provide the password which I want to set as a root password for my machine. Now I will change the machine name and I'm changing my machine name to NGINX CentOS. I will click on create droplet and wait until the droplet will be ready. So you can see droplet is ready and I'm getting my IP. I will copy my IP, go to the terminal, exit out from my existing machine and SSH my new machine. SSH root at the rate and provide my IP address which I just copied. Hit enter button, provide yes, hit enter, and I will provide the password which I mentioned on the DigitalOcean. Hit enter, and you can see right now I'm inside the NGINX CentOS machine. I will clear out the console. So we have seen that we have the apt package manager inside the Ubuntu. Which package manager is available in the CentOS? CentOS have the yum package manager. So let's execute some command yum install nginx, right? As apt is a package manager in the Ubuntu, yum is the package manager from the CentOS. Hit enter. It is downloading something. Press Y. Hit enter. It is again asking for something. Press Y. Hit enter again. It is downloading the dependencies and now it is downloading the nginx module. And the nginx installation is done. Let's clear out the console. And now let's verify is nginx running or not. So we will execute the same command psaux grep nginx. So no nginx is process is running on my CentOS. There is a difference in the Ubuntu. When we have installed the nginx with the help of the apt package manager, the nginx was started by default. But yum package manager is not starting the nginx by default. So how we can start the nginx in the CentOS? In CentOS, whenever yum will install some application, it will add the application inside the services. And to start the service in the nginx, you need to execute a command systemctl, right? Then provide the command start and then the service name. Now if you will check for the process, you can see nginx master and nginx worker process is running. We can also check the status of service in CentOS, and the command should be systemctl status and then the service name. Hit enter, and you can see we are getting the service status. That service is nginx service, this nginx http and reverse proxy server, and service status is active. If you want to stop the service, you can execute this command systemctl stop then your service name. It will stop the service. If we will again check for the status, we will see we are getting the service status is inactive. Let's clear out the console and start the service again. Let's check the status. My service is running. I will identify the IP. Here is my IP. I will copy my IP address, go to the browser, and I will paste my IP and hit enter. You can see I am getting the NGINX default page. You can see the difference in the NGINX UI. Earlier, when we executed the NGINX on the Ubuntu machine, the UI was different, and once we are executing the NGINX on the CentOS machine, the UI is different. Right? So this is the way how we can install the NGINX on the Ubuntu machine and on the CentOS machine. In the coming lecture, we will see how we can install the NGINX with the help of the binary directly. So we have seen the installation. Let's close this. Destroy your droplet which you created for the CentOS. So I will click on destroy and click on destroy this droplet. Confirm. So this will destroy the Nginx CentOS droplet. So thank you team. If you have any doubt, any question, then please let me know. I will be happy to answer your questions. So team, welcome back. Welcome to Nginx training. And in last few lectures, we have seen how we can install the Nginx with the help of the package managers. Today we will see how we can install the Nginx from the source code. There is a reason why we are looking at different kind of installation, because when we are installing the Nginx from the package manager, we cannot include the modules in the Nginx, right? We cannot add the custom modules, we cannot add the third party modules in the Nginx. To include the custom modules or include the third party library, we must know how we can install the Nginx from the source code. So today we will learn how we can install the Nginx from the source code on Ubuntu machine as well as on CentOS machine. For this, first we will go to the DigitalOcean and we will create two droplet, one for Ubuntu and another one for the CentOS. So I am here on the DigitalOcean. I will go to create droplet, and first droplet I will create for Ubuntu 18.04. I will name my machine Ubuntu custom Nginx and click on create droplet. I will create another droplet for the CentOS version. This time I will go with the CentOS and select for the CentOS 8.02, which is the latest version. And this machine I am going to name CentOS custom Nginx. Click on create droplet. We have to wait until both of the machines will be ready. So we can see both of my machines are ready. Now I will log in both of the machines in separate terminal, and we will see how we can install the Nginx from source code in parallel on both of the machines. So team, here we can see I have opened two terminal. On the black shade terminal, I will open the Ubuntu machine, and on the blue shade terminal, I will log in the CentOS machine. First, I will get the IP of my Ubuntu machine. I will type SSH root @ and provide my IP. Provide the confirmation yes, and provide the password which are supplied during the creation of the machine. Clear out the console, and you can see we are in the Ubuntu custom Nginx machine. In the same way, we will go to the CentOS machine on the blue terminal, and you can see over here we are inside the CentOS custom Nginx machine. Very first, on both of the machines, I will update the packages. So in Ubuntu, we have the command apt-get update. Hit enter. This will download all the packages and update all the default packages available on the OS. Ubuntu machine package installation is done. Now I will go to the CentOS, and on the CentOS, to update the packages, we have a command yum update. Hit enter. It may possible that same command will ask you multiple times for the confirmation. So you need to provide the confirmation every time whenever this command will ask for the confirmation. See, it is asking for the confirmation. I will press Y, hit enter. The package installation is in progress. We have to wait. Again asking for the confirmation. I again need to provide Y and hit enter key. Please make sure CentOS package installation will take some time. It may possible it may take around 4 to 5 minutes. Team, it's been 3 minutes and still the microcode CTL is in downloading. So it will take some time. So team, if you're trying to install Nginx on the CentOS and the package update is taking time, don't worry, it will take some time, but it will complete shortly. So you can see the package installation is done on both of the machines. Let's clear out the console. Now to build the Nginx from the source code, first we need to download the Nginx source code. For this, we will go to the browser, open a new tab, and we will search for the Nginx. You will get two websites of the Nginx. First is the nginx.com and another one is the nginx.org. Whenever we are going to download some source code or we are going for some help, definitely we need to go with the nginx.org, because nginx.com is the official business website for the Nginx. So we will go to the nginx.org, and over here we are getting the option download. We need to click this, and here we are getting few options. mainline version which is 1.19.1, stable version which is 1.18.0, and the legacy version which have 1.16, 1.14, 1.12. So we will go with the mainline version, and to download the source code you need to copy this particular link nginx.1.19.1. I will copy this, go to my terminal, and I will execute a command wget and provide the link. Hit enter, and you can see if I will go with ls, you will get a tar file over here. Same code we will download on the CentOS as well. Wget, provide the URL, hit enter, but wget is missing on the CentOS. So we need to install the wget as well. For this, we will execute a command yum install wget. Provide the confirmation, clear out the console, and try to download again. You can see the file is being downloaded. We have the nginx 1.19.1 tar.gz, and we have the nginx 1.19.1 tar.gz. Now we will untar this particular file by a command tar hyphen zxvf, provide the file name, hit enter, right, clear out the console, ls, and you can see file is basically extracted in a new directory nginx 1.19.1. Same thing we will execute on the CentOS as well. zxvf, then provide the nginx file name, hit enter, clear out the console, put ls, and nginx is being extracted over here as well. Now we will go to the nginx directory in both of the directories. Team, I hope I'm showing the installation of both of the machines in parallel. It is not creating a problem for you. You just need to follow the instructions which is required for you. If you want to install the nginx on the CentOS, you need to follow the CentOS instruction. If you want to install the nginx on the Ubuntu based machine, you need to follow the Ubuntu based instructions, right? I'm showing the comparison because most of the instructions are same, just the OS command are different. Now inside the nginx, if we will put ls, then over here you can see we have the configure. Same thing you will find over here. What we need to do to build the nginx source code, you need to execute this particular configure. For this, we will execute dot slash configure. It means execute the current directory, right? Hit enter, and it is saying that C compiler cc is not found. Let's try to execute the configure on CentOS, and we are getting the same error on the CentOS as well, that C compiler cc is not found. It means to compile the nginx code, first we need to download some compiler on both of my machines. So on the Ubuntu based machine, you can install the compiler with the command apt-get install build -essential, right? Hit enter, and this will ask for the confirmation, provide y, and hit enter, and you can see the installation is in progress, right? To install the compiler on the CentOS machine, you need to execute a command yum group install double quotes development tools, right? Hit enter, and you can see installation is in progress. It is asking for the confirmation. I will press y, hit enter, and CentOS will download almost 222 libraries as a part of the development tool installation. So we have to wait until the development or compilation tool installation will be done on both of my machines, Ubuntu and the CentOS. So on CentOS, download is done. It is installing the libraries. On the Ubuntu, it is also installing the man-db library 2.8.3. We can see on Ubuntu based machine, the development tool installation is completed. So we will clear out the console. Right, on the CentOS it's still in progress, so we will wait until the compilation will be done. So team, ultimately you will find that only the OS kind of commands are different for both of the machines. Rest of the part will be same on both of the machines. So library or the nginx is OS independent, that will work same as CentOS and same on the Ubuntu, but the commands and the utility we need to fire regarding the OS, these are different. So we can see on the CentOS as well, the installation is about to complete and it's done. So we will clear out the console on the CentOS as well. Now we will again execute the configure. And first we are trying to execute on the Ubuntu based machine. So you can see this time configure is working and it is basically compiling the code. But it will fail again, right? And it is failing for the PCRE library. If we will execute the same command on the Ubuntu, right? Then It will also compile the code and fail at the same stage. It will ask for the PCRE library. And you can see we are getting the same error that module requires the PCRE library. It means not only the source code are enough, we need to install few more libraries to work with the NGINX. So NGINX comes with two kind of libraries. One is inbuilt library and another one is the third party library. Whenever we will install the NGINX with the help of the package manager, it will install all the inbuilt library and the source code. But over here, when we are directly compiling the NGINX source code, it is asking to provide the inbuilt library as well. So we need to provide the inbuilt library as well. Let's clear out the console on both of the terminals. And first, let's try to download the inbuilt library on the Ubuntu based machine. So on Ubuntu, we will install these libraries. We will install the libpcre3. We will install libpcre3-deb. Then we will install the zlib1g, zlib1z-deb, and libssl-dev and make. PCRE library is required for the nginx, zlib for the gzip, right? And libssh for the SSH connection. Let's hit enter button and it will download all these libraries and it's done. Now, what is the comparative command on the CentOS? How we can install these libraries on the CentOS? For this, you need to execute the same command yum install pcre pcre-devel. Over here, it was pcre-dev. Then we have the zlib-devel openSSL replacement of the libssl. Then we have the openSSL dev and make. Hit enter. It is asked for the confirmation. Provide the confirmation, and installation is done. Let's clear out the console on both of my terminal. Now let's execute the configure again. Hit enter and you can see it is compiling the code and configuration is completed. We are getting an option configuration summary using system PCRE library, OpenSSL library and using zlib library. Let's execute the configure on the CentOS as well. It is compiling the code. Compilation is done and we are getting similar kind of output. It means all the modules which is required for the NGINX are present on my system. Let's clear out the console. But this is not enough to execute the NGINX. We have downloaded the module, but till now we have making the build of a complete NGINX with the help of these modules. For this, you need to provide some extra parameter to the configure command. If we will again go back to the browser, we will go back to the NGINX. Over here we have the documentation. Inside the documentation, we have the second option building NGINX from source. Right, and over here we are getting the different options for the configure. See, if you will execute configure -- help, you will get the different option like which is the prefix path, which is the sbin path, the modules path, configuration path, PID path, log path, group. There's a lot of options available which you can include with the help of the configuration. And what is the use of these options? So whenever we are including some option with the configuration, we are creating the NGINX build with that particular configuration. And whenever we will start the NGINX after this configuration, my NGINX will have this configuration which I'm providing at the time of the building. Let's see. So suppose I'm choosing few configuration options from here and directly inserting in my terminal. So over here, I'm putting this particular command /configure, providing the binary path user bin nginx, because by default my nginx will be installed in the user bin, providing the configuration path. That configuration will be right at the etc nginx and nginx conf. Error log will be at this particular path, where log nginx error log. HTTP log will be at this particular path, where log HTTP logs. And I want to configure this with the PCRE library, adding the PID path, which is the where run nginx PID. It means it's on nginx PID, and I'm building it with the OpenSSL as well. It means with the secure connection. Let's hit enter. It is building my nginx. We have to wait until the complete processing will be done, and this will create the nginx build for you. You can see a make file is basically being created. If we will try to execute the same command on the CentOS, the same command will work on the CentOS as well. And it will also create the make file. The make file is basically being created inside the objects. If we will clear out the console and to compile the code, we will execute make. You can see it is compiling the code. Let's execute the make on CentOS as well. So the compilation on both of the machines will be done in parallel. So right now it is basically compiling the NGINX code plus all the libraries which we have included inside the NGINX configuration, right? Once the compilation will be done, it will create a build and we can install that particular build with the help of the make install. So you can see the compilation is still in progress, and on Ubuntu machine we can see the compilation is done, right? It is leaving the directory root nginx 1, and same is being completed on the CentOS as well. Let's clear out the console. And now to install the nginx, we will execute a command make install, right? What this will do, this will basically install the nginx which is being built by the earlier make command. Hit enter and execute the same on the CentOS as well. Make install, right? And we can see the make install is basically executed on both of my machine. If we will clear out the console and we will execute a command nginx-v, we can see latest nginx 1.19.1 is installed on my machine. Same if we will execute on the CentOS, we will get the same output. nginx 1.19 is basically installed on my machine. Let's try to start the nginx on both of my machine, and to start the nginx you just need to execute a command nginx. That's it, it's done. NGINX, it's done. Let's try to find out the process which is running for the nginx. ps-ef grep nginx, right? Same command I will execute over here as well. We can see nginx master process and nginx worker process is running. If we will execute the same over here, we can see the nginx master process and nginx worker process is running. So team, this is the way how we can install and build the nginx from the source code. If you will find out the IP of your machine, ipconfig or ifconfig, ifconfig, this is the IP of my Ubuntu machine, 130. Hit enter and see we are able to access the nginx. And if I will copy the IP of my CentOS machine, which is .18, hit enter and see we are able to get the same web page. Earlier, once we have installed the nginx in the Ubuntu and the CentOS, then the UI was different on the CentOS, right? Right here you can see the UI is same on both of my machines, right? Why? Because this time I'm not downloading the nginx with the help of the package manager. I'm basically installing the nginx directly from the source code. So the file which is present in the nginx source code, HTML file which is present inside the nginx source code, that is being displayed on both of my machines. So team, this is the way how you can install the nginx from the source code with custom modules on the CentOS and on the Ubuntu. Now let's go to the DigitalOcean and destroy your CentOS machine. Right? I'm not going to destroy my Ubuntu machine because Ubuntu machine we will use in the upcoming lectures. So team, if you have any doubt, any question during this installation, then please let me know. I will be happy to answer your questions. Also, all the commands which we have executed in this particular lecture, they are going to be mentioned in the next lecture as a text direction so that you can follow the same commands in your practice. Thank you team. Thanks for your time. Hello team, welcome back. In the last lecture, we have seen how we can install the nginx from the source code on Ubuntu and CentOS based machine. Today we will see how we can add the nginx as a service in both of the operating system. So ideally the command which we are going to execute today and the process which we are going to follow today will be similar on Ubuntu and CentOS based machine. There is no difference. So we will execute this particular lecture on the Ubuntu based machine. But the question is why we want to add nginx as a service on the operating system. So let's start with. So we are going to add the nginx as a system D services. But first we need to understand what is the system D services and what are the services in Unix and Linux based systems. So team, in Ubuntu 15.4 above and in CentOS 7.0 above, we have the support of the system D services. And system D services will help us to make the process more resilient. When I'm saying make the process more resilient, what does it mean? It means whenever you are executing any process as a service, and due to any reason if that particular process is going to crash and that particular process is going to exit, in that case service will recreate that particular process or service will restart that particular process. Also whenever your machine is going to reboot, right, your process will be auto recreated after the reboot. If your machine is going to power off, power on, then once the machine will be power on, your process will be auto created. So why we need NGINX as a service? Because NGINX is a web server, that is the front end server for your web application. Whenever user hitting the request, that is being responded by the NGINX. If NGINX process is itself down, then your complete environment will be down, because your front end is not accepting any more user request. So we need to make sure that the front end process of my production system should be more resilient. For this, we will add the NGINX as a service. So due to any reason, if NGINX process is going to crash, NGINX process is going to exit it, that process will be recreated by the service. And due to any reason, if machine is going to reboot, or there is a scheduled maintenance by which the machine is going to power off and power on, then once the machine will up, right, the process will be auto created. It is required because we don't know when the machine is going to reboot. And after the reboot, if process is not coming up, right, then somebody needs to manually start that particular process, and it may simply increase your downtime on your production environment. So we will add the NGINX as a service so that we can make the NGINX process more resilient in the production system. Now let's see how we can add the NGINX as a service. For this, we will go to the terminal and log into my Ubuntu machine. So here we are on our terminal. We will go to the DigitalOcean and copy the IP address. And now I will SSH my machine. Provide the password and we are inside the machine. Clear out the console. And let's check if the process is running, which we have executed in the last lab, right? And the NGINX process is running. If we will go to the IP, ipconfig, open the browser, paste the IP, and NGINX is running. Now let's see what will happen. We will go to the terminal and we will reboot my machine. Hit enter. This will reboot your machine, right? You can see the connection is lost and we need to reconnect my machine after some time. So just wait for 1 to 2 minutes. It will enough to reboot the machine and then we will connect the machine again. I hope machine should be rebooted. Now I will again SSH the machine, put the password, clear out the console, and you can see we are inside the machine. Let's check the process again. And you can see NGINX is not running. If we will go to the browser, refresh this browser, the NGINX process is being killed. It means the process was running, due to some reasons my machine go in the reboot and now process got killed. So to make the production server up, I need to start the process again. I need to start my front end server. So to make the process more resilient and to avoid these kind of bottlenecks, we will add the NGINX process as a service. For this, we will open the browser and go for the NGINX init script, right? Type the NGINX init script, hit enter, and you will get a web page NGINX init scripts. Let's open this web page. On this web page, you can see we are getting the different init script: upstart, systemd, FreeBDS, OSX, Windows, right? So we are talking about the systemd. So we will open the systemd services, this particular link. Over here, you can see it is being listed the supported system: Fedora, OpenSUSE, Arch Linux, Ubuntu tested, Fedora 16 and 17, Ubuntu 18.04. Then we have the location, at which particular location the service will be created, and over here we are getting the file. So what you need to do, you need to create this particular file nginx.service at this particular location, libsystemd system, right? And copy this particular content in this particular file. That's it. That's the only work we need to do to keep the nginx as a service in my operating system. So I will copy this particular path, go to my terminal and create this, touch and paste this particular path. Now let's open this particular path as well. Vi and this particular path, libsystemd system nginx.service. Hit enter. I'm inside the Vi mode. Press I to go into the insert mode. Let's go back to the browser again and copy this complete data and paste it here. But over here we need to make some changes. You can see the part is description, after wants, type is forking, and over here we have the process ID. But if you remember, whenever we have configured our nginx, my process ID was not present directly inside the run. My process ID was like var/var run nginx.pid. Inside the pre-start, it is providing the pre-start path of the nginx with the -t, which will check for the configuration. And over here as well, we need to change something. In my case, nginx is installed inside the user bin, not in the user s bin. So I need to update this path as well, and same path I need to update inside the execution start user bin nginx. So see, we have the type, we have the PID file, right, which is the process ID. We have the start pre command, which is -t to check the configuration only. Then we have the execution command, which is user bin nginx, right? You also need the same command to start the nginx. Then we have the reload, right? And reload have the -s reload. We didn't discuss about the -s and the other functionality like reload. So with the -s, you can provide the signal to the nginx. Whenever nginx process is running, you can send a signal to that particular process. Shortly I will show you how we can send the signal to a process. Then we have the stop, and inside the stop we are basically quitting the main process id, right? And then we have the install type, which is multi-user dot target. We will simply press escape colon wq to save this particular file and hit enter, right? Let's check if the nginx process is running. Nginx process is not running. Let's start the nginx process to check the signal. You can see I have started the nginx. If I will check, then nginx is running. Now let's type nginx -h, and over here we are getting the -s. It is the signal, and we can send these signals to the master process, which is stop, quit, reopen, and reload. Over here these two, stop and reload, are the most usable signals. Stop will stop the nginx process, and reload will reload the nginx configuration, right? It will reload the running process configuration in the nginx. What does it mean? It means if you have updated the nginx configuration inside the nginx.conf file, right, until you will reload that particular configuration, nginx will not count that particular change in the nginx process. Once we learn about the configuration, I will show you the complete use of reload, right, with the practical example and with the real life challenges of the reload. Right now we are just discussing that these are the signals which you can execute on the master running process of the nginx. So let's stop the nginx -s stop, right? We have sent the stop signal. Let's verify the process, and nginx is not running. So we have added the nginx as a service, as a file. How we can start the service? To start the service, you need to execute a command systemctl. Then the operation you want to perform, I want to perform start, right? And the service name, in my case, my service name is nginx. Hit enter, and that's it. Nginx process is basically started. If you will find out, you can see. You can also identify the service status using the another command systemctl status, then the service name. Systemctl status command will show you the status of any service which is running in your operating system. If you will hit enter, you can see that nginx service is running. This is the main process id 1103c. Over here we are getting the main process id, and this is the child process id. This is the configuration file etc nginx conf, right? Status is okay. etc nginx conf test is also successful, and then we are getting started the nginx http reverse proxy server, right, which was the description of my service. And over here we are getting the time as well. So if you will restart the service, so suppose I am going to restart the service by a command, so I can execute a command systemctl restart nginx. I will again check for the status. The service is up just 2 seconds ago. So we have added the nginx as a service. Let's clear out the console. Now let's do one thing. Let's go to the browser and refresh your web page. So nginx is running. Let's go back to the terminal. So earlier in this lecture we have mentioned that if we will edit the service and we will reboot the system, that service will be automatically up. Let's see if it is happening or not. So ideally after this particular instance this will not happen, but I will show you. I will execute the reboot. I will wait for a few seconds to reboot the machine. In the meantime, if I will go to the browser and refresh my web page where the nginx is running, we can see it is not able to communicate with the nginx. It means machine reboot is in process. Once the reboot will done, we will again go back to the machine and we will see the status of my service. Let's try to SSH the machine again. Enter the password. So machine reboot is done. Let's clear out the console and identify the service status. Ideally, As per our statement, that should be okay and it should be in the running mode, but you will get it node loaded. It means just adding the file is not enough to take care the boot power off power on sequence for the services. It means we need to take care few more things. And what are these things? So let's start the NGINX first. NGINX is started. Let's verify the status. NGINX is running. And now to take care the reboot machine power off power on sequence, you need to execute one more command, systemctl enable then service name. Right? This is my service name. Hit enter. And you can see this basically has been created a symlink. This is the symlink which is being created inside the etc systemd system multi-server target NGINX service and this particular file which we just added. Now if you will go to the browser, refresh this, NGINX is running, go back to the terminal and reboot your system. Right? Let's wait until the reboot will done. We will again connect with the system and we will see if this time NGINX service will automatically come up or down. So I will clear out the console. So I will connect to my machine again. Right? You can see we have connected the machine after the reboot and let's check the NGINX status. Hit enter and see NGINX is running. So my process is already being taken care after the reboot as well. Now if you want, you can power off your droplet, you can power on this droplet, you can multiple times reboot this particular machine. Your service will be automatically come up whenever the operating system is up. So this is the way how we can make the NGINX process more resilient as compared to the static process or manual start process by adding the process as a service in the operating system, and adding that particular service is a auto start service on the system reboot. And team, these are the basic concepts, but they help very much in the production environment to make the system more resilient and more available. So thank you team, thanks for your time. Hello team, welcome back. Welcome to NGINX training. In this section we will learn about the HTTP protocol. Whenever we are working with the NGINX and NGINX is a web server, so we should be aware that how HTTP protocol work, what could be the components of the HTTP protocol, and how we can make sure that the HTTP protocol is working and we are getting the traffic from web server to the client. So first we will discuss the types of the protocol. We will see what are the type of protocols are available and why the protocol is required for the communication. So let's start with. So first let's discuss the protocol. So protocol is a digital language through which we communicate with others on the internet. So let's understand this with a simple example. We are human and our population is about 7 billion on the earth. We have the different countries and each countries have their own specific language. Some are English native, some are Spanish native, some are Russian native, some are Hindi native, some are Sanskrit native, some are Urdu native. So each community have their own language and with the help of that particular language, they can communicate to each other. The communication is only possible when you know the same language which the second person is speaking. So if you are American and you are talking to some Japanese, then the communication between the Japanese citizen and the American citizen only possible when both they are know either Japanese or English or some other language. If American know only English and Japanese know only Japanese, then communication between these two persons is not possible. Protocol is that particular medium which will set up the communicate. So you can understand in layman term, you can call the protocol as a language. So protocol is a medium which is a digital language through which multiple machine can communicate over the internet. So if we will go with the book definition, protocol meaning is that it is set of mutually accepted implemented rules at both ends of the communication channel for proper exchange of the information. In the computer terms, we have the channels to set up the communication, right? And as a part of the communication, we will transfer the data. That transfer will have some rules, that transfer will have some checks, that transfer will have some limitations. So protocol is something which is a mutually accepted implemented rule on both sides of the communication channel for the proper exchange of the information or data. Each protocol is defined in different terms and different use with the unique name. In the computer terms, we have the multiple protocols and each protocol have their own use, right? Message travel from sender to receiver by medium using the protocol. Whenever we are sending the message from one machine to the another machine, where one is the receiver and another is the sender, that medium is basically is being called protocol. One of the most common and known protocol example is the HTTP that is used over the World Wide Web. So whenever we are talking to internet, whenever web servers are talking to each other, the protocol, the communication which is happening between the web server is the HTTP protocol. HTTP protocol is the top layer front end application protocol which will present at the top of the OSI layer. So over here I'm listing out few protocols, then we will discuss about the core functions of these protocol. The first is the transmission control protocol which we call TCP. Then we have the internet protocol which we call the IP. We have the user datagram protocol which is called UDP protocol. We have the post office protocol which is called POP or POP3 protocol. Then we have the simple mail transfer protocol which is basically being called SMTP. Then we have the file transfer protocol which is called FTP, and we have the hypertext transfer protocol which is called STTP. And the another one is the hypertext transfer protocol secure which is called HTTPS, which is the secure version of the HTTP protocol. So these are the main top protocol which we generally use in the internet terms, right? Although there are few other protocol as well, but these are the main protocols, and I hope you have heard about almost all of these protocol in your career. So let's discuss about one by one. So first, what is the transmission control protocol? What is the TCP? TCP is the popular communication protocol which is used for the communication over a network. So whenever you want to communicate over the network, you want the TCP protocol. So what TCP will do? Whenever the communication is happening with the TCP, TCP will divide the message into the series of packet, right? And then send from source to destination. And at the destination, it will again reassemble the packet and create the complete message. This is the second top protocol of the OSI layer. The first one is the HTTP. Then we have the internet protocol. Internet protocol is the third top level protocol after the TCP of the OSI layer, which is working with the TCP. The TCP and IP both works together. Whenever we are sending the traffic from the TCP, the IP protocol or IP address in the packet helps us routing through the different nodes in a network until it will reach to the destination. So whenever the traffic is being sent and the protocol is being used as a TCP, IP protocol will help the TCP to identify the destination, right? Because whenever we are sending the traffic, it will go through multiple nodes, right? So we need to make sure that which particular node that particular packet should be delivered. So IP protocol and TCP protocol works together to set up the communication. Next one is the user datagram protocol. User datagram protocol or the UDP protocol is basically substitute communication protocol. That is the substitute communication protocol of the TCP. It has implemented primary for the creating low stall rate and low latency linking between the different applications. The UDP and TCP both work in the similar manner, but UDP is the substitution of the TCP. Although TCP is mostly used and more successful over the UDP protocol, but still if you want some low stall rate and low latency, definitely you need to go with the UDP protocol. Then we have the post office protocol, which is also being called POP and POP3, which is designed to receive the incoming emails. The SMTP is again for the email, which is being used to send and distribute the outgoing emails. If you are working on the enterprise application and you have some web application which have some functionality like forgot password or which have functionality like subscription email, then definitely you are using some SMTP server. And on that particular SMTP server, you have configured the SMTP protocol to distribute and send the emails to the customers. Then we have the FTP, which is very famous protocol which will be used with the LAN wires, right, to transfer the files from one machine to the another machine. And then we have the mostly used and OSI top layer protocol which is called STTP protocol. STTP is basically work on the client server model. STTP used to making the connection between the web client and the web server. HTTP shows the information on the web pages as well. So whenever we are talking about the web, whenever we are doing something about the web, definitely you need to make sure you are using the HTTP protocol. HTTPS is the secure version of the HTTP protocol. Whenever you will open some website, if you are going with the Facebook, you are going with the Twitter, you are going with the YouTube, you will see that in the address bar you will enter a address like https://facebook.com. That https is the secure protocol, right? Some websites support both http and https, right? But 90% good websites are using https only because https is more secure over the http protocol. And the only difference between the HTTP and HTTPS, that whenever HTTPS is being used, the data which is being transmitting over the network, that is being encrypted with the HTTPS. So thank you team, that's all about the protocol. These are the protocols which are available for the communication between the different machines. So thank you team, thanks for your time. Hello team, welcome back. Welcome to NGINX training. And today we will discuss a bit about the HTTP protocols. What is the HTTP protocol and what is the working model of HTTP protocol? So let's start with. So as we are aware that HTTP protocol is the top level protocol of the OSI layer which is being used for the web communication. And if we will go with some book definition, then HTTP is an application level protocol for the distributed collaborative hypermedia information system. And definitely this is distributed collaborative and the hypermedia information system because we are working on the web. Web client is sending the request to the web server, and the request which is being sent from the web client to the web server, that is the HTTP protocol request. That request will contain a lot of things, that request will do a lot of things which we are going to discuss shortly. If we will go with the internal model of the HTTP protocol, then HTTP is a TCP IP based communication protocol that is used to deliver the data, and data could be the HTML files, image file, query result, media files on the World Wide Web. So internally HTTP protocol is also using the TCP IP model but in some different architecture, in some client and server architecture. HTTP specification specify how client request data will be constructed, sent to the server, and how server respond these requests. So whenever we are trying to submit the connection between the web server and the web client will create and form some request. That request will have some standard format, so that we can make sure that always whenever I am sending the request, that request have some necessary information, that request have some defined format so that server can understand that particular request. Once server will get the request, it will process the request and send response back to the client, and that response is also well formatted. That response will also have some formation, some data which is being sent as a response of a request, so that web client know that it is the response of my request and it will display to the user. The basic features of the HTTP request is like HTTP is a connectionless. So let's try to understand why HTTP is a connectionless. HTTP client or the web browser initiate an HTTP request, and after a request is made, the client waits for the response. So let's try to understand with some examples. So whenever we are hitting a request, whenever we are, suppose you will go to the browser and you will enter the URL of a particular website. So what you are trying, you are basically opening that particular website. The client in that particular case is your web browser, and the web server is the website's web server, right? So you are basically firing a request to the web server. Once you will hit the URL, you will see on the browser, you will get the progress bar. That progress bar is basically waiting for the response. So once you will hit the request, what will happen next? The server will process the request and send response back, after which the client disconnect the connection. It means once you will hit the URL, server will process your request, it will send back the response to the browser, and after that particular response, server will disconnect the connection for that particular request which is being made by the browser. So client and server knows about each other during the current request and response only. Further, that particular request will be processed. There is no communication between the client and server, that is called connectionless. It means request is being sent, that is being processed by the server, response is getting returned back to the client, right? So the connection between the client and the web server was present for that particular time only whenever the request was being processed. Once the request will be processed, server will disconnect the connection and there is no connection between the browser and the web server. HTTP is a media independent. That is the another thing. You can send any kind of data as a HTTP protocol, right? The only condition is both the client and server must know how to handle that particular data. You can send the text data, you can send the HTML data, you can send the JSON data, you can send the stream data, you can send the media data, right? Any kind of data communication is possible with the help of the HTTP protocol. The second one is the HTTP is stateless. What does it mean? It means the server and the client both know each other during the current request only, and after that both of them forget about each other. Due to this nature, the protocol, neither the client nor the browser can retain information between the different requests across the web page. It means a connection is being set up between the requests. So if you are hitting 10 requests from browser to the web server, then 10 requests, then 10 times the connection will be created and 10 times the connection will be destroyed. So we can understand now, if 10 request is basically being made by the web client, that is being served by the web server, right? And now if the request want to know the status of each other request, right, then this is not possible, because each request have their own connection and they don't know about the another request. So it means HTTP is a stateless as well. It is not maintaining the state of the requests. This is the basic architecture flaw of the HTTP communication. Whenever you are hitting the request from the web client, that could be your web browser or some other tool, right? And that request is the HTTP protocol. Request will be processed by the web server. Web server will accept that particular request. It will identify the URI and the parameter which is being sent in the request, right? If there is some kind of server side script required, it will execute that particular script. It will do their processing and send response back to the web client, so that whenever you are hitting some URL, you are getting the web page. So let's open the browser and let's see what we are trying to explain. So we are on the browser. Let's open some websites. So suppose we are going to open the youtube.com. So you can see we are hitting a particular YouTube. Now this particular spinner is being spinned, right? Once the page will load completely, spinner stopped. It means using my browser, whenever I will hit this particular URL, and you can see this is using the HTTPS protocol. This request is basically submitted from my browser. Request is being processed by the YouTube web server, and this is the page which I am getting on the YouTube. This page is dynamic page, right? This is not a static page. It may possible if I will refresh this page will be changed. It may possible, and see, the videos link is basically changed. Earlier there was some other video, right? There was some other video, there was some other video. If I will again refresh it, it may possible that it will change again, and yes, it's changed. So the content which I'm getting over here is the dynamic content that is being basically processed by the Google server. So although I'm hitting the same request from my web browser, but due to the application nature, web server is basically sending the different response every time, right? It means the architecture which we was discussing, we are sending the request, web server is processing the request, then web server every time executing some server side script, going to the database, fetching some data and representing to the user, sending the response back to the user. So that is the same architecture which we was discussing over here. For the static website which have the static web page, web server always return the same web page, that is the static content. But for the dynamic website, web server will execute some server side script, get the data and return the response back to the user. The all communication which we have sent between my browser and the YouTube web server is basically happened on the HTTPS protocol, and this is the way we simply hit the request, we will get the response. We hit the request, we get the response, right? So that's all about the HTTP protocol, team. If you have any doubt, any question, then please let me know. Thank you, team. Thanks for your time. Hello, team. Welcome back. Welcome to NGINX training. And today we will see the request types of the HTTP protocol, right? So we will see how many request type do we have in the HTTP protocol and what is the use of each request type in HTTP protocol. So team, as we have already discussed and we are aware that HTTP request is basically being sent by the client to server to get the data, right? So whenever we are saying that we are sending the request, then that request must have some component, and on the basis of these component, the web server is basically processing the request. So we are going to discuss about these component, that what are these component and what is the use of these component and what is the purpose of these component for the web server. So whenever HTTP client is sending the HTTP request, that request is basically being sent in the form of the request message, and request message contains the below property. The first is the request line. So whenever we are sending the request to the web server, we are sending the request in the form of the request message, and the first property of that particular request message will be the request line. The next property will be the zero or more headers. It means after the request line we will send the headers. Header could be the number of headers or zero header. After the header we have an empty line which will indicate that header fields are basically ending over here. and then we have the optionally message body. It means request have the four part. First is the request line, second is the header, after the header we have the one blank line, and after that we have the request body, which is required whenever we are sending the request, right? So body is optional. Some HTTP request accept the body, some don't accept the body. So we will discuss what is the request line, what is the header, and what is the request body shortly. So request line begins with the method token followed by the request URI and the protocol version. So the first line of the request body is the request line, and request line construct with the three properties. The first is the method token, the second is the request URI, and third is the protocol version. So let's discuss about the method token. HTTP protocol have multiple methods like get, post, put, delete. We will discuss about it. The request URI is something which is the resource path, and the protocol version is the version of the HTTP protocol which you are hitting. So let's go to the browser and I will show you what I'm trying to explain. So over here what we will do, we will open the F12, and with the help of the F12 we will open the network tag. After this, what we will do, we will open the NGINX Web Server which we are running on our machine. So we are running on machine like 133. So this is the IP of my machine on which the NGINX is running. I will hit this IP. See, the NGINX web page is basically being loaded, and over here in the network section you are getting a one call is being made. The status code is 304, type is the document, and this is the complete information about this particular request. So here inside the network section you are getting the request information. This is the request which is being sent. See, over here we are getting the one request, 180 byte is transferred, 612 byte is resource, and finish time is 446 millisecond. This is the DOM content loaded type of request. So by this particular way, using my browser which is a web client, I have hit a HTTP request on my web server which is running on my IP 104.131.80.130. This is the NGINX server which we are running on our Ubuntu machine. Here is the request. Let's click this particular request, and you can see this is the request URI which is HTTP based call, right? The request method is the get, which I told you. Here is the status code, we don't need to worry about it, and the referer policy, we don't need to worry about it. Let's go to the request header. Inside the request header you can see we have the header which is accepting the text HTML, application HTML, application XML, image web, image PNG, JPG, application signed exchange, and the other things as well. Encoding is the Gzip, accept label is the ENUS, connection is keep alive, this is the host which I am hitting, and this is the modified request and the other parameter of the request. So team, this is the request what I am hitting. So over here what is the request URI? Request URI is a get method. Then we have the slash resource path. It means we are hitting the slash resource path because we don't have any resource after that particular path. And the protocol what I am hitting is the HTTP protocol. So this is the complete request URI. In my case the method was get, right? The request URI was the slash path, and protocol was the HTTP. So this is the request line which could be the first in HTTP request. Then we have the request method, and we have the multiple request methods in the HTTP protocol. Let's go with the request methods. The first method is the get, and whenever you want to retrieve the data from the web server, you always use the get, right? Whenever we are not changing anything, whenever we are not sending a body in the request, we are using the get method. Get will always use to retrieve the data from the web server. Other one is the post. So post request used to send the data to a server. Whenever you want to modify some data, whenever you want to submit some data, you will use the post, right? You can take an example. Whenever you are putting some comment on a Facebook, right? So you are sending some data to the Facebook server. That request is a post request which will have some body, right? And in that body it will contain that who is sending the request, from where that particular request is being sent, on which post that particular comment need to be submit, and what is the content of that particular comment as well. With the help of the post, you can update the customer information, you can update any data on the server, you can upload the file, and you can submit any kind of data modification on your web server, although the web server must accept that particular request. That will understand the formation, and the client should be the authenticate client who is sending the request. Then we have the put and post are both similar. They both are used to change the data on the server, but put replace the current representation of the target resources with the uploaded contents. It means whenever we are adding some modification, we are submitting the put request. Generally developers avoid to use the put, right? Most of the, in case of the put as well, developers are still using the post request to submit the data. Then we have the delete, and delete will be used to remove the representation from the web server which is being defined inside the URI. Delete will also not accept any body. You just need to define the complete resource path which you want to delete, and HTTP protocol will delete that particular resource from the resource path. Then we have the connect, which is establish a tunnel between the server, identify the given URI. So whenever you want to make the connection with your server with the help of your application code, you will use the connect, right? So these are few methods which you can use: get, post, put, delete, and connect in the HTTP. We have discussed about the method, we have discussed about the resource URI, and we have discussed about the HTTP protocol version as well. This is going to be the complete request line for your HTTP request. So let me try to open the browser and let me show you the what is request URI. So over here, let's close this terminal and I will open some websites. So suppose I will open YouTube, right? This is the YouTube web page. Now if I will click over here my request URI is slash path only, because I am hitting the root resource of my web server. Whenever I will go some specific things, suppose I'm going with the trend, I will click on the trend, right? So over here I'm getting the trending videos. Now inside the URL you can see you have some other fields, slash feed slash trending. That particular thing which is being added in the base URL is called the resource URI. This time you are hitting this particular resource URI on the YouTube web server. Although the request is still get, but resource URI is being changed, so that data is also being changed. We are sending extra parameters in the request, and the change is resource URI. If we will go to some other things like subscription, then resource URI is basically again changed. Now the resource URI is feed and subscription. So team, this is called the resource URI, which is being appended in your URL after the host URL. Same thing is applicable with any website which is sending the static page or the dynamic page. In many websites you have the forgot page, about page, contact us page. So these are the resource URI for that particular websites, right? So team, if you have any doubt, any question, then please let me know. I will be happy to answer your question. That's all about the component of the HTTP protocol. Thank you team, thanks for your time. Hello team, welcome back. Welcome to NGINX training, and let's discuss about the last lecture of the HTTP protocol, which is HTTP response code. So whenever we are submitting the request, how do we know that particular request is basically processed, that request is basically pending, that is successful, that is rejected, or what is the status of that particular request? That all things we got to know with the help of the response code. Whenever we are submitting the request, that request is being processed, right? We will get the response from the web server, and in that particular response we will also get the response code, and on the basis of that particular response code a lot of further processing will be done. So let's see what are the response code and what response code are possible in the HTTP protocol. So as I told you, response code define the status of the request. That request is basically processed, succeed, declined, dropped, rejected, fulfilled, not fulfilled. Response code defines the status of the request for which the response is basically retrieved. Response code or the status code element in the server response is a 3-digit integer where the first digit status code defines the class of the response. So HTTP response code is the 3-digit integer, and in that particular response code the first digit define the class of the response. It means we will have the multiple classes of the response. If we are getting the response code in terms of 1.00, 101, 102, 104, it means 1x and x. It means the response is an informational. It means the request has been received and process is continue. Web server is telling us whenever you are hitting the request, you are getting the response in terms of the 100. It means that particular request is basically accepted by the web server, and web server is processing that particular request. If the Response code category is 2. It means we have 201, 200, 203, 204, 205, 208, 213. It means that request is basically successfully received, understood, and accepted. Right? Server has accepted that particular request, it has understood your request, and that request is successfully received by the server. If we have the response code 304, 302, 301, 300, it means 3, right? The first character is 3. It means the request is basically redirecting to some other servers. Request redirection is happening. So it means further action must be taken in order to complete the request. That request is still not being completed. And the last one is the 4, which is the client error. It means if you are getting the response code and that contain 4, 404, 402, 401, 400, right? It means request contains incorrect syntax and cannot be fulfilled. The request, the HTTP request is you are hitting from your web client to the web server. The web server don't know any kind of that particular request, and that request is can't proceed further. The next is and last is 5xx. If we are getting 5xx request, it means that is the internal server error or server error, right? Which means the server cannot fulfill your request although the request is a valid request. So the difference between 4xx and 5xx is in 4xx the server is not accepting your request, it don't know the request, right? But in 5xx server is accepting the request is valid, but it cannot fulfill the request. These are the response code which you have seen multiple times in your daily to daily life. Sometimes you will get the internal server error, that is the 500. You will get 404 page not found, that is the client error. 401 unauthentication, 400 access forbidden, 403 access forbidden, right? These are the very common response code. 201 resource created, 200 resource successful. These are the common response code. If you want to see, I can show you. Let's go to the browser. Let's press, after opening the browser, let's press F12, and suppose I'm going opening yahoo.com. Hit enter, and you can see it is opening the yahoo.com. We have to wait until the complete website will be open. Over here you can see total 402 and 403 requests are basically submitted from my web client whenever I hit this particular yahoo.com. Let's go up in the network section. The very first I have submitted yahoo.com, that is being redirected, right? The status code is 301. It again redirected to the yahoo.com, it again redirected to the www.yahoo.com, and then it will go with the US, and then we have the 200. It means first three call we are getting 3 series, right, which is the redirection. Then we are getting 2 series, every request is 200, which is the request successful. We are getting all request 2, then we are getting some 3 series. So over here you can see we are getting the request and the response code of each request. So whenever you are submitting the request, and if you will open any request, suppose I will open the first one. See, this is the request URL, what I hit, this is the method, what I post, and this is the status code 301 moved permanently. So with each request, whenever you will get the response, you will get the response code as well, right? You will get the status code as well. And that status code will inform you about the status of the request which you have made with the help of the web client on the web server. So we have the multiple response codes, but these codes are basically categorized on the basis of the first digit 1, 2, 3, 4, and 5. So whenever we are hitting the request, we need to make sure that what is the response code we are getting on the response of that particular request, so that we can further process our processing. So this is about the HTTP protocol, team. If you have any doubt, any question, then please let me know. Thank you, team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training. This is a new section. Here we will discuss about the NGINX configuration. NGINX configuration is a very important and necessary part of the NGINX web server, because all kind of configuration which you want for your NGINX web server, that belongs to the nginx.configuration file. In simple words, you can also assume NGINX configuration file is the heart of NGINX web server. So in this section we will learn about the NGINX configuration, the changes which we done in the NGINX configuration, and the impact of these changes on the NGINX web server, and how we can customize the NGINX web server for our use. But before proceeding further, we need to understand the terminology of NGINX configuration. NGINX configuration file, it appears to be organized in a tree-like structure defined by a set of brackets. So whenever you will open the NGINX configuration file, you will find a tree-like of structure in the configuration file, and the complete file is basically being defined with the set of the brackets. So let's go to the terminal of our machine and let's see how nginx.configuration look likes. So here we are on our terminal. We will log into the server where we are executing the nginx in the droplet. So we are logged in our server. Let's see if nginx process is running hyphen, and yes, nginx process is running. So let's go to a location etc nginx, put ls, and over here you will find a file nginx.conf. This is the configuration file for the nginx. Let's open this particular file. I will execute a command cat nginx.conf, and here we are getting the content of this particular file. So you can see this is the starting of the file, right? Over here we are getting the different blocks like events, then we have the http, and each block have the curly braces definition. See, so the configuration file follow the tree structure, and the scope of the elements in the configuration file is defined within the curly braces. The block section or the area which is defined the curly braces is called the context. Context is an important word because when you will go through the nginx documentation, you will find this particular word multiple times. So you need to make sure that what is the context in nginx.configuration. So a complete block which is defined within a curly braces is called a context in the nginx configuration, and in the nginx configuration we can have multiple contexts. Context can be layered within one another. It means in the nginx configuration we can have the multiple context within one another. As I told you that nginx follow the tree based structure, so you can have the parent child relationship or multiple child relationship in the nginx.configuration file within the contexts. The specific value which is defined in the context is called the directive. So we have the context and we have the directives. These are the two words which we need to focus on, because when you will learn about the nginx documentation you will get the directives and the context, and we need to make sure that what is directive and what is context. Over here I am attaching a sample file of the nginx configuration, right, where we have the server context, and server context is starting with a curly braces and ending with a curly braces. Within the server context we have the another context location, and we have the two context of the location. See, first context of the location is basically pointing to the root html, and second context is basically pointing to the 50x.html. They both are the context, and within the same context you can have the child context, and these child context can also be repetitive with the different set of values. Now what is the directive? Directive is anything which is defined in the form of key value pair. Over here you can see we have the multiple directives. So over here listen 80 is a directive for the server context. Server name localhost is the another directive for the server context. Index space index.html space index.htm is the directive for the location context. If we will go to the second context of the location, then root html is the directive for the another location context. So the line which is being defined inside the configuration file in the form of the key value pair, that is the directive, right? And everything which is defined between the curly braces, that is called the context. We can have the multiple kind of context inside the nginx configuration file. Let's discuss about these as well. The first and global context is called main context, right? This is the most general context, main or global context. It is the only context that is not contained any typical context block. It means main context is the global context which also don't have any curly braces blocks. So if you will go to the terminal, then over here you can see the data which is defined over here before the event context is called the global context. So this hash user nobody worker process one error log error log error log pid, these are the global context for your nginx configuration file which is by default created in your server. Right now most of the things are commented, only worker process is one. We will discuss about it. We will discuss in very details about the global context and the impact of the global context. The main context represents the broader environment for nginx configuration. It is used to configure detail that affect the entire application on a basic level. It means every directory which are you defining inside the main context that will impact your application at a environment level. the complete NGINX will be impacted by that particular directory which you are defining inside the global context, because that will apply on all other child contexts. Some common details that are configured in the main context are user and group, run the worker processes, right, number of the workers, and file to save in the main process ID. So these are few common and global things which you can define inside the global context. You can define the user which you want to execute the NGINX process, the group to which particular group that particular user will belong, the number of worker process, the number of worker connections, right, the location of some main files which your NGINX are writing, right, and the process ID of your NGINX as well. So team, if you want to insert some global thing which will impact your complete NGINX environment, you need to insert that particular directive inside the global context or the main context. After the global context, we have the events context. The event context is contained within the main context and is used to set global options that affect how NGINX handle the connection at a general level. Within the event context, you will define that how NGINX will manage the connection, either their connection to the NGINX worker process connection or NGINX main process connection. And this is the child of the main context. NGINX use an event-based connection processing model. So the directive defined within the context determine how worker process should handle the connection. We will discuss about in quite details when we learn about the event context. Right now we need to understand that event context is the child of the main context, and in the event context we need to define the number of worker connections within the NGINX. Then we have the main context which is called HTTP context. Generally, if you will find out any NGINX configuration file, this is the context which will be the lengthiest context in the nginx.configuration file, because this context will contain all the directives and the other necessary context to define how program will handle the HTTP and HTTPS connection. Handling the HTTP and HTTPS connection are the primary concerns of the NGINX Web Server. And all the settings, all the directives, all the context which is required for the HTTP and HTTPS connection, they must be within the HTTP context. So if you will go to the terminal again, over here you can see here we have the HTTP context, right, which will have some directives. Over here we have few other directives. Then this have the another context server. Server have the another context location. This have the another context, another location. Then we have the another context location, although this is commented. Then over here this particular server context is basically closing, and we have the another server context. We have the another server context for the HTTPS, and over here my complete HTTPD context is closing. So HTTPD context is the longest and lengthiest context in the NGINX configuration file, which will contain all the directives plus all the context which is required to handle the HTTP and HTTPS requests. HTTP context is a sibling of the event context, so they should be listed side by side rather than nested. HTTP and event context are the sibling context, right? So you cannot include the HTTP context within the events. They should be defined at the parallel level. Within the HTTP context, we have the another context which is called server. This context is declared within the HTTP context, and user can have many server blocks as you need, and each of which can handle the specific subnet of connections. Within the server context, you need to define the virtual host, that which kind of request will be delivered to which file system and which virtual host will handle which kind of request. This is the main context which will be useful in the load balancer. We'll discuss about the server context in quite details. Right now you need to understand that the server context is the child of the HTTP context, which will be used to define the connection handling for a specific subnet or a specific virtual host. Then we have the location context. Location context is live within the server context, and unlike the server context, you can have the multiple location context within each other. It means location context can be nested within the location context as well. You can define the multiple location context within the location context as well, and each location context will have the specific location for the traffic. And the location context is more general location context to catch the certain subset of traffic. Then further processing is based on more specific criteria and additional context inside. Within the location context, you need to define that which virtual host will serve which kind of traffic, right? And you have the nested virtual host, then definitely you need to create the nested location context. We learn about it in quite details right now. If you're not able to read it, please don't worry about it, but you need to make sure that location context will be the part of the server context, and you can have the multiple location context within the same server context. Also, the location context can be nested in itself only. Then we have the upstream context, which is also an important context, right? And this will also use in the load balancer terms. This context is used to define the configure of upstream servers, which means we need to define that which kind of request will be handled by which kind of request. With the help of the upstream context, or with the help of the upstream configuration, you can define the active passive mode, that which load balancer or which node will work as a active node, which node will work as a in case of failover. You can also define the multiple upstream context to handle different kind of request, that certain kind of request will be handled by this particular upstream, certain kind of request will be handled by the another upstream. So suppose if you have a website which will serve the static content, the dynamic content, the video content, the jpg content, the mp4 content, so you can define the multiple upstream, that if we are getting the request for the video streaming, then video streaming upstream will handle that particular request. If we are getting the request for the mp4, then mp4 upstream context will handle the request. If we are getting the request for a static file, static data, then static upstream will handle the request. We learned about it, that how upstream will work and how we can define the multiple server locations within the upstream. But this is the purpose of the upstream, to render a specific request to a specific server. The upstream context should be placed within the HTTP context and outside of the any specific server context. It means the upstream is the part of the HTTP, but it is the sibling of the server context. This context defines a named pool of server that NGINX can then proxy request to. As I told you that within the upstream we can define the number of servers which will work as active, which will work as a passive, which will be work as a proxy. So inside the upstream we have the list of the servers, we have the pool of the servers, and we can render a specific kind request to a specific server. Then we have the mail context, which is rarely used in the then we have the mail context, which is rarely used in the nginx, but if you want to work nginx as a mail server, you need to define the mail context. The function of the mail context is up to provide an area of configuration, a mail proxy solution on the server. The mail context is defined within the mail or global context, right? So you can define the mail context within the global context as well. Also you can create the main context for the mail. So this is about the nginx configuration file, team. I hope right now you are pretty much clear that what is the structure of the nginx configuration file, what are the context and what are the directive, and what kind of context do we have, and what is the use of these context in the nginx configuration. In the coming lectures we will see all the practical things. We will update the context, we will change the context, and we will see how nginx will work with the updated context. So thank you, team. Thanks for your time. If you have any question, any doubt, please let me know. I will be happy to answer your questions. Hello team, welcome back. Welcome to NGINX training, and today we will see a lab how we can create the vhost in NGINX configuration file, how we can load the static data in NGINX. So let's go to your terminal and log in your machine. So I have logged in my machine, Ubuntu custom NGINX. This is the droplet which I have created and on which the NGINX is running. If we will execute a command ps -ef grep NGINX, so you can see NGINX master and NGINX worker process is running on my machine. Let's find out the IP, and I will go to my browser and try to access my IP on port 80. Hit enter, and you can see we are able to get the default NGINX web page. Now what we will do, we will upload some HTML content on my server, on server which the NGINX is running, and we will configure that particular HTML static page within the NGINX, and we will see if NGINX is able to read that particular HTML file or not, right? So let's go back to the terminal, and inside the terminal let's execute a command pwd. So right now you are inside the etc nginx. What I will do, I will go to the root location and hit ls. Over here we have the files like area, win, dev, home, and other files. Here we will upload some content from my local box. So if I will go to my local box, so inside the download I have a folder blogging template. This is the single page bootstrap website which we are going to upload on my server. If I will go to this particular directory, so here we have the index.html file and the assets directory. If you will go to the assets, here we have the directory like css, font, images, js, and logo. If we will go to the CSS, inside the CSS we have all the CSS which will support this particular website. Inside the fonts, here we will get the different font family. If we will go to the images, then we have few images inside the abouts, clients and portfolio, right? You can see over some JPG image over here. If we will go to the JS, then you will get all JS file which we are going to use in this particular website, and here we will get the logo of this particular website. Now let's go back and open the index.html web page. So once you will open this particular index.html web page, you will get a website like this: Brownie, education, skill, experience, profile, portfolio, and client. This is the single page website which will have some dummy data, right? This is not the real data, not a real website. This is the dummy template which is being created to display in this particular tutorial. So over here you can see this is the well formatted HTML website. We have the Ajax support, we have the image support, we have the color partition, the CSS is perfect, we have the different stylings, then we have the calendar lifeline, which is, then we have the different sections and JS supports. See, we have the different JS supports on mouse over, right? Then we have the images and we have the different supports on the images. And if you will click on any link like profile, so you will scroll to the profile. On experience you will scroll to the experience. On portfolio you will go to the portfolio. This is the single page simplest HTML bootstrap website. What we will do, we will upload this particular website to my server on which the NGINX is running. The server IP is 104.131.80.130. For this, let's go to the terminal and let's open up a new terminal. Inside this new terminal, you need to execute a command scp. Now you need to provide the path of your file in your local system. So in my case, the file is present inside the users Anshul downloads, and over here we have the blogging template. So we are going to upload this particular blogging template to the remote server. You need to provide the username of your remote server @ then the IP of your remote server. In my case, my IP is this. I will copy this, right? We need to make sure we are not providing any HTTP and other stuff. And after this, you need to provide the path on which particular path you want to upload this particular blogging template directory. So after this, you need to put a colon and provide the path. Suppose I want to upload it at a root location. Please make sure you also upload it at a root location. Sometimes NGINX don't have the permission of the other directory, and in that case you may get the 403 error as well. So please make sure you are executing the command similar like to me. Over here you need to provide your local path, and then you need to provide the root, then @ IP of your machine, colon, then root path. Hit enter. It will ask the password of your machine. We need to provide the password. Hit enter, and it will start copy of your files. So we need to provide the -r as well, because we are not uploading the single file, we are uploading the directory. After the scp, you need to provide -r. Hit enter, enter the password again, and it will start uploading all the content. So you can see the index.html and the other files are basically being uploaded on my server. So don't worry team, I will attach this particular template as a zip file in this particular lecture. So you need to go to the resource section of this particular lecture and download this template for your own use. We have to wait until the complete upload will done. So you can see all files are being uploaded. If we will go to the first terminal, put ls over here, we can see we are getting one more directory, blogging template over here. Let's go to the blogging template, put ls, and over here we have the index.html and the assets. If we will go to the assets, put ls, we have the CSS, fonts, images, JS and logo. It means all the directories plus all the files are being uploaded. Let's clear out the console and let's go to the root directory again. Now let's open up the nginx.configuration file of your nginx. So we will go to the cd etc nginx, put ls, and over here we have the nginx.configuration file. So what we will do, first we will take the backup of the current nginx.configuration file, and then we will modify the nginx.configuration file. Why we are taking backup? Because if we need to remodify the nginx.configuration file again, we will have the backup file. So I will execute the command nginx.conf mv nginx.conf, then nginx backup.conf, right? This will copy the nginx.conf data into the nginx backup. You can see nginx backup is being created. and we will also create a cp of nginx.backup as a nginx.conf. Put ls, so we have the nginx.conf as well. So we have the nginx.conf and nginx.backup.conf. Now we will edit the nginx.conf file, right? So here is the content of my file. What I will do, I will remove all these contents from my file. So I will scroll up and I will remove all this content from my file. So I have removed the complete global block. Now I will remove the directive from the events block as well, and I will remove all the directives from the http section as well. Inside the http context we have the server context. Let's remove everything from the server context as well. So you can see we have empty our nginx.configuration file. We have only three context over here: events, which is blank, http and server, and http and server context are also blank. Now let's go to the server and create a vhost. How we can do this? Let's go to the insert mode, provide the proper indentation by pressing escape. Now over here you need to mention a directive listen. After the listen, you need to define the port on which particular port you want to redirect the traffic. So I want to listen on port 80, right? By default, if you will go to the browser, then you can see by default Nginx is listening on port 80. If you want, you can define the another port as well. Over here, you need to copy your IP address. Then we need to define the server name, that on which particular server this particular request will be rendered. So right now I don't have any domain, so I need to define the IP. I will define server underscore name. Then you need to define the IP of your machine which you just copied, and please make sure there's no extra colon and other protocol between the server name and this particular server. Semicolon we need to use to close the directive. So we have defined two directive inside the server. First is the port, on which particular port we want to listen the website, and then we have defined the server name, that on which particular server this particular request will be redirected, which is coming on port 80. After this, you need to define the root, right? That which particular file system will read that particular location. So if you will go to the another tab, you can see we have uploaded the file at the root location. So let's log in over here. We are logged in, put ls. Now go to the root, put ls, and over here we have uploaded this blogging template. Go to the blogging template and put ls. Right over here we have the index.html file. Execute pwd. So this is the path which we need to provide. The path is blogging template. I will copy this and provide as a root path over here, right? Please make sure we will also putting the slash and semicolon. So we have defined a server location in my nginx.configuration file, that this server will listen the request on port 80. The request which is coming on port 80, that request will be forwarded on a server 104.131.80.130, right? If you have a fully qualified domain name, you can provide the domain name over here as well. And then we are defining the path, then on which particular path this particular request will search for the content of HTML file. Let's save your file, clear out the console. Now let's execute a command systemctl reload NGINX. Why we are executing the reload? Reload is a command which will refresh your configuration on your running NGINX process. If you are going to restart this, suppose we are going to execute a command instead of the reload, we are going to restart NGINX. So what this particular command will do? First this will stop the NGINX, then it will start the NGINX. And in that case we have the risk, and risk is the latest nginx configuration file we have created. If that particular configuration file have some error, then your nginx process will not come up. It means on the running system you may kill your nginx process, which may kill your web server, right? So restart is not preferred. Always we need to make sure that whenever we are doing some changes in the configuration, we are going to reload the configuration. And reload is the functionality which will reload the configuration at runtime on the nginx. You don't need to restart the nginx. There's a one more way to check that configuration which you created is a good or not. For this you need to execute a command nginx-t. Hit enter, and you can see this is saying me that configuration of etc nginx conf is okay, right? And test is successful. So by this particular command you can check that the configuration which you are making, is that configuration correct or not. If you will do some mistake in this particular configuration, let's open the configuration over here, etc nginx nginx conf, and suppose I am removing this curly braces from the root. Save my file, and over here I will again execute the test nginx.t. So we can see we are getting the error that unexpected token at line number 15 in the nginx.configuration file. It means the configuration file which we created is not correct. In that case, with the incorrect nginx configuration file, if you will restart your nginx, then it will kill your nginx process and nginx will not come up. In that case, you may face the downtime on your server. So please make sure whenever you are doing the configuration changes, first you will test your configuration changes with the nginx-t, then you will reload your nginx configuration instead of nginx restart. Let's correct the configuration. We will again open the vi mode and put the semicolon over here, right? Save my file. Again check the configuration, and configuration is good, right? Let's clear out the console and reload your configuration. And to reload the nginx, we can execute a command nginx-s reload with the signal reload. If you want, you can reload the nginx with the systemctl reload nginx as well. So we have reloaded the nginx. Let's open the logs. So cat var log nginx asterisk, hit enter. So see, the last line we are getting signal process started. Over here, the above line we are getting the log configuration file 15 is error, which is reported whenever we have removed that particular semicolon from my file, right? So reload has been done. If you will tail your logs, we'll execute a command tail -f where log nginx asterisk, it means trace, it means tail all logs, error and access, and we will go to the browser and refresh my web page. So you can see the HTML web page is changed. Right now we are not getting the web page which we was getting. Earlier we was getting the default nginx web page, but right now this particular web page is changed. Although I can understand that this web page is not something which we have seen on the earlier browser, right? It means which we have uploaded. If we will open this, then this is the web page which we have uploaded, and this is the web page which we are getting. So what is the difference between both of these web pages? The difference is only HTML is getting loaded over here. No CSS file, no JX is basically being loaded over here. Only HTML is being loaded over here in this particular web page, right? Although over here all the CSS, all the JS are being loaded, but over here we are not getting the JS and we are not getting the CSS as well. We are just getting the HTML form. If we will go to the logs, we'll see we are getting the logs over here. This request, first is this request is made, then we are getting the log for the CSS file. See over here we are getting the different CSS file logs, and log call is 200. It means nginx is recognizing the CSS file, but somehow it is not applying the CSS files. See, all the CSS file calls are basically 200. Over here we have the 200. This is the CSS call, this is also the CSS call, this is also the CSS call, this is 200. If we will go through, the JS call is also should be 200. See, this is the JS call, this is 200. This is the JS call, this is 200. So what is happening? Is that something which Nginx is breaking, or is that something which we are missing? So Nginx is not breaking anything. It's actually our mistake which we are doing. Although Nginx is recognizing all the CSS file, all the JS file, it is showing 200 status code, but it is not reflecting the same on the browser, right? It is not reflecting the same over here. Why it is not reflecting the same over here? Let's understand that particular thing as well. So let's copy this, go to the terminal, and inside the terminal let's execute a command curl -i, define your server, then define any CSS or JS which you want to see. Suppose I want to see the status of this particular CSS, boot as nav. I will copy this and provide over here, right? Please make sure that we are not providing double slash, right? We are providing the correct path. So here this is the correct path of my CSS. I want to check the status of this particular CSS. Let's hit enter, and over here we can see we are getting the status okay, which is the same over here we are getting inside the log, right? Status is okay. Then we are getting the server, which is nginx 1.19.1, then the date, then the content type, and here is the catch. Content type is a text plain, right? Although in my case this is the CSS file, so this should be CSS, not text plain. If the same thing we will do for the JS query. So over here let's identify any JS. So here is a JS assets JS oval, then we have the cursor min.js. Let's copy this path, go to the browser, clear out the console, and let's hit this particular JS, hit enter. So see, it is also able to identify the JS, but again JS is also a plain text, this is not the JS. So how we can resolve these problems? NGINX is not basically understanding that what is the file extension, the file which I am reading, what is the extension of that particular file. It is always accepting the file extension as an text plain. How we can do that particular thing? For this we again need to open the configuration file, etc nginx go to the insert mode, and inside the http section at the same level of server we need to define the another context which is types. Right, we have defined the types, and inside the types we need to define the type of my files. So over here we need to define text slash html, and this file will be html file, semicolon, provide another type, text css space, this will be css type, save my file. Now reload the nginx. So I will execute a command nginx -s reload, hit enter, go to my logs, and over here we can see signal process started. It means nginx is being reloaded. Now let's go back to the browser and refresh my web page again. So here is my browser, I will refresh it again. So you can see something is being changed, some style is being changed, but still page is not being refreshed. Right now if we will go to the logs and we will execute the same command again which we was executing for the css, hit enter. So this time you can see it is able to understand the css. Earlier this was getting the text plain, right now it is able to understand the css, but it is still not loading the js. So does it mean we need to define each and everything inside my configuration file? No. Inside the nginx we have the subdirectories model, right? So if you are defining something inside the subdirectories, then you just need to define that particular subdirectory inside the configuration file. So let's go to the nginx configuration, etc nginx, hit ls. Over here you will get a file called mime.types. Let's get this particular file, mime types. So if you will go through this particular file, then mime type files have the types section, and inside the type section we have the text html, which is html, stm, and shtml, the different extensions. We have the css, xml, gif support, jpeg for the jpeg and jpeg support, js support, atom support, rss support. Over here inside the mime.types you have defined the types, and here we have the multiple types which may support the file system for the video, audio, application octane stream, application xsufflet, java archive, bdnoss, google. There's a lot of things. So we don't need to define all the types over there. What we will do, we will define the subdirectory structure. So this is the another way. You can define your own subdirectory inside the configuration file, which may carry your html context, which may carry your type context, which may carry your global context, which may carry your server context, which may carry your nested location context, and then you can include that particular context in your configuration file. So let's see how we can include this. The file name is mime types, and this have the types over here. Please make sure whenever you are creating the handcrafted file, you are defining the correct context inside your file. Otherwise, your configuration will not be load. Let's clear out the console. Go to the BI mode for the nginx.conf. Go to the insert mode. Go to the types, and let's remove this. And instead of the types, let's declare a new directive inside the HTTP context, which is called includes mime.types. Why we are defining just file name over here? Because my nginx configuration file and the mime type files at the same location. If you have the mime type files or any subdirectories files at the different location, then you need to define the complete path over here, right? And this should be include. Instead of includes, this should be include. Close this and reload your nginx one more time. Nginx-s reload. Go to the logs, put enter, reload your NGINX, you will get the signal over here. NGINX is being reloaded. Let's go to the browser. Now let's go to the browser. Let's copy this address. It may possible that your browser may fetch the cache. So we will open new incognito mode and paste my IP over here. Hit enter and see we are getting the complete file, right? The same website which we was getting in our browser. This is completely CSS. The complete CSS and complete JS support are available over here. See, and we make sure that whenever we are hitting the request on port 80, that request is basically being reflected on my server, which I have defined inside my NGINX configuration file. If you will go to the configuration file and you will update the configuration file one more time, and this time suppose I want to hit this particular server on another port like port 8081, I will update the port, close my configuration, and again reload my nginx.reload, right? Go to my browser, refresh this on port 80, you may get the error, right? Let's define port 8081, hit enter, and you will get your website over here. So team, this is the way how we can define the servers and a particular block location on a particular port, that how a particular port will serve the traffic. You may have seen in your production servers that same server is redirecting different web pages on different ports. You may also configure within the same Nginx server, you may configure different ports for the health check of your service, for the real traffic of your service, and for the support application of your service. It may possible that same Nginx server is running on port 80, which is executing your application on port 8080, executing the sub application port 8081, executing some child application on port 9090. It is executing your application health check. It may possible within the same Nginx server you can define the different mapping. So this is the first step. We have seen that how Nginx can behave with the custom configurations. We will learn more interesting things in the coming lectures. Thank you team, thanks for your time. Hello team, welcome back. Welcome to Nginx training, and today we will see what is the location context in the Nginx configuration file. In the last lab, we have seen how we can load the static page or static website, JS and CSS with the help of the Nginx configuration file. And today we will see what is the importance of the location context and how we can use the location context inside the Nginx configuration file. So location context block live within the server blocks and are used to decide how to process the request. It means location context is the child context of the server context, and it will decide the resource path of the request URI. We can define the multiple location context within the same server context. Location context can also be nested. It means you can define location context inside the location context. Then that location context also have the location context. There's no limitation. You can define n number of location context within the location context itself. First, we are discussing about the application of the location context. Then we will go to the lab as well. Now let's come to the second point, that location context will decide how to process the request URI. Whenever you are hitting the URL on a simple port, the request URI is always hitting the root path, right? But what if you append the resource in your URL? If you will enter some URI in your browser, then how your application will behave. So that is being decided with the help of the location context. Here is the syntax of the location context. We need to define the location, then we need to define the modifier, and then we need to define the location match. After this, we have the curly braces, and within the curly braces, we need to define the location context body. Here, modifier is the optional value. If you want, you can define it. If you want, you can avoid. But I always prefer to define the modifier, right? Location match is mandatory in the location block, and we will discuss about the modifier and the location match shortly. First, let's discuss about the location match. Location context define what Nginx should check the request URI against for. It means whenever we are hitting a particular URI, then on the basis of the location context, that URI will be served. So if you have the multiple location context defined in your Nginx configuration file within the server, then when you hit the URI, Nginx will check the location context at the runtime and it will return the suitable location context to the URI. Right now, if it all seems abstract, you don't need to worry about it. Once we will go to the lab, it will be pretty much clear that what is the location context and how Nginx will manage the location context in the configuration file. The existence or non-existence of the modifier affect the way the Nginx attempt to match the location block. It means the modifier which is the optional modifier, the existence or non-existence. It means if you want you can define the modifier, if you want you can avoid the modifier, but that modifier will affect the way how NGINX will attempt to match the location block. If we have the multiple location block and more than two location block or more than one location block are matching with your request URI, then the best match will be decided on the basis of the modifier. Here we are listing some modifiers, right, and associated blocks, and we will see how NGINX will interpret that particular modifiers. So first modifier is none when you are not defining any modifier with your location block. If no modifier are present, the location is interpreted as a prefix match, right? This means that location given will be matched against the beginning of the request URI to determine the match. Let's go through with the none value first. So we will open the terminal and we will log into our machine where the NGINX is running. So here we have two terminals, right? The blue terminal and the black terminal. Let's log into my machine. Once you log in your machine, I will clear out the console. And over here, we will go to the NGINX configuration file. So we will go to cd etc nginx put ls, and over here we have the nginx.conf. Let's open the nginx.conf in a vi mode. Now here we have the events which is blank. We have the http context. Inside the http context we have seen the include of the MIME type, and we have the server context. Location context is always the child of server context, so we need to define the location context somewhere inside the server context. So we will go to the insert mode, and over here we will define the location context. But before defining the location context, let's go to the browser and let's see what we are trying to achieve. So over here we are on a browser, and if you remember we have modified the port 8081. If I will refresh this, you can see my web page is loading. What if I will append some URI over here? So suppose I'm appending some URI, context us, hit enter, and we are getting 404 page not found. It means there's no page, no request URI on this particular server which match my particular URL port, then context us. We need to define the location block to match that particular URI. So let's go to the configuration file, and inside the configuration file we will define the location context. So we will define the location. Then right now we are not defining any modifier, we are directly defining the location match. So suppose I am defining context us. After this we need to define the curly braces, we need to close the curly braces as well, and we will keep it at a same location. Once you will close the curly braces, inside the location you need to define some. So suppose over here I'm not returning any HTML page and I'm defining some hard-coded value. So I will enter return 200. It means first return the status code and then return some string. So suppose I'm defining some string over here. Hello, you are inside custom location, and then we are closing this particular location block like this. So what this particular block is doing over here, we have defined some URI, right, contact us, then we are returning the 200 status code once this particular URI will be returned, so that we will not get the 404, and this is the text message which we are returning on this particular location block instead of some HTML file or some decided route path. So let's close this. Now we will reload the nginx-s reload. Now we will go to the browser again, and inside the browser let's refresh your web page, and you can still see we are getting the error. You can see we are getting the error, we are not getting the block which we was hitting. Let's go to the console and let's open the log on the blue terminal. Once we will open the log in the blue terminal, you can see we are getting that it is hitting the request get, but the status is 404. Although if you remember we have defined the context us inside my configuration file. So if you will identify that you have defined the context us in the small characters. So if you will go to the context us and we will replace the capital U with the small u and hit enter, you can see we are getting hello, you are inside custom location. If we will go to the logs, then logs are also 200. It means once we are hitting this particular URI, this particular message will be returned. Earlier we was getting 404. Now suppose you are going to append anything after this particular context. We are getting context as about, hit enter. See, I'm getting the same message. If we are going to append something else about myself, hit enter, we are getting the same message. So by this particular way you can understand that NGINX is just matching the first URI. After this first URI match, it doesn't care that what we have after this particular URI, and NGINX is always returning the context which is basically matching with this particular first URI. This is the case of none modifier, because inside my nginx.configuration file, if I will get my file nginx.conf, you can see I have not defined any modifier over here. I'm just defining the location match, and whenever this particular location match will be successful, we will get this particular result on the web page. Now let's go back to the slide again. So we have discussed about the none, and the definition we have also seen. This means that the location given will be matched against the beginning of the request URI to determine the match. Definitely, it was only matching the beginning of the request. It doesn't care that what we have after that particular location inside the URI. Now second one is the equal. So now if we are defining some modifier, right? And if equal sign is used, this block will be considered a match if the request URI exactly matching the location given. It means if we will define the equal inside my location, then it will exactly match the given location, and if there is no exact matching location, then you will get the 404. In the similar way, we have the regular expression with the help of the tilde. If a tilde modifier is present, this location will be interpreted as a case sensitive regular expression match. It means if we are defining the tilde before the location match, then this location will be interpreted as a case sensitive, right? And regular expression match will work. Then next one we have the tilde asterisk, right? And if the tilde asterisk modifier is used, the location block will be interpreted as a case insensitive regular expression match. And last we have the caret character and a tilde. If caret character and tilde modifier is present, if this block is selected as a best non-regular expression match, regular expression match will not take place. It means if caret character tilde is defined, then this will be selected as a best non-regular expression match inside the engine's configuration file. And how this particular regular expression match is working, if you remember that we have added the PCRE library inside the NGINX when we was building the NGINX, that PCRE library help us to identify the regular expression and use the regular expression. So we have seen the none. Now let's see about the equal, tilde, tilde asterisk and character tilde. So let's go back to the terminal again and let's modify my location block. So vi nginx.configuration file, hit enter, and this time I will go to the location, go to the insert mode, and instead of the none I will define equal, like write this. Now let's save my file and reload the nginx. I have reloaded my nginx. If you will go to the terminal, you can see the nginx process is basically started. Let me enter over here. Now let's go to the browser, right? And over here let's refresh your browser. Now you are again getting 404. Why? Because I have the extra URI in my path. I have modified my location context, but I have the extra resources inside my URI so that the location block is failing. Let's remove this, hit enter, and this time we have the exact match. We have the exact match of the contextors, and we are getting our custom message, hello, you are inside the custom location. So this is the way. If we want to match the exact location, then we can use the equal. And if you want to just match the starting of my URI, then we can use the none object identifier. Let's go back to terminal again, and over here let's copy this content. Let's go to the editor mode, and this time we are defining two location context over here, one with the exact match, and suppose over here before the exact match we are defining the same location context, but this time we are not defining the exact match. Team, please make sure that it doesn't matter that in which particular order you have defined your location inside the configuration file. NGINX have their own implementation to identify the location. It doesn't matter that in which particular manner the location is basically defined. And over here let's modify some message. You can see here I'm not defining any modifier, here I'm defining a modifier. Let's modify the message inside the modifier, and here I'm defining you are inside the custom location, and I'm saying hyphen exact match. Now let's save your file and reload your NGINX. NGINX is being reloaded. See, now let's go back to the browser, and now let's see, once we will hit the context us, right, which location block will execute. The exact match will execute or the none modifier location block will execute. Refresh this, and you can see the exact match is basically executing, right? We are getting the message which we have defined inside the exact match. None location block is not executing whenever we have the two location block with the same URI, but we are defining the exact modifier and none modifier, then first preference is the exact modifier, not the none modifier. If we will append something after this URI, append anything like this, refresh your, you can see the location block with the none modifier this time executing. So this is the way how we can define the multiple location blocks inside the NGINX configuration, and how we can bind our application to behave exactly at some particular location. So by this you can understand, if you want to strictly follow that a particular URI, a particular path should be returned, then you can follow the exact match. Otherwise you can follow none, right? If I will remove the context, instead of the context us, hit enter, we are getting 404. It means at least the exact URI should be defined. So let's again add the context us, hit enter, and you can see the exact match is basically being hit by my NGINX server. Now let's again modify my file, and this time instead of the exact match, let's use regular expression tilde like this, and modify the message as well, and we will call it regex case sensitive match, because tilde is a case sensitive by definition. Let's save your file, reload your NGINX, go to the logs, NGINX is reloaded, go to the browser, right, and let's hit the context us. And this time as well we are also getting the regex case sensitive match. It means although the none and regex is defined, but the preference is regex, not the none. So now one more question, if all three are defined, the exact match is defined, regular expression is defined, and none is defined, then what will be the preference? So I will provide you the priority later, but right now I want you will understand that if we are defining the multiple location block with the same resource URI, then how that particular location block will be picked in the NGINX. This is really important to understand, because whenever we are going to configure the web server, these things will help you a lot. And now let's copy this, put over here, and put the capital context us, hit enter, and see we are getting page not found. Let's go back to the terminal again, and this time we will modify the NGINX file again, and instead of the tilde we will put a regex like tilde asterisk, and we will modify the message regex case insensitive match. Close this, reload the NGINX, go to the browser, refresh your web page. We have the capital context us, and we are getting the message over here. We have the small context us, remove this, and we are getting the same message. So if a regex is defined, it is a case sensitive or case insensitive. In both of the case, regex will be the priority over the none context modifier. So this is the way how we can define the multiple contexts and how we can use the context in the NGINX. Now let's discuss about the priority of the context, that which is the highest context priority for the NGINX. So NGINX choose the location that will be used to serve the request in the similar fashion how it select a server block. It runs through the process that determines that best location block for any given request. And here is the priority, that if we have defined the exact match, then exact match will be picked as the first priority whenever multiple location blocks are basically getting the same URI. After the exact match, we have the preferential prefix match. It means correct, character, and tilde. If we have defined the same location block, right, then after the exact match, the second priority is the preferential prefix match, which is caret, character, and the tilde. And after this we have the regex, which is tilde and asterisk. After this we have the tilde, and after this we have the none. So here is the priority of the modifier which NGINX will choose whenever it will match the location on the basis of the given URI. The understanding of this process is very crucial because whenever you are going to configure the NGINX and you want to configure the reliable and accurate NGINX, the understanding of these things are much required. So team, if you have any doubt, any question, then please let me know. This is the way how we can work with the location block in the NGINX. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training, and today we will see a lab on the variable in NGINX. We will see what are the variables in the NGINX and how we can use the variables in NGINX configuration file. So let's start with. So like the other programming languages, we have the variables and variables are used to store the value. The same thing we can do inside the NGINX configuration as well. Inside the NGINX configuration, we can create the values and values can be saved within the variables. NGINX also have the inbuilt variables which you can use as per your application, and if you want you can create your own variables as well. The NGINX variable by default contain the string value. There is nothing that you can define the integer, float, array, list. There is nothing like that. NGINX variable is a simple variable which will contain the string value. The set directive is used to assign a variable in the NGINX. Suppose you want to declare a variable and the value inside the NGINX configuration file, you need to create a directive like set $a, then define the value. Here a is the variable, and using the set, you are setting a variable a with the value hello world. User can also put the conditional statement on the basis of the variables. It means inside the NGINX configuration file, you can put if statement on the basis of the variable which you are defining inside the configuration file. As I told you, NGINX also have the inbuilt variables, either inbuilt in NGINX or inherited from some third-party library. Some of the important variables which we are going to discuss. And first variable is args. This variable will list all the arguments which you are defining inside the URI. Second is the body byte sent and body byte received. The variable body byte sent and body byte received will define the number of bytes sent by the client and number of the bytes sent to the client. Byte received is the another variable which will define the number of bytes received from a client. Then we have the connection request. Connection request variable define the current number of requests made by the connection. We have the another variable like date local which will define the current time in the local time zone. The host name, it will return you the host name, and the NGINX version, it will show you the NGINX version. Let's go to the terminal and let's see how we can define the variables and how we can use the variables inside the NGINX configuration file. So you can see I have logged in inside my machine Ubuntu custom NGINX, and on the blue terminal I will show you the logs, and here as well I am also logged in my machine. So here I will open the log simply tail-f var log NGINX, and I will open all the logs which are present inside the NGINX file, and here I will get my logs. Let's go over here and let's see if NGINX is running. So ps-ef grep NGINX, and yes, NGINX is running on my box. Now let's open the NGINX configuration file and let's see how we can use the variables. So vi etc nginx nginx.conf, this is my file, and over here I will define one more location like, and suppose I'm defining the location name like find, and inside this location I will return the status code 200, and after this I will return a string. And suppose inside the string I am returning the variables. The first variables what I'm returning is the host name. Then put new line, and second variable suppose I'm returning like args new line, and third variable suppose I'm returning like there should be dollar instead of the percentile. And what other variables we have discussed about like dollar connection underscore requests, new line, dollar, nginx underscore version, right? Now let's save my file. I will reload my nginx, nginx-s reload, hit enter, and you can see there is an error in my configuration file. I will open my configuration file again, and let's see what I'm missing. And I'm missing closing semicolon over here. Let's save it again, verify the nginx-t, and file is okay. Now reload the nginx. Let's check, and we can see the process is basically being reloaded. I will go to my browser and I will open my IP on port 8081. So you can see we are getting my website. Now I will go to the location which I just defined. So I will define find, hit enter, and over here you can see we are getting the different values. This is my host name, Ubuntu custom nginx. Then we are getting some blank, then we are getting 6, then we are getting the version of my nginx. So let's go back to the configuration file again, and let's open the file in vi mode, and let's make it correct. So this n should be like this for new line. So the second argument is the argument, as we was not passing any argument in the request, so we was not getting any value, and 6 was the connection request. Let's save your file, again reload your nginx, go to your browser and refresh your web page. See, now we are getting in the new line. So this is my host name. The second thing is the argument which I'm getting blank. The third one is the request number, and now we have the nginx version. Let's refresh this. You can see the request number is increasing. Refresh this, increasing. Refresh this, increasing. Refresh this, increasing. Let's go to some other web page. So I'm going on port 8081, right? And now I'm again getting on the find. So request number is increasing again. Now inside the URI, let's pass some argument or the query path. So I will put dollar and say API key equals to 1234, hit enter. Now you can see you are getting the argument as well. The argument which you are passing over here, you are getting the same argument over here. Let's pass one more argument, question mark, name equals to Anshul, hit enter. See, I am getting the second argument as well. So this is the way how nginx variable will help you. Now let's see how we can put the condition on the variable. So let's go back to the terminal, go to the vi mode, and before the find, let's put a if block over here. And I will call if, then space, braces, and inside the braces put space. Please make sure everything which you are defining inside the if must contain at least one space. Then define the dollar arg underscore name. Then we are defining if dollar name is something like Anshul. String, put curly braces, close curly braces. Inside the if, let's return 200, and over here I'm returning yes, I am Anshul. Right? So what I'm doing over here, I'm reading the argument name, right? And if the argument name is Anshul, then I'm returning 200. Otherwise, it will return 404. Let's save this file, reload your nginx. We are getting the configuration error. We must forgetting something, and yes, we are forgetting the closing semicolon. Let's close this. Type nginx -t. Configuration is okay. Reload the nginx. Nginx reload is done. Go back to the browser and let's refresh your web page. And this time I am passing dollar name equals to Tom. Hit enter and see, we are not getting the web page. But if I will put dollar name equals to Anshul, hit enter, we are getting the condition. So by this particular way, you can put the condition as well, that if something is matching, then this thing needs to do. Inside the request URI, you can mention anything. So now you can see how we can work with the conditional statement as well. Inside the if, we have defined a variable, right? And whenever we are getting the same variable in the request URI, my page is being returned. If I will update it and suppose I'm taking Anshul 1, then I'm getting the default website. So by this particular way, you can manage your nginx configuration and you can define the conditions as well. So team, this is the way how we can work with the variables in the nginx configuration. If you have any doubt, any question, then please let me know. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training, and today we will see a lab on rewrite and return in the NGINX configuration file. So we will see what is the use of the rewrite and what is the use of return in NGINX configuration file. So let's start with. First, we need to understand that return and rewrite both directives are used for the same purpose. And the purpose could be, and the first is if the URL website has been changed, and second is to control the request within the NGINX. For example, if a request can be forwarded to an application, if the content will be generated dynamically. So whenever you want a redirect on the original request, you need to use the return or the rewrite. The first case which we mentioned is the URL change. It means suppose your website URL is www.mywebsite.com and tomorrow your website URL has been changed to www.mywebsite.org. In that case, you always need to redirect your old customers to the new domain as well. So you can use the return or rewrite. And if you want to control the flow of your application and you want that some content will be dynamically delivered at a particular URI, then also you can use the return or the rewrite. But there's a key difference between the return and the rewrite. Although the main purpose of both of the directives is the same, but there's a difference in the function. Let's first discuss about the return directive. Return is simpler directive as compared to the NGINX rewrite. Why I am saying the return is simple? Let's discuss about it. So first, let's discuss about the return directive. Return directive is simple as compared to the NGINX rewrite directive. When I am saying return is simple as compared to the rewrite, it means the logical flow of return is quite simpler as compared to the rewrite, and resource consumption of return is also low as compared to the rewrite. We will learn why rewrite is costly as compared to the return. Return must be enclosed within a server or the location block, which defines which URL should be rewrite. Whenever you are going to define the return, you always define the return within the server block or the location block. We have already used the return in last two lectures. If you remember, then we was returning 200 then a string. And over here is the sample of the return. Suppose inside the server block you have listen port 80 and you have defined the server name www.oldwebsite.com. This is your domain. Whenever user will visit this particular website, this particular domain will be hit. In that case, you want that user will directly return to the new website, right? So we will define the return 301. Then we are defining the request URI on which you want to return the user. So over here we are defining the scheme www.newwebsite.com, then the request URL. Let's discuss about the rewrite directive. And similar to the return directive, rewrite directive will also be within the location and the server block. As compared to the return directive, rewrite directive can be used to perform the more granular task, because with the help of the rewrite directive you can perform more complicated URL distinctions. You can capture the element in the original URL and you can perform the directive on the basis of that particular capture value. You can change or add element within the path. It means you can create the dynamic URI, and on the basis of the dynamic URI you need to choose that which location or which server block should be returned. The syntax of rewrite will be like this: rewrite, then you need to define the regex, then you need to define the URL, and flag is a optional. And the basic difference between the function of rewrite and return is that rewrite directive does not send a direct redirection to the client in all the cases. If the rewritten URL match with another following directive, NGINX will rewrite the URL again. It means whenever we are defining the rewrite, it will traverse all the location and find out the best match. That's why rewrite is more resource consumable as compared to the return, because return simply return the URL which is defined for the return, but rewrite will traverse all the locations and identify the best match and then return. So let's go to the terminal and let's see some hands-on practice on the return and rewrite. So over here we are on a machine, and on the blue terminal as well we are on the machine. Let's open the logs over here. So I will open the logs on my blue terminal and I will switch back to the dark terminal, and over here we will open the configuration file. So inside the configuration file you can see we was using the return earlier as well, right? We have used the return multiple time during the earlier configuration. Let's do one thing. Let's go to the insert mode and create one more location block. So over here let's save this particular file or exit out from this particular file. and let's go to the directory where my HTML page is saved, right? So over here, if you will go to the browser, so on port 8081, we was getting this particular website. Let's open the base location of this particular website. So if you will go to the root, put ls. Over here, we have the directory blogging template. Inside the blogging template, by default, this particular NGINX page is basically being returned. Over here, we have the assets. We will go to the asset, put ll. We have the directory like logo, images. Let's go to the images, ll. We have the another directories like about, client, portfolio. Let's go to about, put ll. And over here we have the files like welcome hyphen banner jpg, profile underscore image jpg, old underscore image jpg. Let's execute a command pwd, and this is my complete path. So by default, when I'm hitting port 8081, I'm basically redirecting to this particular location where my index HTML page is basically defined, because this is the root path which I have defined inside one of my location. Now let's copy this particular resource URI, assets, image, about, go to the browser, paste it over here, and then try to access the JPG file. The name is welcome banner JPG. So I will copy this and paste it over here. Hit enter. You can see we are able to access my JPG file. But right here, the complete path of the file is being exposed. Suppose you don't want to expose this particular complete path. How you can do it? So let's go to the configuration file. I will clear out the console. Inside the configuration file, I will go to the insert mode and define one more location block. Location. And suppose this time I am defining the location like welcome. Open and close curly braces. Format the curly braces. Now over here I am defining return 301 or 307, whatever the return code you want to mention. And then I'm defining the path of my file which I want to return on this particular location. So suppose on this particular location, I want to return the same file. This is the path: assets, image, about, welcome, then banner. So I will copy this and paste it here. Close this. Let's resolve this particular thing and save your file. Let's reload the NGINX, NGINX -s reload. Hit enter. You can see NGINX is basically being reloaded. Now I will go back to my browser, and instead of all these things, I will simply return welcome. Hit enter. And you can see when I'm hitting the welcome, it is basically returning me on this particular path. If I will go to the logs, then over here you can see you are getting the 301. This is the redirection call, and I am hitting the welcome get call, but this redirection call is basically being written on this particular URL. If you will try, you can hit it again, welcome, and see. If you want, you can close this and you can hit a new browser 8081 and hit the URL welcome. See, this is always returning to the same location, but the drawback is the complete URI path is being exposed. It is exposing the complete URI path. So how we can fix it? Suppose I want to return the same page, the same image on just welcome URL. So let's go back to the configuration again. Open the configuration in VI mode. Now over here, suppose I'm going to define the rewrite. So I will go into the insert mode, right? And I will define the rewrite. Inside the rewrite, I will define the regular expression like caret character. Then suppose I'm defining some dummy path and I'm getting guest. Then suppose it is accepting some word as a guest, regular expression. Then it is defining welcome, right? So you can see over here we have the direct welcome, then we have something which is guest, and then some dummy path over here, then we have the welcome. And we want when someone hit some guest and some name, this will redirect to the welcome, right? So over here we have the welcome block which is returning some banner page, and this particular location basically we are rewriting with the rewrite. So let's save this, reload the NGINX. NGINX reload is done. You can see over here. Let's go to the browser, and inside the browser after this let's put guest, and suppose I'm putting a name like Tom. Hit enter and see I'm hitting the guest Tom, but it's basically redirecting to the banner page. See, guest, suppose this time I'm looking Michael, hit this particular URL and this is basically redirecting to the welcome banner. So this is the way how you can use the return and the rewrite. But rewrite also have some more advantage as well. Let's see what are those. So we'll open the configuration in the VI mode, and suppose we are defining one more rewrite over here. I will go to the insert mode and I will define rewrite character guest, and this time I will enclose the complete string in a block like this, and then I'm defining welcome slash $1, and I'm defining one more location block over here like location, and I'm saying welcome, and over here I'm saying suppose Anshul, and then I'm opening and closing the curly braces. I'm defining a body over here. Within this location block I'm defining return 200 or 301, whatever you want. Suppose we are returning 307, and I'm returning a string, this is Anshul, and close this. So what we are doing over here, you can see over here we have the two kind of write. One is the guest, then we accepting some word after the guest, right? And we are simply returning to the welcome location. Then we have the guest, we are accepting some word after the guest, and that word I'm taking as a parameter, and that parameter I'm passing to the location. And if that parameter name is Anshul, then this particular status will be written. But if that parameter name which I'm passing after this, the guest is not Anshul, then this particular thing will be returned. And suppose this time we are defining the another rewrite. So I will go to the insert mode and I will type a block rewrite character user, and this time I'm supposed defining this within the curly braces w plus, and I'm taking this like a welcome slash $1, right? Close this. I'm defining another location over here, location, and I'm taking it like equal optional modifier slash welcome, and if the username is Anshul, open close curly braces, format it, and inside this location I'm defining return 200 and returning a string hello Anshul, welcome. Now closing this. So what we are doing, we have the two rewrite. First rewrite is just have the guest, right? And guest any username is returning to the welcome, and welcome has this particular location we have seen. But if we are using user and username is Anshul, then what will happen? Then this particular string should be returned. Let's save this, reload the NGINX, check it. The NGINX reload is done. Go to the browser, type over here whatever you want like welcome Maria, hit enter. The welcome banner is basically returned. Now I will put user Anshul, hit enter, and this will return to me the another location block. So this is the way how you can work with the return and the rewrite. So we are working on different sets, that how we can customize the configuration or Nginx configuration inside the Nginx, and how that configuration may impact the redirection on the website. So team, if you have any doubt, any question, then please let me know. Thank you team, thanks for your time. Hello team, welcome back. Welcome to Nginx training, and today we will see a lab on the try files. We will see what is the concept of the try files in Nginx configuration and how we can use the try files to make the web server more reliable. So let's start with. So in Nginx configuration file, you will get an option try files. Try files directive can be used to check whether the specified file or directory exists or not. So whenever you are defining the static files, the static directory, it could be MP4, could be video, then you can use the try files. And with the help of the try files, we can make sure the requested resource is basically exist on server or not. Once you will define the try files directive inside the Nginx configuration, and once the try file will be called, then Nginx makes an internal redirect and verify if the requested path is exist. or return a specific code if that particular path is not exist. So let's go to the terminal and let's see how we can modify the NGINX configuration file for the try files. So I'm on my terminal and I will open the configuration file. Here is my configuration file. Let's clear out some configurations from this file to make it simple. So team, you can see I have erased almost the complete engine configuration file and we come to the very basic again. Over here, let's define some location and I'm defining a location video. Open close the curly braces and inside the video location I'm defining return 200 and passing a string enjoy the movie. So what we will do now, if I will save my file and reload my NGINX configuration, right, I will go to my browser and inside my browser now if I will go to video, hit enter, you can see I'm getting the 200 status code and basically a string which I mentioned is being redirected. Now let's go back to the configuration file again and go to the insert mode, and suppose over here I'm going to define the try files. One more thing, you can define the try files either in the location block or in the server block. So I will define try underscore files, and after the try files you need to define the parameters. So suppose first I want to define the parameter, on the basis of that particular parameter my redirection will be work. And suppose as the first parameter I'm defining something like test object. After the test object I'm defining like video, and after the video I will close this, save my file. So what I'm doing, I'm defining two parameters over here. First resource path is the test object and second resource path is the video. Let's save your file, reload your NGINX configuration, and let's go back to the browser. And over here instead of the video I will define test object. Hit enter. You can see I am mentioning the resource path of the test object. I am getting the response of the video. So every time I will go to the test object, it will render me on the video URI. How it is being possible? So it is happening because of the try files. So what is happening over here? Once you are hitting the test video URI, first NGINX is trying to find out this particular location. Once this particular location will not be matched, then it will try for the next one, and next one is the video, and next one is the video, so that you are getting the video content being returned. And inside the configuration file, instead of the test object, this time let's define some valid path. So over here I'm defining some valid path of any image which is present on my box. So let's find out the image which is present on your box. Clear the console, go to the root, cd, blogging template, assets, images, then we have the about, put ls, and we have the welcome banner, profile image and all. Execute pwd, copy this path, assets, image, about, and paste it here. Okay, and after this I need to provide the image name. So suppose I'm opening the profile image.jpg. I will paste it here and remove this particular double slash from starting. So what we are doing right now, my first path is also valid and my second path is also valid. So how try file will behave? I will save my configuration, reload the NGINX, go to the browser, and let's refresh the test object. So you can see I am getting this particular image. Now let's do anything, and suppose we are mentioning any URI over here like nothing, hit enter, the same image should be returned. After the nothing, let's mention hi, same image should be rendered. After this, let's mention you, same should be rendered. So it means once the first match is basically happening, try files is not matching the rest of the URI. It will directly redirect to the first object. So how we can solve this problem? So to solve this particular problem, we again need to go to the terminal, open the Vim, and as a first object inside the try files, I will pass the URI. So as a first object, I will pass the $URI. It means if the URI which I'm hitting that is a valid URI, then return this particular URI. Otherwise, go for the second option. Otherwise, go for the third option. So let's save this, reload the NGINX, go back to the web browser, and over here we are mentioning and going with 8081. And now let's try port then index.html. Hit enter and we are getting our website. If we will go with the second option, which is assets and welcome png, hit enter, we are getting the welcome png. If we will mention another png like old jpg, we'll get the another image which is present on my resource path, right? So it means once we are hitting the valid URI, try files is returning me the URI. If I will go with the some wrong options, instead of the old jpg I will go with some path which doesn't exist. So suppose I'm going to mention home alone over here, hit enter, then I will get the image which is the second option inside the try files. So first try file is going with the first URI, then if the second argument is valid, then try files always returning the second argument. So you can see whenever we are hitting the request with the help of the try files is always redirecting with the request. Once we are hitting the valid URI, it always redirect the request as per the server. Once we are hitting the invalid URI, it is always returning the second match best URI. So how we can avoid it? Suppose we want to avoid that, if exact URI will be hit, then it will only return the valid URL, otherwise it will return 404. How we can achieve that? So for this, let's again go back to the terminal and again edit the file. So we have defined few things. First is the URI, second one is the valid path. So let's make it invalid so that my request will forward to the next object. So I'm making it invalid and I'm going with this like images files underscore image.jpg. I know this file doesn't exist. So first it will check for the URI. If URI will not match, it will check for this particular path. If this particular path will not match, it will check for the video. Let's save this, reload the NGINX and let's hit anything. Suppose I'm hitting asset image. So see, we are getting for the enjoy the movie. So by this particular way we can achieve, if you want to show 404 if any resource is not found on your server, so you can achieve it. Why? Because try files always going with the last options once nothing is matching inside the given options. So I will declare one more thing over here and I will call it slash 404 and I will define one more location block for the 404 location 404 open close curly braces, inside the location type return 404 and returning some string. Sorry, this resource doesn't exist. I believe sometime you have seen these kind of messages whenever you have hit some incorrect URL. So how this is happening? This is happening with the help of the try files. Now what we are doing, first it will check for the URI. If URI will not match, it will check for the second option. This option is also invalid, so it will check for the third option. This is also invalid. Now it will go for the last one, which is 404, right? And on the 404 we are returning this particular message. So let's close this, reload the NGINX, go back to the browser, and first let's hit some valid URL. So I'm hitting like 8081 index.html. So this is the valid URL. My index.html present at the root path, so it is basically returning the index.html. Now I will hit the another URL like video, right? Video is also the part of the my try files, so it is returning the third options. Now let's hit some incorrect URL. So suppose I am hitting like video, hit enter. So this time video is matching, so that it is returning the video location. But what if I hit like this, user JSON, hit enter, I'm getting 404. It means the resource what I'm trying to hit, that doesn't exist. So try file have matches all the best possible options which is defined within the try files, and if something is not matching, then it is returning the last redirective or last directive from the nginx configuration. If you want to identify this from curl, you can copy this, go to the terminal and you can execute curl -i and paste it here, hit enter. See, you are getting 404. So this is the way how try files help us in the redirection if resources exist on the server and if resources not exist on the server. So team, if you have any doubt, any question, then please let me know. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training, and today we will see lab on the logging in NGINX. We will see how NGINX logging is works and how we can control the NGINX logging with the help of the configuration. So let's start with. And over here we are on terminal. If you will remember, then we have configured the NGINX log configuration where log NGINX. If we will go to the NGINX log configuration, so let's open the configuration at this particular directory cd where log NGINX. If you will put ll, then you can see two files are present over here. One is access.log and another is error.log. By default, NGINX create these two files, access log and the error log. All the error logs which is related to the NGINX server, they belongs to the error log and the request which you are hitting on the NGINX web server, and all the URI which NGINX is serving is basically called inside the access.log. You can also see we have the content in the access log and we have the content in the error log as well. Why we have the content in both of these log files? Because this is the default log file which we have configured with the NGINX and we are working on the NGINX instance log. If you will put ll-lsh, then you can see the access log is 205 kilobyte and error log is 76 kilobyte in size. Let's do one thing. Let's clear out these log files. So I will make the log files empty and I will also make the error logs empty. Let's get the size again, and both of the files are 0 in size, right? So we don't have anything inside the access log and inside the error log. If you want, you can open access.log. There's nothing. Cat error.log, there's also nothing. So what we will do now, we will tail on both of my files, right? We will tail on both of my files, or we will tail on this particular directory. So anything which will return inside the log file, we will get that particular using the tail command. So I will enter tail -f asterisk. It means it will print all the things on the console which is being written inside the access.log file or error.log file. Let's hit enter. So right now nothing is present inside the access.log and error.log. Now let's go to the first terminal and open the NGINX configuration file. And from the configuration file, I am removing all the locations and try files. So here is the basic NGINX file which will redirect me on the blogging template directly. I will save this. Now I will reload my NGINX. Let's go to the logs and you can see we are getting one line signal process started. It means that line is basically written in some log file. Now we will go to the browser and inside the browser we will open our site. So I'm opening my site on my IP and default port 8081 which is being configured inside my configuration. Hit enter and you can see my complete site is being loaded. Now let's go to the log file again and you can see we are getting a lot of logs over here. And these logs are basically being written inside the access.log file. See, this is the root request which we hit. Then it is loading every resource which is required, some CSS, then some CSS, then the main CSS. It is also loading the JS files. So team, all the call which is being made by the NGINX Web Server, they all are being written with the status code. They all are being written with the timestamp, the complete request URI, the protocol which is being used, the status code, and the data which is being transferred, the client who make that particular call, and what is the client version as well. So we are getting complete data inside the error log files. You can see last status code is 200. Let's do one thing. Let's go to the browser again and hit some random call. I know this URI doesn't exist on my server, so I will get 404. Let's go to the logs again and you can see we are getting 404. So now you can see we are getting two entries. One entry is made inside the error log file. You can see over here, this entry is inside the error log file, and another entry is being made inside the access log file. And inside the access log file, we are getting get slash nothing 404. And inside the error log file, we are getting blogging template nothing failed. There is no such directory. So many people have the conception that if we are getting 404, then that request must go inside the error log, not inside the access log. But that is wrong. 404 is also a valid status code, right? As per the HTTP request, 404 is also a valid status code, so that you are getting 404 request inside the access log as well. And inside the error log, you will only get the error. So error was user was trying to access this particular resource which is not available on the server. And this is the request which is being made. This is the client who made the request. This is the server to which server this request is basically made, and this is the request slash nothing. But 404 always will be print inside the access log. So whenever you are searching for the 404 in the NGINX log, you need to make sure that you will search the 404 inside the access log, not inside the error logs. Let's make some changes in the configuration and put some invalid configuration. So suppose I'm putting some invalid configuration and I'm removing this particular colon after here. Save my file and reload my NGINX. So you can see I'm getting the error over here. The same error you will get inside the error log. Inside the error log, we are getting the same error, unexpected curly braces at this particular line inside the configuration. Let's make it correct. Reload the NGINX, go to the error logs and see. We are getting signal process started. It means the error has been gone. So error logs and access log, both logs are basically printed inside the nginx.configuration file, and each request which you are hitting on your nginx, that is being print inside the access log. Now suppose you want to make some configuration changes. You want that if we are hitting some particular location, then that request will directly go to the access log. But if we are hitting some specific resource, that request will log inside the some another log file. So how we can do that? For this, you again need to go to the configuration and modify the configuration. So suppose I'm defining some location directive, and this time I'm defining the location directive like user data, and I want all the request which is hitting this particular location directive or which are hitting the user data, they must be logged inside some another access log. So first I will define return 200 and define the successful string user data is published. Close this, and over here I need to define some more directive like access underscore log. After this, I need to define the location at which particular location I want to create the access log for this particular URI. Suppose I'm defining where log NGINX and I'm defining access underscore user dot log. Let's close this, save your file and reload your NGINX. Go to the terminal and you can see signal process is being returned. Let's hit some space and go back to the browser. Now this time instead of the nothing, I will hit user data. Right, this is the location which we just entered inside the configuration. Hit enter. We are getting user data is published. It means request is served. Let's go back to the logs, and you can see a new line is basically being printed inside the access user log, right? User data. This line is not going inside the access log. You can see access log don't have this particular request. Only user access log have that particular request. If you will press Ctrl C, clear out the console, put ls, you can see access underscore user log is also being created. If you will put tail hyphen f asterisk and hit browser request one more time, now you can see log is only printing inside the access underscore user log. So all the access log for this particular request URI user underscore data will go to the new log file. So this directive access underscore log will be very helpful whenever you want some separate log files for the separate URIs. We have the user access, we have the user registration, we have the forgot password. There could be the n number of URIs which may present on your website. And if you want separate access log for each URI, you can define the access underscore log URI for your URI. Now suppose we have a very heavy traffic site and we want that some log should not be printed inside the access log or any log file, or they may be skipped. How we can skip any kind of log inside the nginx? For this, let's go back to the terminal again, edit the file, and suppose we want to skip the user data log. So we can define it with the help of the access log directive and provide a option off and provide a option off. It means off the access log for this particular URI user data. Save your file, reload the nginx, check the logs, nginx is reloaded, go back to the browser, hit the request multiple times. You can see I'm getting the response, go back to the logs, and there is nothing. It means no log is being generating for that particular URI user underscore data. So we have seen how we can partition the logs, how we can create the different log file for the different URI. And if you want to off the log for certain URI, you can also off the log for the certain URI. Same the access log, you can keep the error logs also in some different directories, but it is a good practice to keep a single file for the error logs but distribute the access logs, because if we have a very heavy website, then access log will be fill up very quickly, right? And to distribute the access log, we also can make sure that we can analyze the efficient data whenever some particular URI or some particular resource path will be failed. So it is a good practice to keep the single error file but distributed access file. So thank you team, thanks for your time. If you have any doubt, any question, please let me know. I will be happy to answer your questions. Hello team, welcome back. Welcome to NGINX training, and today we will see how we can handle the dynamic request in the PHP. Till now we were serving the static content, we were serving the HTML file, we were serving the PNG file, we was returning some standard string. Now we will see how PHP can handle the dynamic request. And if you remember, when we was discussing about the NGINX and Apache, we mentioned that NGINX is a single process application. Single process execute multiple threads to execute the request. And when we was learning about the dynamic content, we mentioned that NGINX will create the PHP FPM process to handle the dynamic request. Because dynamic request needs to be handled by the different process that is not being handled by the NGINX process itself, and that is the reason why NGINX work as a reverse proxy, because NGINX main process will initialize a process with PHP FPM. PHP FPM will handle and complete the dynamic request. It will submit the request to the main NGINX process, and main NGINX will serve the request to the client. So today we will see how we can handle the dynamic request, handle the dynamic PHP request with the help of the NGINX. So let's go to the terminal first. We are on our terminal, and to start the PHP FPM process, NGINX first need the installation of the PHP. So first what we will do, we will install the PHP FPM in our box. For this, first we will update the package. So apt-get, and we will execute the apt-get update. Let's hit enter. This is always helpful to update the package manager first. Now to install the PHP FPM, you need to execute a command apt-get install php-fpm. Hit enter, and this will download the PHP FPM. It will ask for your confirmation. Provide your confirmation and hit enter key again. This is downloading the PHP FPM process. Once the download will done, it will install the PHP FPM and you will get the success message on your terminal. So let's wait until the complete download and installation will be done. And you can see the complete download and installation is done. And over here we are getting that this particular PHP processing is triggered for the ManDB, unread ahead, labc and systemd. It means PHP service is by default created with this particular PHP FPM. If you go with this particular link, you can see a sim link is being created which is directly locating to the libsystemd system, right? And this is the PHP FPM service which is being created, PHP 7.2-FPM. So whenever we are installing the PHP FPM, PHP will create the service with the version. Why this is helpful? This is helpful because if you want to execute multiple PHP versions, you can do that particular thing. So over here, like the NGINX, we don't need to add the PHP as a systemd service. PHP is already added as a systemd service inside my system services. Let's clear out the console and verify the status of my service. So systemctl status PHP 7.2-FPM. Hit enter. There's a mistake. This should be PHP only. Hit enter. One worker process and see one master process and two worker process are running. If you will identify ps-aux grep PHP, it means show all PHP processes. You can see one master process is running with root user and two worker process are running with the www-data user inside the PHP. Now let's clear out the console and we will go to the browser. On browser, we will try to hit our website on port 8081 on which my website is running, and I'm getting my website running. It means NGINX is running and my website is also loading successfully. Now let's go back to the terminal and open the configuration file. So here is my configuration file. What I will do, I will clear out this particular location first. Now I will go inside the insert mode, and to work with the PHP, I will define the index. Index is a directive which you need to use whenever you want. Index is a directive which you want to use whenever you are working with the dynamic and static content. And the first file which I want to supply to index is the index.php. And if index.php is not available, then serve the index file index.html. Close this directive. So what I'm doing over here I'm supplying both of the index file, one for the dynamic process and another for the static process. And if you remember, index.html file is present at the root of my blogging site at this particular location. Now let's do one more thing. Let's modify the port as well, and we are again going to make the port on default 80. Let's save the program, reload the NGINX, hit enter. NGINX reload should be done. Go back to the browser and let's remove the port from here. Hit enter, and you can see my website is basically loading on port 80, right? Index.html is basically being loaded instead of the index.php. Why index.php is not loaded over here? Because in my file blogging template, if I will go to the blogging template, put ls, you can see there's no file called index.php, only one file present which is index.html, so that whenever I am hitting the request on port 80, the second index is basically being returned. Now let's again open the configuration file and put some changes over here. I'm defining another location. After this index, I will define another location and defining the root location, right? Over here, I'm defining the try files, and first it will return the URI. If URI is not matching, then second thing is return the URI at root path. If this is not matching, simply return 404 status code. So this is the location which we have defined. So what I'm doing over here, with the help, you can see this is the root location. So whenever request will land on the root location, first it will try for the URI. If URI not present, then it will go for the URI, then the all resource path. If this is also not present, then it will directly go to the 404. Let's save this, reload the NGINX, go to the browser and refresh this. See, this is go for the website. If I will go with like this is again go for the website. But if we go like this, test, hit enter, we are getting 404. So the same thing we have defined inside the try files. Now let's again go back to the terminal and open the configuration file. And over here, to work with the dynamic files, we need to define some more locations. So we will define location, then tilde dot slash php dollar, open and close the curly braces, format the braces, and go into the location. So this location I'm defining for the files which have the PHP extension. So all the files which have the .php extension, these files will directly work with this particular location which is just defining over here. And to work with the PHP, we need the dynamic process handling. And for the dynamic process handling, we need the fast CGI module. Fast CGI is simple protocol like the HTTP protocol, right? But that is for the dynamic module use of the NGINX. If you go to the NGINX configuration file location, cd etc nginx, put ll, you can see fast CGI configuration is basically already defined over here. This is the inbuilt module in the NGINX. If you want, you can open this particular file as well, fastcgi.conf, and you can see over here we have the different configurations. So what we will do to add this particular configuration, I need to include add, I need to mention include, then define the configuration. Close this, and after this we need to define another directive, fast CGI underscore pass. And over here we need to define the socket on which particular socket the NGINX and fast CGI process can talk to each other, because NGINX will create a forward request to the fast CGI process, and fast CGI process will accept that particular request and return back to the NGINX. So they need some socket, some communication point or some port to communicate. So we need to define that. So we will define like Unix colon, and over here we need to define the FPM socket location. So if you don't aware the FPM socket location, you directly go to the terminal, right? This is the same machine terminal on which we are working, and type find root hyphen name, it means we are finding some file at the root location which have the name like asterisk ending with the fpm hyphen shock. It means I need to find out all the files on this particular OS which have this particular extension. Let's hit enter and see, this is the location is run php 7.2 fpm.sock. Just copy this, go to configuration, paste it over here and close your configuration. Now let's save your file, reload your nginx, and we are getting some error. Let's see where we missed the curly braces. Okay, so here is a space missing, we need to add the space. See, in this particular location we are missing the space. Just close this, type nginx-t to check the configuration. Configuration is okay, reload the nginx. So we have reloaded the nginx. Now my nginx is able to handle the php requests as well. So what I will do, I will go to the blogging location. Right over here we have the files like index.html and assets. I will create one more file and call it, and you can call it info.php. Over here you need to mention some program which will provide you the php information. So just go to the insert mode and provide a syntax like colon question mark php, then call a function php info. This is the function inside the php which will provide you the php information. Close the question mark, again the question mark, and close the php. Team, this is the php file start syntax and this is the php file end syntax, and over here we have the php function which is defining the php information on my box. Just close this, right, put ls, and you can see we have the info.php available over here. Now let's go back to the browser, and over here you can see we have defined the file at the root path. I will try to access info.php, hit enter, and we are getting some new error. This time we are getting 502. We are not getting 404. It means resource is available but bad gateway. Nginx is not able to connect with the PHP process. Right? There is a gateway error. The gateway which we have defined fpm.sock. PHP process and Nginx process are not able to communicate, so that we are getting this particular error. This is not related to the resource. Resource is present, otherwise you will get the 404. And to rectify the error, we need to go to the error logs in the process. So over here, let's tail last 10 lines of the error logs. Log nginx error log. Hit enter, and here is the error. You can see it is saying the connection error on the Unix run PHP FPM socket, connection failed, permission denied. While connecting to the upstream client server request, and this request got failed, and we are getting the permission denied option. It means the nginx process and PHP process are not able to communicate. We need to find out why they are not able to communicate. Let's go to the terminal again and execute a command ps-aux grep nginx. Hit enter. This should be space. A space is missing over here. Hit enter, and you can see the nginx master process is basically executing via root user, but nginx worker process is executing by user nobody. If we will execute the same command for the PHP, then PHP master process is executing by the root, but PHP worker process are being executed by another user www-data. Here is the main problem. This nobody user don't have the permission to this particular process. So there could be the multiple ways to resolve this particular problem, but we will go with the simplest one. So we will again open the configuration file, and we will start the nginx worker process with the www-data user. For this you need to go to the insert mode, and at a global level you need to define the user, then the username www-data. This is the global directive I am defining, so all the worker process of this particular nginx will be executed by this particular user. Let's save this, reload the nginx, again find out the nginx process, and you can see nginx worker process this time is executing by a www-data user. Right now, if you will go to the browser and refresh my browser, we are getting the PHP info. This is the this page is basically being written by the PHP info file, right? The function we called inside this particular PHP file, PHP info. This is the data which is being written that particular function, and over here you are getting the complete detail, the system, build date, server API, virtual directories, and the complete detail which you need, right? This is a long file. PHP info is returning all the information regarding the PHP as well as this particular operating system. You can see zlib version and other versions are also mentioned over here, right? Inside the environment we are getting that which user is executing this particular environment. These are the PHP variables, the server user, and the other things. Now let's again go back to the terminal, and this time we will create the index.php file. So we will go to the blogging template, put ls. So we have the file index.html and info.php. Over here we will create another PHP file called index.php file. Why we are creating index.php file? Because we have defined index.html and index.php at the root location, and we have mentioned in the index that if root location is being called, then first preference should be the index.php instead of index.html. So call vi index.php, go to the insert, and over here we will print some data with the help of the PHP program. So I'm going to provide some basic echo commands over here. I will initialize the PHP file, close the PHP file, and over here I'm mentioning echo hello, echo welcome to NGINX training, echo enjoy all of the NGINX lectures. Let's save this, go to the browser and open your website 104, and you can see this time on the root axis I'm getting hello welcome to NGINX training, enjoy the NGINX lectures. How I am getting this? Because inside the configuration file, if you will open the configuration, we have defined the index, and first preference is for the PHP index, then for the HTML index, right? And inside the location as well, first it is trying for the URI, then going for the further resources, right? If you will search for index.html, then you will get the index.html. But if you directly go with the base URL, as per my configuration file, you will get the PHP file. So this is the way how you can configure the PHP process, how you can initialize the dynamic configure process, how you can prioritize the file which you can return at the first choice, which you can return at the second choice on the same resource path. And this has one more advantage, that if this file is missing, then by default this file will be returned, right? So this is the way, team, how you can create and configure the dynamic process inside the NGINX. If you have any doubt, any question regarding this particular lecture, please let me know. I will be happy to answer your questions. Thank you, team. Thanks for your time. Hello, team. Welcome back. Welcome to NGINX training. And today we will see how we can tune the worker process and worker connections in NGINX. But before this, we need to understand what is the application and what is the use of the worker process and worker connection, and why we need to tune the worker process and worker connections in the NGINX. So let's start with. So first we will discuss about the worker process. So if you remember, whenever we are executing the Docker PS, we are getting a master process and we are getting a worker process on a running machine. The binary of NGINX which user started, that is called the NGINX master process. But worker process is the process which NGINX itself started, and worker process is the main process who will communicate with the client. It means, as we discussed, that NGINX is a single process application, and that single process is the NGINX worker process. NGINX master process don't serve any request, and it just manage the worker process. Worker process is the actual process which is working with the client. And that is the reason, if you remember in the last lecture when we configured the dynamic process, right, we was getting the error 502 because NGINX worker process was running with the nobody users. So team, NGINX worker process is the main process who will communicate with the client. By default in the NGINX, the number of the worker process are 1. But if you want, for NGINX, you can increase the number of worker process, and each worker process will handle the request asynchronously which is coming from the client. To define the worker process in the configuration file, we need to use a directive worker underscore processes. We need to define the number of worker processes after this particular directive, and the number of process which you will define, that will be initialized whenever you reload or restart the NGINX. The worker process directive is responsible for letting our virtual server know how many worker to span once it has become bound to the proper IP and port. It means whenever I am going to start the NGINX, that how many worker processor need to be started as a part of that particular NGINX. This directive has the complete responsibility and which will initialize the number of worker process which will be defined after this particular directive. And how we can decide the number of worker process, how many worker process we need to initialize in our NGINX. So as a common practice, one worker process per core CPU. It means if you have a one core CPU machine, then you need to initialize only one worker process. If you have 4 core CPU machine, then you need to initialize the 4 worker process. If you have 8 core, then 8 worker process. If you have 16 core, 16 worker process, and so on. So generally we will keep one worker process per core CPU. So now we have two questions. What if we will define more number of worker process, and what if we define less number of worker process? So let's take an example. Suppose you are executing 2 core CPU machine and you will initialize 4 worker process in 2 core CPU machine. In that case, only 50% of each worker process will be utilized, right? Because 2 worker process are working on the same core machine. So both of the worker process will share the 50% load asynchronously, not the complete process will be used. Please remember, whenever we are defining more number of worker process as compared to the workcore CPU, we will never use the full worker process. Load will be distributed between the available worker process. If you have the 3 worker process for one core CPU, load will be distributed in 33%, 33%, and 33%. If you have 2 worker process for one core CPU, load will be divided 50%. If we have a 5 worker process, one core CPU, load will be divided 20% each, right? So generally and best practices, keep one worker process per core CPU. And vice versa, if we have the 2 core CPU machine and our NGINX is running with the one worker process, in that case, one core CPU will always be free, right? Only one core CPU will be used. Either you are executing 2 core CPU machine, but if your number of worker process is 1, then only one core CPU will be used. Second core CPU will not accept any traffic. So please make sure whenever you are defining the worker process, we always need to define the worker of process as per my machine size. So there could be the another challenge, that how we will identify the machine size, because configuration is hard coded in the product. It may possible that I will execute the same configuration on 2 core machine and I will execute the same configuration on 16 core machine. So do I need to change the number of worker process at runtime? No. With the worker process you can define an entity auto, and with the auto entity, NGINX will identify the number of CPUs available in your machine and automatically adjust the worker process. So as we discussed earlier, anything above one process per CPU won't hurt your system. It will not impact your system, but it will leave idle process usually just lying about. That not the complete process will be used. And the another important thing is worker process directive belongs to the global context. You need to define the worker process at the global context. The second directive is the worker connection. What is the worker connection? So each worker process will create the worker connection which is defined inside your configuration file. So suppose you have worker connection defined 600 and you are using 2 core CPU machine. So 2 worker process are running. So totally 1200 worker connection will be available for your NGINX. 600 for the process 1 and 600 for the process 2. If you have 1000 worker process defined, then 2000 worker connection will be available for your NGINX, 1000 for the process 1 and 1000 for the process 2. This directive tells our worker process how many people can simultaneously be served by the NGINX. So if we are defining 1000 worker connections per CPU, it means that particular worker process can simultaneously handle 1000 connections per second in the NGINX. Again, there would be a question that how we will identify that how many worker connection do I need to define. It could be limited or it could be unlimited. So we'll discuss about it. This is the child process of the event context. So worker process is the directive for the global, but worker connection is the directive for the event context. The default value for the worker connection is 768. However, consider that every browser usually opens 2 connections, so this number can be half. So this is the default value, but we can change it. User can check our course limitation by issuing a ulimit command. So whenever you are using the NGINX on your OS, you need to execute a command ulimit-n and you will get a output that how many worker connections can be defined on your OS. Ulimit basically define that how many IO operation input output operations your OS can perform on a single second, right? So with the help of the ulimit, we will identify the number of operations we can support, the OS can support. Then we will define that number within the worker connections. Suppose if we have the directive like worker underscore connections 1000, this means that nginx per process can serve 1000 client per second. 1000 concurrent requests can be handled per client per second if we are defining the worker connections 1000. There's one more thing, if you want you can define the ulimit as well, but I don't recommend that particular practice. So we have discussed about the worker process and worker connections. Let's go to the terminal and let's see how we can use that. So over here we are on a terminal. Let's execute a command ps -aux -forest nginx. Hit enter and you can see we have the one master process and this master process have one worker process. So by default, if we don't have any change regarding the worker connection, worker process in our nginx, then one worker process is basically being initialized by the nginx. Let's go to the nginx configuration file and edit the number of connections. So over here, suppose I'm going to define insert mode worker underscore processes, right? I'm defining 4. Save your file, check the file status -t, system is okay. Reload the nginx -s reload, hit enter. And now let's execute the same command ps aux -forest grep nginx. So what we are doing, we are basically identifying the number of nginx process. With the help of the forest command, we will get the parent child relationship as well. And over here you can see one nginx master process and 4 nginx worker process are basically initialized because we have defined the number of worker process in our machine. But we need to make sure that what is the CPU size of my machine. So either we know because we have created one core CPU machine, but if you want to find out from the command prompt, you can execute a command ls cpu, hit enter, and this will show you output like this, which is a verbose output, and over here you are getting the number of CPUs available. So we have one core CPU machine. Clear out the console. There's a one more command to identify the number of CPUs, which is nproc. If you will execute nproc, it will also define you the number of CPU which we are using, right? There could be the multiple commands as well. You can identify the CPU with the help of the top command as well, but these are few commands which you can use. So ideally 4 worker processes are running on my nginx, and as per our last discussion, this is not the recommended way, because in this particular way none of the nginx process will be fully utilized. Only 25% of each will be utilized because we are using one core CPU and 4 nginx process, and ideally there could be only one worker process per core CPU, right? So how we can manage this? Let's again modify the nginx file, and this time instead of the hardcode number, define it auto. So by an auto argument as a directive, nginx will automatically identify that the core of running machine and start the nginx worker process. Let's close this, reload the nginx. Nginx reload is done. Again, identify the number of process running, hit enter and see. By default, Nginx started only one process because this is the one core CPU machine. If you will spin up 4 core CPU machine, 8 core CPU machine, 2 core CPU machine, the same configuration will automatically work for you, and it will start the number of worker process as per the machine size. So this is the way how we can manage the number of worker processes. Now let's see how we can manage the number of worker connections. And to define the number of worker connections, first we need to identify the ulimit of my system. So I will execute a command ulimit -n, and for my system ulimit is 1024. 1024 is the ulimit for my system. This ulimit is basically explaining that at instance 1024 IO operations can be handled by this particular machine. As nginx also handle the input output operations because it is reading the file, right? Because it is reading the file, constructing the file. So this could be the number of worker connections you need to define inside your nginx. So let's modify the nginx conf again, and inside the events we need to define the worker connections. This is the directive which we need to use. Define 1024, close this, save the file, check nginx -t, configuration is okay, reload the NGINX configuration. NGINX reload is done, and now this particular NGINX process can handle 1024 requests per second, right? So this is the way how we can define the number of worker process and worker connections. Also, you can understand the importance of these particular configuration. These are very important configuration whenever we are going to define the load balancer or the web server for my machine, because these few things can impact the performance of your system very badly. If these things are not properly tuned, it may possible you are executing the high configuration machine but you are getting the low configuration machine traffic because your nginx is not tuned accordingly. So team, if you have any doubt, any question regarding this particular lecture, please let me know. I will be happy to answer your questions. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to Nginx training, and today we will see how we can optimize the performance of Nginx server. In last section, we have discussed about the worker process, worker connection, which is also the part of the Nginx performance optimization. Today we will move further and we will see what are other options do we have to optimize the performance of Nginx. So after the worker connections and worker processes, we have the another thing which is called buffer. Buffer size is another aspect to manage the Nginx performance, and buffer is something which will Nginx use to write the data between the memory and the hard disk. So suppose we have an Nginx process which accepting the connection from the client and which is accepting the post request. Post request has a body and that body Nginx need to save. So first Nginx save that particular body inside the RAM memory. But if we don't have the enough space and as per the Nginx configuration, the buffer size is basically defined low, then Nginx will save that particular thing in the system memory. This process where Nginx is basically saving the post body in the RAM memory is called the buffer. And we need to make sure that we are handling the buffer very efficiently. If the buffer size is too low, then Nginx will have to write to the temporary file, causing the disk to read and write constantly. It means if the buffer size is low, then Nginx will need to write the file into the system memory. That will take the disk read and write, and which is constantly slow. It will slow down the complete Nginx server. So we need to make sure that we will define the accurate buffer size for the most of post request. Before this, first we need to identify that what is the size of the most post request what my application can accept, and according to that we can set the buffer size in the nginx. these are the few directives which will help to these are the few directives which will help you to manage the buffer size. The first is the client body filter size. This handles the client buffer size, meaning any post actions sent to nginx. Post actions are typically from the and post actions are typically form submissions. So client body buffer size, after this you need to define the buffer size which client body can accept. You can define 1 kilobyte, 10 kilobyte, 10 megabyte, 100 megabyte, whatever required as per your application. Generally the body could have the form submission data or REST API data which will have the JSON format. So ideally you need to identify that what is the general size of post request which your application can accept, and that size could be the part of the client body buffer size. Similar to the client body buffer size, we have the client header buffer size, that what is the header client is sending. Sometimes the header could be long because you are sending a lot of data inside the header like the credentials, secrets, cookies. So similar to the client body buffer size directive, client header buffer size will only accept the buffer size for the client header. So we can take an example. Suppose the client header size is 1 kilobyte, but your client buffer size is 100 byte. So this is not basically fit in your buffer size. In that case, Nginx will try to write the complete header in the hard disk and read the complete header from the hard disk. That will hit the performance of the Nginx because hard disk read write is more costly as compared to the RAM read write. Then we have the client max body size. Client max body size basically allow the maximum size of the client request. If the body that client is sending that is exceeding this particular request, then the user will get the status code 413 with the message request entity too large. This is the common error code you have seen in your application during the developments. So whenever you are defining the client max body size low and the body which you are sending in the request is a big, you will get this particular error on your box. In the similar way, we have the large client header buffers. It means suppose for some request we have the large client headers, right? Then we need to define the maximum number of large client header per process and the size of the buffer as well. So these are few parameters which you can use to manage the buffer side inside the NGINX configuration, and these directive needs to be defined inside the HTTP context. Similar to the buffer, we have the another which is called timeouts. And timeouts, as simply explaining by itself, timeout is something if request is not fulfilling in a particular timeout, then we need to send the timeout code. This has few directives like client body timeout and client header timeout. These directives are responsible for the time a server will wait for a client body or client header to send after the request. So once the server will accept the request, right, server need to send the response. In the response, server need to send the header and server need to send the body as well. So server will wait for the defined client body timeout and client header timeout before sending the data to the client. If that particular time is exceed, then server will throw the 408 request timeout error. So this is another common code which you have seen multiple times during the development, right? 408 is a common code. Sometimes when server is not able to fulfill the request, we may get this particular error. And in the Nginx, that can be managed with the help of the directive client body timeout and client header timeout. Similarly, we have another one, keep alive timeout. Keep alive timeout assign the timeout for the keep alive connections with the client. So whenever client is creating the connections with the Nginx, if you have defined the keep alive timeout inside the configuration, then client and server connections will be alive for that particular time, right? Nginx will not close the connection for that particular time if the request processing is not done. And if that particular timeout is basically exceed, then Nginx will close the connection with the client. Then we have the next one which is called the send timeout. Send timeout is another important aspect to tune the Nginx performance for large or heavy traffic applications. Send timeout establish not only entire transfer of the answer but only between two operations of reading. If after this timeout client will take nothing, then Nginx will shut down the connection. It means whenever client and server are basically establishing the connection and we have defined the send timeout, then the connection will not wait for the entire transfer of the data which client is requesting. And next one we have the Gzip compression. What is the Gzip compression? Why we use it? So Gzip compression can help to reduce the amount of network transfer Nginx deals with. However, we careful increasing the Gzip compression level too high as server will begin wasting CPU cycles. So whenever data communication is happening between the server and the client, and if you have not defined the Gzip compression, then the complete data will be sent over the network, which is the big size. But if you have defined the Gzip compression, then first data will be compressed, then will transfer over the network. So with the help of the Gzip compression, we will reduce the amount of the network transfer. Here are few directives which you can use for the Gzip compression, like gzip on, gzip compression level 2, gzip minimum length 1000, and what kind of data you want to gzip. Text plain, application X JavaScript, text XML, text CSS, application XMLs. Right? You can define a number of things over here. So this is the way how you can minimize the network transfer as well. And these directive also needs to be defined inside the HTTP. Till now, all the directives which I mentioned, either that is related to the buffer, either that is related to the timeout, or either that is related to the Gzip. All these directives are the part of the HTTP context. Then we have the static file caching, which is the another feature of the Nginx. And as I told you that Nginx can also work as a caching system. So it is possible to set expire header for the files that don't change and are served regularly. This directive can be added to the actual Nginx server block. Whenever you want to define the static file caching, right? Nginx will make sure that in few requests, few files are basically requested by the client, and every time the header is same. So Nginx will keep these files inside the caching system, and you can define these kind of block for these, then define the regular expression, then define the file types. Over here we're defining the files which have the extension jpg, jpeg, png, gfi, ico, css, js, right? By default the expiration period 365 days, it means a year. So by default, Nginx will keep these files, JPG file, JPEG file, PNG file, GIF file, CSS file, JS files inside the Nginx cache. And every time whenever client is sending the request for the server and header is same, these file will be served from the caching system. This is a very recommended way to tune your Nginx performance. So thank you team. This is about the performance tuning of the Nginx. But before closing this lecture, let's see how we can define these directive inside the configuration as well. So I'm opening the configuration file in a Visual Studio on my local system. So here is a configuration file, right? You can see over here we have defined the HTTP context. So we are defining the buffer size for the post submission, client body buffer size, and client max body size. Over here you can see I'm defining the client body buffer size 10K. It means it will accept up to the, it means all the post requests which have the body size within the 10 kilobyte, they will be served as a buffer. The post request which have the size more than 10 kilobyte will not be served as a buffer. Then we are defining the client max body size, which is 8 MB. So team, these few parameters are very simple. Suppose if you want to define for 100 kilobyte, you need to define like this. Suppose you need to define this particular directive as a 100 byte, you can define like this. Suppose you want to define like a 100 kilobyte, you can define like this. Suppose you want to define like 100 megabyte, you can define like this. This is not case sensitive, so you can define capital M or small m, this nothing matter. You can define capital K or small k, that doesn't matter as well. Then we are defining the client max body size. So if client body will exceed 8 megabyte, then you will get the response code 413 request is too large. Similarly, we have the client header buffer size, which is set 1K, right? We discussed about it. Then we have the timeout, client body timeout, which is 12 millisecond, and client header timeout, which is also 12 millisecond. By default, this is set to 60 second. If you want, you can manage this. Suppose you want to set it to some other value like 30 a second, so you can define like 30s over here. You want to define this for the 45 seconds, so you can define 45s over here. S means second. If you want to keep it for minutes, you can define like 10 minutes, you can define like 10m. If you want to keep it up to hours, you can define 10 hours like this, up to days, 10 days like this, and up to years, 10 years like this. But these are useless. We generally work with the seconds and milliseconds. Then we have the keep alive timeout, which is 15 millisecond. And then we have the send timeout. Send timeout we didn't discuss. Send timeout is something which will max time for the client accept or receive a response. So whenever server is sending the response, if client is not accepting the request within that particular timeout, server will drop that particular response. Then we have the another one, which is the send files. So after the caching, this is another important directive, right? Send file, what will do, if we are using the send file on, then NGINX will directly read the file from the hard disk. It will not keep it inside the buffer and directly send to the client. It means if we are using the send file on, then NGINX will not buffer the static files. NGINX will directly serve the static file from the hard disk to the client. Then we have the TCP on push, which will optimize the send file packages, and this is for the location of the caching. Right, so this is the way team how we can manage the performance of the NGINX. We'll attach this particular file as a resource of this particular lecture, so you can get it if you need it. Thank you team, thanks for your time. Hello team, welcome back. Welcome to NGINX training, and today we will see how we can add the dynamic modules in the NGINX. So if you remember, we have built this particular NGINX from the source code, and now we want to add more modules in the NGINX, so we need to again build the NGINX from the source code. For this, we will go to the terminal and we will see how we can add the modules in the NGINX. So we are on our terminal. First, let's see how many modules do we have as a part of my NGINX. So I will go to the directory etc NGINX. Over here, put a command ll or ls, what you want. And over here, you can see we don't have any directory called modules. It means if we have some handcrafted modules over here, then a new directory will be created at this particular location called modules. So we need to verify that how we can add the modules in the NGINX. For this, first we need to identify the configuration which we have set up on this particular NGINX when we started this NGINX. So you can identify this configuration with a simple command nginx -V. Hit enter and you can see we are getting the configure argument over here. We will copy this particular arguments and save at some location on my box. Now let's clear out the console. Now we will go to the root, put ls, and over here we have the nginx jar and the nginx directory which we used earlier. So we will go to the nginx first, put ls, right? And over here we have the configuration and the other things which we executed earlier. Now we need to identify that how many dynamic modules are present in this particular configuration. For this, you need to execute a command configure -help. So you can see it will list out all the modules which are the part of this particular configuration. So we are getting few path modules, then we are getting few name modules, few dir modules, free group modules, and you can see we are getting few dynamic modules as well. So let's filter out all the dynamic modules from this particular configuration. I will clear out the console again, execute the same command and put grep over here and call dynamic. Hit enter. So these are the dynamic modules which we have inside my NGINX. So over here we are getting the different dynamic modules like XSLT, image filter, GUIP, Perl, mail, stream, and other things. Suppose you want to add any of the dynamic modules in the NGINX configuration. For this, again need to execute the configuration and provide the parameters which we want to configure the NGINX. So earlier we have provided these parameters to configure the NGINX, which we copied from the NGINX-V. Now we need to add one more module, so we will provide that particular dynamic module. We will copy this, and suppose we are providing this image filter dynamic module, and after this we need to mention like hyphen hyphen modules hyphen path equals to etc slash nginx slash modules, right? Hit enter, and you can see the configure is started working, but we are getting the error, and the error is that image filter module requires some GD library, so we need to include that particular library as well. I will clear out the console and execute a command apt get lib gd -dev. So we will install the GD library first, provide the confirmation, put yes. It will download and install the GD library. Let's wait until the library installation will be done, and this is done. Let's clear out your console and execute the same configuration again. Hit enter, and we can see this time configuration is successfully done. Let's clear out the console and we will execute a command again, make. So we will execute the make. It will take some time. We have to wait until the complete process will done. This will take some time, so we have to wait. You can see make is done. Let's clear out the console and install the new configuration by make install. This will install the new dynamic module over the existing installation of the NGINX. Hit enter, and it's done. Clear out the console, execute the command ps-aux grep nginx, and nginx is running on my machine. Let's check if the new configuration is a part of the nginx or not. So nginx -v, hit enter, and we can see new module is the part of the nginx, and we are getting the module path at etc nginx modules. You can verify this if you will go to the cd etc nginx, hit ls. New modules directory is basically being created over here, and if we will go to this particular directory modules, hit ls, we are getting the newly dynamic module so file. This is the encrypted file, so you cannot see the content of this particular so file. Let's go back to the configuration, clear out the console, and as we have included the image filter module, so we will identify some image path which is already the part of my website. So we will go to the blogging. Inside the blogging we have the assets, inside the assets we have the personal, and inside the assets we have the like images. Inside the image I believe we have about, put ls, and over here we have the welcome banner, profile image, and old jpeg. So let's copy this path, and this is the complete path. Let's go to the browser. We will open our site. So my site is loading on the default PHP as we configured. So I will provide the path, and after this I will provide the image name. And suppose this time I want to open this particular profile image JPEG, or we can open the welcome banner JPEG as well. So I'm opening the welcome banner JPEG. You can see we are getting the image successfully over here. Now let's do one thing. Let's modify the nginx configuration as per the module which we just created. So we will go to the terminal back, and over here we will open the configuration vi nginx.conf. And over here I will add one more location to work with the image filter module. So I will add a location like location equals slash define my complete path, and this is the path of my image. Remove this double slash from here, close, open and close the curly braces, hit enter, format your file, and now we need to define the directive inside this particular location, but we don't know what is the directive available for the new module which we just included. So we will go to the browser and we will search for the nginx org. We will open the nginx.org, we will go to the documentation. Inside the documentation we will go to the dynamic modules, and here we are getting all the modules, and we will search for the module we just included. So we included image filter module. We will open this nginx http image filter module, and over here you will get the complete information about this particular module. So if you see, you can have the filters like image filter off, image filter test, size, rotate and resize, crop and other things as well. Suppose we are accepting this particular thing, rotate, right? I will copy this and define over here, and suppose I'm rotating my file at 180-degree. Just close this, save your file and test your nginx configuration, nginx-t, hit enter, right? And we are getting the error that unknown directive. Although we have included the module, but still we are getting the unknown directive image filter. Why we are getting this particular error? This error is because although we have included the dynamic module in my configuration, but nginx still don't know about the dynamic modules. So we need to aware the nginx that we have the dynamic module for these particular directives as well. And how we can do that? So we will again go to the configuration, right? And inside the global context, we will add load underscore module. And inside the load module, we need to define the SO file path. What is the path of my SO file? So let's open this terminal. Let's go to the etc NGINX, right? Put LL. My NGINX configuration is present at this particular location, etc NGINX. NGINX configuration is present over here. Now at the same location, we have the path modules. So we will go to the modules, put LL, and inside the modules, we have the NGINX HTTP image filter SO. So I will copy this, go to the terminal back, and over here we need to define the complete SO path. So my file is present etc NGINX. After that we have the modules, and over here we have the SO file which we just copied from here. So this is the name of my SO file. I will copy it here, close this, save your file, and again execute nginx-t. Configuration is okay. Reload your nginx. So nginx-s reload, hit enter. Oh, there is a mistake in the spelling. This should be nginx. Nginx reload is done. Go back to the browser. Now we will go over here. We will copy this particular path. We will open a new browser like Firefox. Why we are opening the new browser? Because it may possible that your browser will read the file from the cache and it will not reflect in your browser. So we will open in a new browser, and you can see file is rotated 180-degree. If you want to modify this one more time, go to configuration, edit the file, edit the rotation. Suppose we are rotating it something else like 270, save the file, reload the configuration, go to the browser, refresh your browser. So see, you are not getting it reflected, but if I will copy it, quit the Firefox, open the Firefox again, open the Firefox in incognito mode, paste this URL, hit enter, you will get it reflected. See, this time this is 270-degree. So team, please make sure if you are rotating the image and your image is not rotating in your browser, so please make sure you are clear the history and cookies of your browser and refresh the URL again, or try to open that in incognito mode of some other browser. This is the way how we can add the dynamic modules inside the nginx. If you have any doubt, any question, then please let me know. I will be happy to answer your questions. Thank you team, thanks for your time. Hello team, welcome back. Welcome to NGINX training, and in this section we will see how NGINX will work as a reverse proxy. First, let's understand few applications of the reverse proxy, what is the concept of the reverse proxy and what are the benefits of the reverse proxy. So let's start with. So first we will try to understand what is reverse proxy. So reverse proxy is a server that sits in front of the web servers and forwards client requests to those web servers. So whenever we are talking about the reverse proxy, we are talking about a server which will sit between the application web server and the client. Client are the web browsers or the tools which are hitting the request on your web servers, and web servers are the front end application of your application. Reverse proxy is something which will be established between the client and the web servers. Reverse proxy typically implement to help the increase security, performance and reliability. So why we need the reverse proxy between the client and the web server? We need the reverse proxy to increase the security, to increase the performance of the web servers and to make the reliability. And shortly we will discuss how web server will increase the security, performance and reliability. Right now there are three entities on your screen. First is the web client, second is the NGINX, and then we have the application server. Whenever a user or whenever a client will hit some request, that request is basically served by the front end server of your application. Then why we need nginx? Nginx is an entity which will be work as a reverse proxy between the client and the web server. So first, whenever client will try to access the application, client will send a request. That request will land on the nginx directly. Then nginx will basically accept the request and calculate if the request is valid. If the request is valid, then as per the nginx configuration, it will forward the request to the application server. Application server will process the request and forward the response to the nginx, and nginx then forward that particular response to the web client. So over here you can see, although the communication need to be between entity 1 and entity 3. Entity 1 is the web client and entity 3 is the application server, but all this particular communication is going through with the help of the entity 2, and entity 2 is the nginx, which is working as a reverse proxy server between the web client and the application server. This all processing, this all particular data flow called the reverse proxy, whenever nginx is working as a reverse proxy on behalf of the application server. So web client is not hitting the application server directly, web client is hitting the nginx, and nginx further communicating with the web client. In the same way, response which web client is getting, that is not basically getting directly from the application server, that response is basically being forwarded by the nginx. Now let's try to understand the benefit of this particular model. So the reverse proxy have the multiple benefits, and first is the load balancing. So whenever we are talking about the load balancing, nginx is work as a load balancer as well. And how nginx will work as a load balancer? Because in the nginx you can define multiple upstream or multiple backend or front end application, and on the basis of the URI which client is hitting, that request will forward to the specific application. We have already discussed about it in the earlier lectures as well, that you can define the multiple locations in the nginx, and each location will forward the request to each specific server, and shortly we will see how we can do it as well. So why we need load balancing? So suppose you have a popular website, right, and that gets million of users every day, and it may possible that the single origin server will not be able to handle all the incoming traffic from the million of user. So instead the site can be distributed among the pool of different servers. It means we will create the different front end servers with the same configuration, and all the requests which coming on your website on your domain, that request will be distributed among the multiple web server, and all these servers will be handling the request at the same time. This is called the load balancing. With the help of the reverse proxy, we can provide the load balancing solution which will be distribute the incoming traffic evenly among the different servers to prevent any single server from becoming the overloaded. So by this particular way, we are basically saving our servers from the overloading, and by distributing the request on the multiple web servers, we are also improving the performance of my application. And this approach also prevent us from the failover. It means whenever a single server is going down, that server will not accept the request anymore and the other server will accept the request. If we are not using the load balancing and server is going down, then your complete production site will be down because your front end is not accessible. The second benefit is the protection from the attacks. How reverse proxy are protecting the application from the attack. So with the reverse proxy in place, a website or service never needs to reveal the IP address of their original servers. Whenever you have the web proxy in between the client and in between of your application servers, so the IP address of your application server are not exposed to the outside world. right? Because all the clients are basically communicating with the reverse proxy. So this make it much harder for the attackers or the leverage to target the attack against, such as a denial of service attack or CDN attack and many more attacks, because we don't know what server are basically serving the request. There is a third entity which sits between the application servers and the users. So it will be very hard to hack such kind of system or attack such kind of system with the DOS or CDN attacks. And the another benefit is the caching. We already have discussed that NGINX is also work as a caching system. So reverse proxy can also cache the content, result in the faster performance. So let's understand the caching model with the help of an example. Suppose your application server is situated in the Tokyo and some of your users are trying to access your application from the London. So what will happen? The request will go through from London to Tokyo and response will again go through from Tokyo to London. That may take some time and that may introduce the network latency in the access of your website. But if you have the reverse proxy model and you have the Nginx server which is present at the London location as well. So whenever some user are basically hitting your website, they are getting index.html page. Once the first user will hit the request, NGINX Web Server which is situated in the London will hit the request on the application server and it will get the index.html. Now once another user will hit the same request or multiple user will hit the same request from the same location, reverse proxy server or nginx server will not hit the application server from the same resource. It will cache the resource and directly serve the request from the caching. It means all the users which are hitting the same request, they will get the response from the web server which is located in the London, not the application server which is located in the Tokyo. So that will improve the performance of your website and that will also improve the user experience. Next one is the SSL encryption. So if you are hitting the request on the HTTPS, so whenever you will hit the request, that request will be encrypted over the network and decrypted over the application side. Then again, response will be encrypted at the server side and decrypted at the client side. So whenever the traffic is flowing between the network, that traffic is the encrypted traffic. So suppose encryption and decryption, all the things are basically also processing by the application server, then application server need to do extra work, right? So the encryption and decryption communication for the each client can be computationally expensive for the application server. A reverse proxy can configure to decrypt all the incoming request and encrypt all the outgoing response, freeing up valuable resource on the origin server. It means if you have the reverse proxy model, then reverse proxy will do the encryption and decryption on the behalf of the application server. Application server do not need to encrypt and decrypt the request which it is accepting. So suppose a million of requests are hitting your application server, then application server don't need to encrypt and decrypt all of the million of requests. Nginx server reverse proxy server will decrypt the request and encrypt the response on the behalf of the application server. This will also free your application server to do the lot of work, and application server will be more effective in terms of the request processing instead of the encryption and decryption. So these are the benefits of the reverse proxy. This is the concept of the reverse proxy. If you have any doubt, any question, then please let me know. In the coming lectures, I will show you how you can configure the reverse proxy in Nginx. So thank you team. Thanks for your time. Hello team, welcome back. Welcome to Nginx training. In the last lecture, we have seen how we can configure the reverse proxy. And today we will see what is the use of X real IP directive. So after the reverse proxy configuration, you will get some issues and we will discuss how we can resolve that particular issues with the help of some special directive in the Nginx. So let's start with. So let's discuss what is the issue you will get after the reverse proxy configuration. So over here we have the three entities: web client, Nginx and the web server. Web client will send the request to the Nginx. Nginx as a reverse proxy will send the request to the web server application. Web server application or the front end application send the response back to the Nginx and then it will send the response back to the web client. That is the complete flow of the reverse proxy. Now let's see, we have the hypothetical IP address of the web client, Nginx and the front end server. We have 192.0.0.1 which is the IP of the web client, 192.0.0.2 which is the IP of the Nginx, and 192.0.0.3 which is the IP of my front end web server. So what will happen, suppose you are opening some website. So you will open the website with the help of the web client like a web browser. That web browser will hit the get index.html request on the web proxy server. Then that particular web proxy server or the NGINX reverse proxy server will send that particular request to the front end application, and front end application basically will get that particular request from the IP of the reverse proxy instead of the IP of the web client. So web client have the IP 192.0.0.1, which is sending the request to the Nginx, and Nginx is further sending the request to the front end application server. So in that case, with the reverse proxy, the front end application is getting the request from the 192.0.0.2, which is the IP of the reverse proxy, not the client. So if we have set up the web proxy, right, then all my web servers or my single web server always get the request with the Nginx reverse proxy instead of the client. This creates the problem in the production because many applications have the IP related binding, many applications have the IP related coding, IP related application, throttling. There could be n number of things which can be associated with the IP. And every time if I'm getting the same IP which is not the IP of my client, then that could be a problematic scenario. Why? So suppose 1,000 clients are basically sending the request at the same time. So 1,000 clients are sending the request to the different IP addresses at the Nginx reverse proxy, and then Nginx reverse proxy are sending that particular 1,000 request back to the web server. So web server will assume that all these 1,000 requests are basically coming from the same IP address. Web server will not be able to differentiate the IP address because web server is getting the request directly from the reverse proxy, not the client. In that case, the IP specific challenges will be faced, right? You cannot apply the throttling in that particular case. Suppose you want to apply the throttling on the IP address, you cannot apply that particular throttling, right? So there could be the multiple kind of issues whenever you will introduce the reverse proxy with the web server if the IP handling is not being introduced. And if you want to see, I can show you. So let's go to the terminal, and you remember here is the machine on the black terminal. This is my brownie machine on which my brownie website is running, and the machine nginx reverse proxy on the blue server. This is the reverse proxy machine, right? So first let's go to the black window and tail the log, tail -f where log nginx, and tail the access log, access.log file. I will put out some separator over here so that I can separate out the logs. Now I will go to the browser, and in the browser I will hit my IP 130, which is the IP of my black window machine. So I will reload this particular page. You can see reload is completed. I will go to the terminal, and over here you can see a lot of log are being generated, right? After the separator we have a lot of logs. Here you can see the request is coming from this particular IP 103.47.18164. What is this particular IP? This is the IP of my local machine. If you want to see, I can show you. You can go to the Google and type what is my IP. Google will find out your IP and it will print over here. So your IP is 103.47.18164. This is the IP of my local machine, my Mac machine, and same IP is basically being listed over here. So this time we are getting the request from the client. Now let's put some separator here, tail the logs over here as well, tail -f where log nginx access.log file. I will put some separator over here as well, and this time we will go to the browser, and instead of the main website or main web server I will hit the reverse proxy. Reverse proxy is running on 205, right? I will reload this particular web page. Request is completed. I will go to the logs. You can see on the web proxy I'm getting the log and I'm getting the correct IP. This is the IP of my Mac machine, and I'm hitting the web server on 205. But if we will go to the actual machine where the application is running, this is the reverse proxy which is forwarding the request to the brownie site, right? But brownie site is running on this particular website. Over here you can see the client is 206.189.132.205. This is the IP of my reverse proxy machine. This is not the IP of my Mac machine, right? So although I'm hitting the request from my Mac machine, but that request first landing on the reverse proxy like here, and reverse proxy is sending that particular request further as per the configuration. And if we will go to the actual web server, then web server is accepting, then web server is getting the request from the reverse proxy. So how we can resolve this? How we can forward the client IP instead of the reverse proxy IP to the web server machine? So let's put Control C, clear out the logs, and over here we need to find out the config command which we have executed. So we will type nginx hyphen capital V, right? So these are the arguments which we have passed. We have passed the nginx sbin, we have passed the configuration file, the log path, the http log path with pcr, pid path, with ssl module, image filter module, dynamic, which we added. So we will copy these all arguments and paste it somewhere at the safe place. Now after this, what I will do, I need to add one more module over here. Which module we want to add? So let's go to the nginx website. I will call nginx.org. Over here, let's go to the documentation, right? And over here we are getting the different reference modules. Let's search for the real IP. Here we are getting the nginx http real IP module. Let's see if we have some other entry. We are getting nginx stream real IP module as well. So which module we are going to include? We are going to include this particular module, nginx http real IP module. Let's open this. And over here you can see we are getting some syntax, some directive as well, that real IP header and set real IP from and other directives as well, right? So what we will do, first I will include that particular module. So this module can be enabled with the command with http real IP module. If you don't want to follow this document, you can directly go to the terminal and you can go to the location where the nginx is installed. So nginx is present at this particular location, in my case cd root, then my nginx, put ls. Over here we have the configure, so we will execute configure hyphen help, then put grep, and then put a real IP, hit enter. So we are getting two modules with http real IP module, with stream http real IP module, right? So this is to enable the nginx http real IP module, and this is to enable the nginx stream real IP module. So what I will do, I will execute a command configure, then I will paste the earlier path. So first I will copy this and provide over here. Then after this I will provide this module as well. So first I will copy this, then I will paste this inside my configuration. So I am adding one more configuration in my nginx. Let's hit enter. This will take some time, we have to wait, right? You can see the configuration is done. Now I will clear out the console and execute a command make to compile and build the nginx. So it will take some time, we have to wait until the make will complete. You can see the make is completed. I will clear out the console and install one more command, make install. Hit enter. This is executed, right? Clear out the console and execute ps-ef grep nginx, right? Nginx is running. Let's see if the module is included or not. So nginx hyphen capital V. So we can see the module is included. Clear out the console. Now after this, I will tail my logs, tail hyphen f, var log nginx access.log, and hit a one request from the original machine. So first I will hit a request from the 103.130, and you can see I'm getting the request from my IP, right? Now I will move further and separate out the logs. I will go to the proxy server, and inside the proxy server I will edit the nginx configuration file again. Over here first, over here we will go to the location where my proxy is basically forwarding to this particular IP. Then here we will add some directives. So what directive do I need to add? I need to add the set header proxy directive with the x real IP. So these are the two directive, proxy set header x real IP remote addr and proxy set header x forward for proxy add x forwarder for. Remote addr and proxy add x forwarder for are the variables in the nginx. Remote addr address means the remote IP address which will be saved in this particular directive, and proxy add header forwarded, it means forward the complete header, and complete header will be saved in the x forwarder 4. Now let's save your configuration, reload the nginx-t. My configuration is okay. Now I will reload the nginx by command nginx-s reload. Nginx reload is done. Let's tail the logs, var log nginx, put some separator over here, and we also have the separator over here. Right now we will again go to the browser And inside the browser, I will hit the reverse proxy, which is 205. I will refresh my browser. You can see my website is being loaded. Now I will go to the logs. First, I will go to the reverse proxy log. So reverse proxy log is getting the client IP, then forwarding the request to this 205. Let's go to the actual machine IP or the web server. But web server is still showing the IP address of my reverse proxy. See, it is not changing the IP to the remote machine. It means we need to do some changes in the configuration file of the application server as well. So I will put Control C, clear out the logs, and I will go to the vi etc nginx nginx.conf, right? And over here inside the http section, I will add one more log location. So let's define the log format over here, and I'm going to define this particular log format over here. Team, you don't need to worry about the commands or the directive which we are mentioning over here. I will attach all the commands, all the directive as a text direction in the next lecture, so you can copy it. Here you can see we are defining the log format. Special logs is the name of the log format. Over here we are getting the IP httpx real IP, right? If you remember, similar kind of variable we have defined inside the proxy server as well. And then we are getting the remote user, then local timestamp, then the request, then status body sent, http referrer, http user agent, and the remote addr. We are also mentioning the remote addr over here. So this is going to be the log format for your application. Then I'm defining access log and defining a new location where log nginx access log special log. So special log is the format which we have defined, and I'm creating access hyphen special log special file for this particular log format. Then I'm defining access log and the error logs. I will close this, check my configuration nginx hyphen t, right? Configuration is okay. I will reload the nginx hyphen s reload, right? Now I will tail again, tail hyphen f where log nginx put asterisk over here, hit enter. I will put the separator over here, right? And I will put the separator over here as well. Now let's again go to the browser and hit the reverse proxy. So I will reload the browser. You can see site is being loaded. I will go to the logs. So on the reverse proxy, I'm getting the log and it is being hit by the client IP and it is being hit by the local machine 103.47.18164. Now go to the application server. And inside the application server, you can see you are getting the logs inside the access log file and inside the special log file. Access log file is still showing that the request is coming from the reverse proxy. So you can see this is the client IP, this is the date, this is the request which I am getting, then this is the response and this is the host on which the request get, and this is the user agent. And but inside the special log file, we are getting that request is coming from this particular IP. This is the IP of my local machine. This is the IP of a local machine, the IP of a local machine. Then we are getting the timestamp. Over here you can see the timestamp is actually same 161456, right? Then we are getting the complete request, then we are getting the response code, the host which got hit, and then we are getting the reverse proxy IP. Tail only the special log, access hyphen special log. You can see in this particular log file, we are basically getting all the requests from the IP which is hitting the request. If you want to check this on the, let's open some VPN site. So I will open some VPN, say VPN online. So I will find some online VPN. So here we are getting some fastest free proxy. Let me allow to open this. And over here it is saying that enter the web address. And over here we have the proxy location Netherlands. So let's copy my address, which is this, put it here and go. Right? We are getting my site. Now let's go to the access log again. And you can see this time the IP is, and you can see this time the IP is 109.201.133.6. The same IP we should getting in the proxy as well, 109.201.133.6. Let's go back to the proxy site and let's go back, and instead of the Netherlands, let's choose some other country. Suppose I'm going to hit this particular request from the Germany. So this time IP will be different. Let's refresh the log over here as well so that I can get the actual IP and go to my website. So you can see it is again opening my website. So my website is again opened. I will go to the logs. You can see this time I'm getting the request from another IP 135.181.35273. If I will go to the actual application server log, you can see same IP is being reflected inside the special log file. So this is the way how you can provide the actual IP to your web server instead of the reverse proxy IP. Why we are getting the reverse proxy IP inside the access log file? Because my log rotation policy is already defined. If I will rebuild it and I will define new log rotation policy, I will get the this particular IP. But if we are getting this particular IP, it means my application server is actually accepting the request from this particular IP and it is processing the request. So this is the way how you can provide the real IP to your web servers instead of the reverse proxy IP. If you have any doubt, any question, then please let me know. Thank you, team. Thanks for your time. Hello, team. Welcome back. Welcome to NGINX training. And in this section, we will learn about the NGINX performance, how we can improve the NGINX performance, and what are the directives, the configuration which we need to tune to get the maximum performance from the NGINX server. So first, we will get to know the application of few directives. Then we will directly go to the lab. So let's start with. So over here, first we are discussing about the client caching. Right, we will discuss how we can make the client caching model with the help of the nginx. When I'm talking about the client caching, then I'm talking about the caching system at the client side. It means caching management at the browser side. If you will open your browser, suppose we are opening a browser. So here I have opened my chrome. If I will go to the left top, these three dot icons, I will click these, and over here I will go to the setting. I will search for the cache. Right, so over here we have the cache and more. Let's click this, and if you will go to the cache section, then over here you can see I have the 299 megabyte image or files as a cache. Right, so this cache management is the browser side or the client side cache management. Sometime you may have faced some problems that if your website is not getting properly or your logout is not working properly, then people recommend it to clear out the cache and cookies of your browser. So we will see with the help of the nginx how that particular cache will be managed. Right, so right now you can see in my browser I have 299 megabyte cache. So we are going to talking about this particular cache management so that my application performance will be more good, because user will get the data from directly their browser cache instead of the server. So over here we will save the time between the browser, the client, and the server communication and the data transfer. Right, we will see what kind of files we can cache at the browser side and how we can cache these files with the help of the nginx web server. So we will learn how all browsers, non-browser http clients supports the client side caching. The main point is that web servers do not control client side caching to full extent, because that is not the part of the web server. Client is the another party which is situated at the user side, and web server is your party. So web server don't have the full control of the client side caching, but web server can issue some recommendation, and these recommendation will help the client to manage their cache. So we will see what are these recommendation which we can pass, and these recommendation can be handled with the help of the http response header. So web server can issue some kind of recommendation to the client that how they can manage the cache data for that particular site, and that recommendation can be going through with the help of the http response headers. So we have few response header. The first response header or the first directive is the cache control header. This is the most important header to set as a effective switching on caching in the browser side. Whenever you want to switch on the caching at the browser side from your web server, you need to add the cache control header in your response. Without this header, the browser will request the file on the each subsequent request. So we can understand this: if cache control header is missing in your response, and within 1 hour same browser same user is hitting the same static file 10 times, then always web client will send the request, your server will process the request and send the response. So it means if the cache control is missing in the response header, then every time user will request some resource, that request will be processed by the web server. But if cache control is present in the response, we can keep a copy inside the cache of the client, so that that copy will be directly served to the user from the browser cache instead of the web server. The cache header few values, and the first value is the public. Public resource can be cached not only by the end user's browser, but also by the intermediate proxies that may be serving many other users as well. And you can define the cache control public like this: cache hyphen control colon public. So if we are defining the cache control public, then not only the user who is requesting that particular resource, but all intermediate proxy, right? They can also cache that particular resource so that they can be served to the other user as well. Generally, or 98% developers or DevOps engineer will keep that particular property public. Then the second is the private. Private resources are bypassed by intermediate proxies, can only be cached at the end client. It means the copy of that particular resource only be cached at the end client who is basically trying to access that particular resource. All the intermediate proxies, all the intermediate servers, they will not cache that particular resource. So we can understand this particular thing with a simple example. Suppose my application server is situated in the Tokyo, right? And I am the user from London. Also, there is a proxy server which is situated in the London for the UK users, right? So when I will hit the request, that request first go to the proxy server which is situated in the London, and then that request will be go to the web server from the proxy, right? And if the cache is public, then the static resource which I'm asking, the copy of that particular resource will be cached at the proxy server plus as in the. So now we will get the two cached copies, once at the user side and another one at the proxy server side. In that case, all the users who are going through with the London proxy server, they will get the cached copy which is cached at the London proxy server instead of the web server, right? So it will improve the performance of the website for your users who are geographically distributed. But if you will keep that particular private, it means all the users from the UK who will hit that particular request, at least one time that particular request will be processed by the web server instead of the proxy, which will introduce the delay. So ideally the cache header should be public instead of the private. Then third property is the max age, which is combined with the private and the public, right? So we can combine the max age with the public and the private, and max age is basically indicating the maximum amount of time that the resource can be cached before considering the stale. It means over here if you are defining 2 hours, 2 days, 3 days, then at the browser side, at the client browser side, or at the proxy side, that resource will be cached for the 3 days, right? After that, that particular resource will be stale and we need to put another request to cache that particular resource. This value sets in time span how long the cache is resource in second, right? So you can define the complete syntax like over here, which we are displaying in another color: cache control public comma max age equals to some timestamp, and that timestamp should be in the seconds. The another directive which we have the cache control is the expires. Expires accompany the cache control header, and expires simply set a date from which the cache control resource should no longer be considered to a valid. It means this also works as a max age, but it is a bit different from the max age. In the max age you are defining the time in the seconds, but in the expire you will define the time in the date. I will show you how we can define it. And from that particular date forward, the browser will request a fresh copy of the resource. Until then, the browser local cache copy will be used. So if we are defining the expire like 5 months, 5 years, to up to 5 years or up to 1 years, that particular resource will be cache in the browser if user is not going to clear their browser cache, right? And after 5 years or after the defined expire time, a fresh copy of that particular resource will be again requested from the web server and again cached at the client side. Now the question is, if both the expire and the max age is combined with the cache control, then what will be the preference? So in both case, if expires and max age are basically accompany the cache control, then max age will take the precedence. It means max age will take the precedence. If the max age and expire both have the different times, max age time will be considered for the cache control or the cache expire. Now let's see how we can do that particular thing with the lab. So let's go to the terminal. So over here we are on our machine Ubuntu custom NGINX, right? Let's log in the same machine in the blue terminal as well. So I'm logging my machine which is ending with 130 pass IP address. Clear out the console. Now let's see what we have inside our configuration file. So vi etc nginx nginx.conf. So this is my configuration file. I'm going to remove all the unnecessary things from this particular configuration file which we have learned in the last lecture. And suppose inside the server I'm going to define one more location. And inside my location block I'm going to define some hypothetical location like which is equals port.jpg. Although this particular location is not present in my brownie side, but I'm defining some hypothetical location over here. Then I'm defining a block, and inside the location block I'm defining like return 200 and some string. Hello, this is dummy location. Right after this I will close this. Now I will save my file, reload the NGINX. I will go to my another browser. Now I will make a call curl -i, define my IP, HTTP protocol, and my IP is 104.131.80.130. Then access the port.jpg. Hit enter, and I'm getting the 200 request over here. Then I'm getting the server, then date, then content type, then content length, and then the connection. Let's do one more thing. Let's add some header over here. So I will again update it and go to insert mode, and I will define one more location, add underscore header. Then I will define my header name, which is underscore my header, right? Then define the value of this particular header. Suppose I'm defining inside the double quotes dummy value. Let's close this, save your file, check the NGINX configuration, nginx-t file is okay, reload the NGINX, right? Let's go to the another terminal and hit the same request which we hit earlier. And this time you can see I'm getting one more entry over here which is my header, right? And I'm getting the my header value as well. This time inside the response, when I'm hitting this particular request, inside the response I'm getting the header. So this header will help me. Right now this is the custom header, but I will modify the headers and I will add the cache control header and the expire header in my. So I will again go back to the terminal, open the configuration file, and now I will add the real headers. So I will clear out my header. First I will define the cache control public header. Then I will add one more header over here which is called pragma public. Pragma public is the earlier header before the cache control. You can see this is the legacy copy of the cache control. So it is good to define it. It will not harm you. But if some websites, some web servers, some browsers are still using some earlier protocols, then definitely this will help you. Then I will add one more thing over here. And this time I am basically accepting the encoding. If some resource are basically encoded resource, then I'm going to accept that particular thing. And in last, I will add the expire. So I'm defining the expire like 6 capital M, which is 6 month. If you want, you can update it, right? You can update it like 2 months, 4 months, or in year if you want to define the capital Y. I'm going to define it 2 months. I will save my file, check the Nginx configuration. Is it okay? Yes, is it okay? Reload the Nginx, go to another terminal and hit the same curl. And this time you can see I am getting a lot of entries. After the connection alive, we are getting the expires, and expire I am getting Thursday 22 October 2020. It means this is 2 months after detail when I'm recording this particular video. At this particular time, all the resource which we are accessing on this particular path, they will be expired. We are also getting auto controlled max. You can see I didn't define the max age inside the properties file, but I'm still getting the max age. This max age is basically calculating automatically on the basis of the expire date. Then we have the cache control which is public, then we have the pragma which is public, and then we have the vary which is accepting encoding. So now this time we have defined all these parameters for this particular specific resource path which we have customized. If we want to make it generic, how we can do that? So we will again modify the NGINX configuration, and over here inside the location, instead of this hard coded path, I will provide some generic statement. Then I will put the regular expression. Then I'm saying suppose all the files which have particular extension, and what extension I'm supporting like CSS, JS, JPG, JPEG, and PNG. Save this file, check the configuration. The configuration is okay, reload the NGINX. Now let's do one thing. Let's clear out the console, tail the logs, tail hyphen f, and var log nginx access.log file, hit enter, and do one thing. Let's hit your web server again. So I will go to the browser and I will hit my web server, and you can see I'm getting my website. Now I will go to the terminal, and inside the terminal you can see we will have some path for the jpg or js query. See, we have some js query path. I will copy this, exit out, clear out the console, and this was the call which we was hitting. After this I will append this js path. So what we are trying to see, we are trying to see when I'm hitting the js, what is the header which I am getting. Hit enter, and you can see this time we are getting all the header with this particular js. Why we are getting this particular header with the js? If we will see cat etc nginx nginx.conf, because we have defined the all extensions which have the css, js, jpg, jpeg or png files inside this particular block. So all the files which have the css, js, jpg, jpeg and png, all these files will be cached at the client side for the 2 months as defined with this particular header, and same we are getting that it is being reflected over here. If you will try to find out some html page, that header will be missing. You can try. Let's hit curl, and instead of this let's try to hit 130. So I will get the html page, and this header is not getting over here, right? Because html page extension is not defined over there. If you will define the html inside the location, you will also get the same header for the html, and HTML page will also be cached at your browser location. So these tweakings in the configuration or these instructions are very helpful for the production sites or the sites which have the multi geolocation users and have a very heavy traffic. So thank you team, thanks for your time. If you have any doubt, any question regarding this particular lecture, please let me know. I will be happy to answer your questions. Hello team, welcome back. Welcome to NGINX training, and today we will see how we can gunzip the response at the NGINX site. It means how we can zip the response at the web server side to reduce the data transmission over the network and improve the performance of our website. So let's start with. So first we need to understand why this particular thing, why the response compression is required. So how fast a website will load depends on the size of the files that has been downloaded by the browser. So whenever you are hitting some website on your browser, right, that website will have multiple files. That will have the HTML file, that will have the CSS file, that will have the JS file, that may have the AJAX files, that may also have the images. There could be the n number of files. Whenever you are hitting the data, your browser is directly downloading from the web application server. And how fast that particular download is, the file speed depends on that particular stuff. If you will see, I can show you. So over here we are in the incognito mode of the browser. Let's open two websites. First I'm going to open the yahoo.in, but before this let's press F12 on your browser and go to the network section so that what network call it will hit when I will open the yahoo.in. So I will hit yahoo.in. Over here you can see a bar is opening, right? So now you can see a bar is spinning. It means it's downloading the response from the server. Let's see how long it will take. You can see the bar is still on. Now you can see that particular bar is gone, and over here you can see 319 requests are being done, 2.2 megabyte data transferred, 6.9 megabyte resources this particular web page will have, and this finish in 34.69 second, and DOM content just loaded in 2.17 second, and total load is 10.68 second. This is the speed of this particular website. Over here we can see the multiple files get downloaded: the text HTML document, style sheets, CSS file, scripts, GIF, XHR. Multiple files got downloaded in my browser whenever I opened the yahoo.in. Now let's go to here and open some another website. So this time I'm going to open the Rediff, right? So we are going to open the rediff.com. Now you can see this bar is still spinning, and over here we can see resource requests are going on. Total 241 requests made, 1.4 megabyte transferred, 4.8 megabits resources, finish in 12.24 second. DOM content load is just 1.09 second, and total load time is 9.75 second. So for every website, this time may vary, and that is define the quality of the website, that how fast the website is. If the same way we will go with the facebook.com, this will be very minimum. Let's open the network bar. and hit the facebook.com, and it's done. The total load time is just 2.35 seconds because the number of requests which is being made by 33 requests only. It means minimum data loaded on your web server. It means minimum data being downloaded on your browser from the web server. If you will close this, and it may possible this Facebook is the image. So this is the only image which basically got downloaded in this particular web page. Rest all of the things either are the script, either are the JS call, either are the HTML or the text files. If we will go to the Rediff, we will close this. You can see a lot of files, a lot of image got downloaded once we hit the Rediff. That's why the server response time was high. A lot of data downloaded in my browser from the Rediff server. Total data size was 12 MB. Over here the data size was just 2 MB. If we will go to the Yahoo, we will minimize this. Over here the same case. A lot of image I am getting on my browser. A lot of data is basically being downloaded from the Yahoo web server to my browser. So this may impact the performance of your website. And by this we can easily understand the website load speeds will be very fast if my file download is a fast process. For this we need the compression. So reducing the size of the files to be transmitted can take the website not only load faster but also cheaper to those who have to pay for their bandwidth usage. This is another factor. If you have ever created any website, if you have ever purchased some kind of domain from the Bluehost or GoDaddy or something like that websites, then definitely these websites are going to charge you about the bandwidth use. So more number of the files are basically transmitting from the web server to the web client, the higher bandwidth you are using. So reducing the size of the files that is being transmitted between the web server to the client through the network, that will make the website load faster, also reduce the bandwidth use as well, right? Which will save your resource and which will save your money too. Now the question is how we can minimize the size. So response file size can be minimized with the help of the NGINX configuration, which use Gzip compress to the files at the server on the fly. It means whenever you are getting the request to access some files in the response, whenever server will send the file, first it will zip the file, then it will send the file on the response. But it may raise another question. If the server is compressing the file, then who will decompress the file? So in the modern client, in the modern web browsers, all the web browsers have the capability that they will decompress the file once they are getting the compressed file in the response. So we don't need to worry about it. We need to just take care that whenever my web server is sending the files, that is sending the compressed response instead of the uncompressed response. Compressing the file use up server resources. There is another challenge, right? Whenever we are doing some extra work, we need the resources. So whenever we are compressing the files at the server, for each request it need the server resources. So to take care that particular thing, we have another directive in the nginx which is called compress level. So we will make sure we will keep the compress level in middle between 0 to 10. If we are saying the compress level is 0, it means we are not decompressing the file, we are sending the same file. If we are saying that compress level is 1, then we are slightly compressing the files, else sending the complete file. But if we are saying compress level is 10, it means we are compressing the size as possible as we can, right? Then sending it over the network. But compress level 10 will take a lot of resource on the server. So what we will do, we will keep the middle entry. We will keep either 3, either 4, either 5. My favorite is 4. That will take the minimum resource on your server, right? And compress the file at a significant size before sending it to the web client. So let's see how we can achieve that particular thing with the help of a lab. So we will go to the browser first, and instead of opening the Facebook Rediff, we will open our website, right? So we will go to a new tab and we will open a website 104.131.80.131. This is the website where I have hosted the brownie on my nginx. I will press F12 and hit this particular request. So you can see over 42 requests are made, 967 kilobyte data transferred, 972 kilobyte resources, right? Finish time is 2.82, DOM content load is 2.18 second, and total load time is 2.82 second. There's a one difference between the Yahoo and my website. Transfer data and resource data is same. Inside the Yahoo, the transfer data was minimum as compared to the resource data. In the Rediff as well, the transfer data was minimum as compared to the resource. Why? Because they are using the compression. I'm not using any compression over here. Let's go to any resource. This is the CSS resource, bootstrap min.css. I will open this. Here I'm getting the headers. So this is the request which I made. The request type is 200. The status code is 200. This is the remote address. And over here we are getting the response header. Let's see what we have in the response header. In the response header we have the accepting range, cache control, max age, which we fixed in the last lab, the content length, and this is the size of this particular file. Bootstrap.min.css have the 118733 byte. This is the very accepting encoding. Over here we are not getting any header which is showing that this is the compressed file. Now what we will do, we will go to the terminal, log into my server. After login, we will open the NGINX file, nginx.conf, and over here inside the HTTP block, I need to define the Gzip format, and that format will be applicable for all the servers which are using that particular HTTP block. Although inside the server or inside the location, you can modify that particular value as well. So first, to zip the file, what I need to do, I need to put gzip space on. That's it. Then what I need to do, I need to define the compression level. So I will define gzip underscore comp underscore level, and I'm defining that compression level is 4. We have discussed about this compression level. As high as you will keep this compression level, you will be use more resource on your server side, right? The 3, 4 and 5 value are the safest value. The server will take the minimum resources, and you will get the best result on the compression level as well. Now we need to define which files I need to compress. So I need to define multiple kind of files. So suppose I want to compress text plain, I want to compress CSS, I want to compress JSON file, X JavaScript file, XML files, XSML RSS file, and the JavaScript file, right? Over here you can see I'm not defining any JPG, PNG, HTML. Why I am not defining the JPG and PNG? Because JPG and PNG already the compressed file on the server, right? If you will define the compress for the JPG and the PNG files, it will consume your server resources, but you will not get some kind of result, right? It means no change in the size. Almost 2, 3 or 5 byte change will be noticed in the file size, right? But it will take the resource on the server. So we are avoiding to compress the JPG, PNG or JPEG files. We just compress the text file, because text file is the file which will compress up to 50% and up to 80% on the server side. Now what you need to do, you need to save this particular configuration. Check the configuration nginx-t. Configuration is good. I will reload the nginx. Now let's check what we will get. For this, you need to close this particular incognito window, because we have applied the cache policy on my server, right? And we will open the another incognito window. And over here in the another cognito window, I will press F12 and open up my website. Hit enter. And right now you can see the difference. 42 requests made, and this time the transferred size is 718 kilobyte. Earlier that was similar to 972 kilobyte. This time we are getting the lower data over here. It means we are getting some compressed file, right? If we will go to any file which we have compressed, so we have compressed the JPEG file, JPG file, CSS file. Let's see about this particular CSS file. Here is the request. Request is this. This is the get request and boot snav.css file. We will go to the response. Inside the response, this is the cache control max age, cache control public, keep alive, and see. We are getting the content encoding gzip. This was missing earlier. This was not present earlier. So we are getting that this content is basically zipped with the help of the gzip file. Earlier we was looking for some JS. I think that was the JS bootstrap min.css. See over here, we should also get the gzip. And transfer encoding, and we are getting another header transfer encoding with this, which is chunks. Over here we are not getting the size this time, right? So let's see manually how this is impacting the size, right? So we will make few calls. So I will clear out the console, and first I will curl some CSS file from my server. So suppose I am querying on a JS file which is present at the assets.js location, curl-i, put enter, and we are getting this result, that date is this, content time is this, content length is this. We are not getting the compression over here. Why we are not getting the compression over here? Because whenever the browser is requesting the server, browser is handling the compression, browser is handling the headers. Over here with the help of the curl, we need to made it manually. So what we will do, we will supply the header over here, And this time we need to supply the header. So we will supply the header like this: curl -h accept encoding gzip deflate -i, then define the same JS file. This is the same URI, right? And this time we are also getting the same data. Let's open the file. It seems we forgot to define the JS extension. So we will open the NGINX configuration again. So over here we have defined the text plain, text CSS, application JSON, application X JavaScript, but we have not defined the application JavaScript. So let's go to the insert mode and define the one more value over here, which is application JavaScript. Refresh this, save the file, reload the NGINX. Reload is done. Clear out the console. Let's hit the both calls again. So first we are hitting the curl on JS. We are not getting any compression tag over here. Now we will hit the request with the header accept encoding Gzip. Hit enter, and this time we can see we are getting the content encoding. Earlier this was missing, but we are not getting the size over here. So let's see how compression is basically impacting my website. By this way, just remember, if you will go to the browser again and you will refresh this, then this time network transfer time will be more minimum. And close this browser and open the incognito mode again. Open your website again. Earlier the network transfer was 712 kilobyte. I think we have added application JSON as a compression. This time it will be reduced. So press F12 and hit this and again and hit this again. And see, yes, this time we are getting more minimized way. We are getting only 557 kilobyte transferred. We have reduced 200 kilobyte network transfer from server to browser. And now you can see this is 60% of the total resource. So you can assume that by just adding few lines in the configuration, how much benefit you are getting. You are reducing the 40 to 45% resources which are basically transmitting over the network from the web server to the client. This will provide you a huge improvement in your performance. Now if you will go to the terminal again and let's see how we can compare the size. So let's hit the earlier curl again and let's save this response in some file. So I suppose I'm saving it in some kind of min.js. So total size is this. Now I am saving the zip header, and this time I'll called min.zip.js. Right over here we are not getting the size. Let's clear out the console and let's put ls-lrt. So here we have the two files, min.js and min.zip.js. So min.js is total size is this and min.zip.js is total size is this. So actually we are reducing the file size over the network transmission. So this is the way how you can compress the response before sending it to the client, and client will decompress this. We have seen whenever we are in a browser, we are not getting any issue, right? This is the same website and every functionality is also working. If you will go to the profile, you can see everything is working. But the network data transmission, we have reduced the network data transmission from 40 to 45%. So this is the way how you can improve the performance of your website with the help of the NGINX. So team, if you have any doubt, any question, please let me know. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training. In the last lecture we have discussed about the static data caching. Today we will see about the micro caching in NGINX and what is the use of micro caching in NGINX. So let's start with. So we can cache two kind of data. The static caching content such as images, JavaScript, CSS file and web content that rarely change is relatively straightforward process. And we have already seen that how we can cache the static data at the client side. Then the question is that possible that we can cache the dynamic data as well? So here is a diagram which will define the caching in the NGINX. If you go with the left side entry, then static content such like images, CSS, simple web pages, they are very easy to cache. But if you will go with the right side content where we have the personalized content means the content which is specific to user. That is something like shopping cart, that is something like account data, and that data cannot be cached. And what is the reason why we cannot cache the personalized data? Because that data is related to a specific user, not a number of users. Then we have the middle layer, which is the dynamic content. The dynamic content may contain the blog post, that may contain the status page, that may contain the lottery type, that may contain the lottery result, or any kind of data which is common for few peoples, right? But still that is being processed dynamically with the web server. Can we cache that particular data? The answer is yes. We can cache the dynamic content too, and this caching can be done with the help of the micro caching. So caching the personalized content, that is content customized for each user, why server application is generally not possible, because the server response differ every request for the same resource. So we cannot cache the personalized data, but we can cache the static data as well as the dynamic content. So let's discuss about the dynamic content a bit. This content can change unpredictably, but it is not personalized for any user or personalized for a single JavaScript or a single client. So dynamic content is a data which is actually being processed by the NGINX dynamic process, which is PHP FPM, but that data is not specific to any user. That data is not specific to any device. That data may be similar for the 100 user, may be similar for the 1000 user, or it may possible for a particular location. That data may be similar for a complete country. But the main question is that is still dynamic data which is being processed by the dynamic process. If we will take the examples on the dynamic data, then here are few examples which I have shortlisted for the dynamic data. The front page of a busy news and blog site where new articles are posted every few seconds. That is the dynamic content. The RSS feed of the recent information, that is also the dynamic content, but both of that content is similar for the multiple user or similar for almost all of the visitors. The RSS feed or the front page of any newspaper is not personalized content for any user. That is common for a complete country, or that is common for a complete region. Then another kind of dynamic data is the status page of the continuous integration of the build platform. In your organization, if you are using CI and you have the build platform, that the status page of that particular CI server will be dynamic data, and that is same for the complete organization. Then we have the inventory, status, or fundraising counter. They all comes in the dynamic data, but that is also similar for the multiple users. Then we have the lottery results, that is also dynamic data. Then we have the calendar data, that is also the dynamic data. And then we have the personalized dynamic content, and some personalized dynamic content is also dynamic data, like the personalized dynamic content which is generated on the client device, such as advertising content, hello your name, that is calculated using the cookies data. So many e-commerce website and the mobile apps, either they in the pharmacy field or either they are in the retail, either they are in the food chain, right? They have some common kind of functionality. They have some common kind of functionality like help. Once you will click the help, you will get a personalized message where it will mention hello your name, then it have some message. So the higher word and the message which you are getting on your screen, that message is the dynamic content, but that message is same for all of the users of that particular web application. It's just your name which is personalized data to you, but rest all of the data is the dynamic data, that is not personalized data. But still you will feel that that message is generally generated for you because it has your name. No, just your name is your personalized data. Then it will ask few options. Are you happy with the service? Are you not happy with the service? If you will choose any option, you will get another message. That is something possible with the help of the artificial intelligence, but that data is also a dynamic content, not a personalized content. So all these data which I've listed over here, these are the dynamic data, not the personalized content. And there could be the n number of cases which can define the dynamic data, not the personalized data, and we can cache the dynamic data. That is true with the nginx. So how we can cache the dynamic data with the help of the nginx? And the answer is micro caching. Micro caching is used to cache the dynamic content. We need to see how micro caching will be used to cache the dynamic content. So micro caching is a caching technique whereby content is cached for a very short period of time. We will use the micro caching because the content is cached for a very short period of time. That's why it is called micro caching. Earlier with the static data, we was defining that particular data cache for 2 months, 3 months, a year, or more than a year, right? But with the micro cache or the dynamic content, you cannot put the cache up to that period long. You hardly put the cache for 30 minutes, 20 minutes, 10 minutes, sometimes in second as well, right? But you cannot provide the cache for 2 years, 1 year, 2 months, 1 month. Otherwise that will lose the part of the dynamic content. So here we will understand the dynamic content. In the Nginx, Nginx use the persistent disk-based cache located somewhere in the local file system. So whenever we are going to define the micro caching with the help of the Nginx, Nginx will use some local disk to store that particular data in the local file system. So we will understand So on your screen, you are getting three icons. Once we have the web client, then we have the NGINX, and then we have the PHP FPM. So suppose this time client initiated the dynamic request. That dynamic request will directly go to the reverse proxy server or your NGINX server. This NGINX server is a single process and it will identify that the request is the dynamic request. So it will initiate a thread with the PHP FPM process because NGINX will use the PHP FPM to work with the dynamic content. Further, PHP FPM will process that particular data and it will reverse the data to the NGINX, and NGINX will reverse that particular response to the web client. This is the complete cycle. But here we have more details. Once the dynamic request will land on the NGINX, NGINX will initiate the PHP FPM process for the request. And it may possible that PHP FPM process either executing that particular data with the help of some JS files, with the help of some AJAX files, with the help of some other programming files, or it is also reading the database to process that particular request. So for your request, PHP FPM is processing your content, and it may possible that it will directly render the data with the help of some scripting language, or it will call the database as well. And in that case after the processing it will response the data to the nginx. Once nginx will get the response data, nginx will form that particular response data or store that particular response data in the form of html page, because nginx don't know the dynamic content. So PHP FPM is the process which will process the request, either that will with the help of the database if database is required or some scripting, right? Then the dynamic response will hand it over to the Nginx. Nginx will store that particular data or get that particular data in the form of the HTML page so that it can display the same data to the web client. But Nginx will use the memory to store that particular HTML page, and here we can call the micro caching, right? Here we can cache the data, store the data in the local disk for a short period of time. So if micro caching is enabled on your Nginx, whenever the same request will come to the Nginx with the same header, Nginx will read the data which is stored in the cache instead of creating the new PHP FPM process. Whenever the new request comes with the same query parameters, Nginx will process the data which is stored in the cache instead of sending the PHP FPM process or again processing the request. That is called the micro caching. But this caching will be limited. That could be up to 30 minutes, up to 20 minutes, or up to 60 minutes, right? Not more than that. And then Nginx will respond to the web client. So by this particular way, either we are requesting the dynamic data, but Nginx if already processed that particular data shortly, right, then it will directly return the response from the cache, from the local disk. It will not create the another dynamic process to read the same data. So by this particular caching, you will enrich the user experience, you will make your website more faster, right, and you will reduce the load on your web server or the origin servers. So I hope you understood the concept of the micro caching. Now let's move further and let's see what are the parameters, what are the components which will be used in the micro caching. So we know very well that to communicate with the PHP FPM, we need the fast CGI protocol. So fast CGI is a widely used protocol for interfacing interactive applications such as PSP with web servers such as Nginx. The main advantage of the FCGI or fast CGI is that manage multiple CGI requests in a single process. That is the beauty of the Nginx, so that it can open the multiple threads within a single process and each thread will do their processing and revert back to the Nginx. Under the Nginx, the fast CGI content cache is declared using the directive called fast CGI cache path. So if you want to enable the micro caching in your Nginx server, you need to use the fast CGI content directive, which is called fast CGI underscore cache underscore path, and where you need to define the path of your cache directory. That directive must be need to define at the top level of HTTP context within the Nginx configuration structure. User can also add the fast CGI cache key, which will define a key request identifier for the caching. Right? Generally, when we are using the fast CGI cache path, we will use the fast CGI cache key as well. And with the help of the fast CGI cache key, Nginx will read the cache efficiently. Shortly, we will discuss about it that how Nginx will use the fast CGI cache key. First, let's discuss the directive parameters of the fast CGI cache path. What is the parameters we need to define within the fast CGI cache path? So first parameter is the where cache nginx or the location. Generally, this is the location which people can take to store the cache of the nginx, which is where cache nginx. This is the path in the local disk directory for the cache of the NGINX. The second directive is the labels. Labels are very important whenever you are defining the cache. Labels defines the hierarchy level of the cache, is set up two level directory hierarchy under the var cache nginx. When we are talking about the labels, so when the cache will be generated and cache is stored in the nginx cache, nginx will create a MD5 key for the each cache. And if you are not defining the label, then nginx will store the each cache MD5 at the same directory within the cache nginx, which will be again very hard to process for the nginx. So what we will do, we will define the two label hierarchy. So first nginx will define some hierarchy like 1, and inside the 1 it will store some cache. Then it will define another directory 2, and inside the 2 it will define the another MD5 key. Then 3 it will define the another MD5 3 key. We will experience this with the help of the live practical once we will go to the lab, right? So that it will be more clear to you that how we can define the two label hierarchy inside the nginx cache and what is the use of the two level hierarchy. Then we have the key zone. We need to define the key zone name and size, right? That enables the creation of a shared memory zone where all the active keys and information about the data are stored. So basically with the help of the key zone, you will define the zone for the nginx cache. If you have the multiple location context inside your HTTP context and you want to define the specific key zone for each location, then that is possible with the help of the key zone. So that a specific location dynamic cache will be stored in the zone first, then a specific location cache for the location 2 will be stored in the zone 2, then a specific cache for the location 3 will be stored in the zone 3. So zone is something which will define the parent object of the cache, right? Which will define the boundary of the cache, that for a specific location, the cache of that particular location will reside in this particular boundary only. That's why key zone will have the key information and the information about the data. Over here, we can also discuss that storing the key in the memory speeds up the checking process by making easier for Nginx to determine where it's a miss or hit without checking the status on the disk. So if we are defining the first CGI key, then first CGI key is helpful for the Nginx to check that where the cache is present or not. That will make the Nginx process more easy. Regarding the hit and miss, we will see what is the miss and what is the hit when we have the keys and when we have the first CGI cache in the lab. Then the next field what we have, this is the inactive. Inactive is the optional field which specifies the amount of time after which the cache data that are not accessed during the time specified get deleted from the cache regardless of their freshness. So this is something which is related to the timeout or expiry time of the cache. So if you are defining the inactive with your cache, then after that particular time that cache will automatically expire and user need to put a fresh request on the web server. Then we have the max size, which is also an optional, and max size specify the maximum size of the cache, right? If you want, you can define the maximum size of the cache. If you want, you can ignore this as well. Now let's discuss about the another directive, which is first CGI cache key. So we have discussed about the first CGI cache path. Now let's discuss about the first CGI cache key. Nginx used the first CGI cache key in calculating the key for a request. Importantly, to send the cache response to the client, the request must have the same key as cached response. It means if you have enabled the micro cache, right? So whenever a request is hitting the web server and getting the response, and if that response is being stored as a cache inside the micro cache block of the Nginx, and that is the key value which is a MD56, which is a MD5 or a hash for the Nginx, and Nginx will use that particular key to respond the request. Each time whenever request have the same URI, same path, that key will be read and Nginx will return the data from the cache on the basis of the key. Whenever you will change the request URI, right, a new key will be generated and it will again cache in your Nginx. Let's discuss what are the part of the first CGI cache key. So first is the dollar scheme, which is the request scheme which will define the protocol, either a HTTP or HTTPS protocol. Here we need to notice one thing. If we are hitting the same URL, suppose we are hitting some www.example.com, the URL is same, but that URL is being hit on HTTP and HTTPS. Then Nginx will maintain the two key. One key for the HTTP and another key for the HTTPS. It doesn't matter if you are hitting the same URL. If the scheme is different, then a new key will be generated. The another part after the scheme is the request method, that which request method you are hitting. It is a put, it is a get, it is a post, it is a delete. The next is the host. This can be the host name from the request line or host name from the host request header field, or the server name matching the request in order to precedence. Over here, host means the complete domain name, right? Over here, the host name is the domain name. So suppose you are hitting a get request on http www.example.com. Here www.example.com is the host, get is the request method, and http is the scheme. Then we have the last part, which is the request URI. Request URI mean the fully original request URI. So suppose if you have a request like get method on http www.example.com question mark name equals to Tom. Here the request URI is the name equals to Tom, right? Which is the complete request URI. Host is www.example.com. Request method is the get because we are hitting the get request, and scheme is the protocol which we are hitting, either http request or https request. So team, these are the part of the micro caching. We have the first CGI cache path and we have the first CGI cache key. In the coming lecture, we will see a lab on the micro caching, and we will see how we can define the micro caching and how we can use the micro caching in the NGINX and how effective the micro caching is. So we will see how micro caching will improve the website performance multiple times with the help of the NGINX caching. So thank you team. Thanks for your time. If you have any doubt, any question, please let me know. Thank you team. Hello team, welcome back. Welcome to NGINX training, and today we will see a lab on the micro caching in NGINX, or we will see a lab on the dynamic content caching in the NGINX, and we will see how it will improve the performance of your website in terms of the multiple concurrent requests on your website. So let's go to the terminal and let's start the lab. So team, over here I have opened my Ubuntu machine in the terminal. I have opened two terminal, one in the black window and another in the blue window. Both of the terminal are basically pointing to the same machine. I have opened two terminals so that I can show you the different things easily. Over here, first go to the configuration file vi etc nginx and nginx.conf. Let's remove the earlier setting which we have done for the Gzip. Why I am removing this particular setting? Because I can make the file more simple for this particular lecture. There is no other reason that this setting will not work with the micro caching. This will work with the micro caching. I just removed that particular setting so that we can focus on the current setting in the configuration file. After this, what I need to do, as we are talking about the dynamic content, so we need to modify our file as per the dynamic content for the PHP process, which we have already done in the earlier lectures. So I'm just going to copy that particular configuration over here. I will go to the insert mode and put the directives one by one. So first I'm going to define the index, index.php and index.html. After this, I'm going to define the another location, right, with the try files. We have already discussed about all these things, so I'm not going to repeat these particular things. And over here, let's see if we have the PHP file present. So we will go to the blogging, put ls, and see we have the index.php and index.html. We also have the info.php file at the same location. Let's save this particular file, go to the browser and open my website. So right here on the default URL, I am getting the brownie site, but I have already modified my configuration. Let's try to reload the nginx, nginx-s reload. Let's see what content do we have in the index.php. So I will modify, so I will view the file index.php, and over here we have some echo message. Now let's go to the browser again and refresh your website, and this time you are getting the PHP content. And you can see we are directly getting the content which is being written inside the PHP. And now the another question is why we are not getting this particular formatted, why we are getting the file syntax over here? Because we have not initialized the PHP process location inside my configuration. So we will go to the configuration again and we will open the first CGI port for the PHP files. So we will go to edit again and we will add one more location over here for the dynamic content processing. And that location will be something like this: location, all the files which have the extension PHP. For this, include the first CGI configuration, and first CGI pass will be Unix run PHP, PHP 7.2 fpm.sock. We have already discussed about all these things in the dynamic content, right? So I'm not going to repeat this again. Now I will save this file and again reload the nginx. Let's go to the browser and refresh your web page. and you can see now we are getting the PHP file is being processed and we are getting the content which PHP is displaying. Let's do one more thing. Let's go to your PHP file. I will open the PHP file vi index.php, and instead of this particular static content I will add some dynamic content over here. So I will remove this content and I will add a function over here, and what that function will do, that function will display the current date on the web page. And inside the PHP file we are defining a syntax like this. First we are defining the h1 heading, which is the HTML syntax. Then we are defining a text, today's date. After this we are opening the PHP syntax echo, which will be a print message inside the date. Then we are using the date function of the PHP. We are defining some format, which is a PHP date format. You can Google around it. Closing the PHP syntax, closing the HTML syntax. Save this file, and we have updated the index.php file. Now let's go to the browser. Inside the browser, let's open your website. So you will get a text like this: today's date, Sunday 23rd of August 2020. Right, this is the time when I'm recording this particular video. So once we are hitting the home page of my website, I'm getting this particular message. So you can see over here the content is dynamic. Right, this content is not a static content. This is a PHP process, and with the help of the PHP functions I am generating the current date. This date is valid for 24 hours or some hours. Now let's see how we can cache the content data in the NGINX. For this, we need to go to the terminal. Inside the terminal, we again need to open the configuration file. And inside the configuration file, first we need to define the first CGI cache path inside the HTTP context. So I will go to the insert mode and I need to define few directives over here. First, I need to define the first CGI cache path directive. Then after this, you need to define some directory. Suppose I'm defining temp directory, which is the common directory in all the Unix systems. Inside the temp, suppose I'm defining some directory like cache NGINX. After this, we need to define few other parameters. What was the other parameters? Like label. So we will define the label. So we will define the labels like labels equals to 1:2. It means keep the two hierarchy inside the directory. Once we will create the cache, I will show you what actually the labels means and how the cache will look like after this particular labels. Then we need to define the zone and we need to define the max age as well. So I'm defining a zone like key zone equals to zone underscore 1, and max size of this particular zone will be 100 megabyte. So zone 1 will contain the 100 megabyte cache. Then we need to define the inactive time. So suppose I'm defining the inactive time like 60 minutes. So first directive we have defined the first CGI cache path. Now we need to define the first CGI key. So let's go to the next line. So we will define the first CGI key directive, and over here value needs to be defined in the same way. First was the scheme, second was the request method, third was the request host, and fourth was the request URI. So we will define the all values in the double quotes with the help of the variables like scheme, request method, host, and request URI. We have already discussed about these parameters, right? So this is the thing what we need to define at the global level. Now how that particular thing will work for only the PHP or only the dynamic process. So we need to define something inside the location which is basically working for the dynamic content. So let's move your cursor over here and we will modify this file a bit. So first we need to define the directive first CGI underscore cache, and we need to define the zone which you have defined inside the first CGI path. So zone is a zone underscore 1. So I will define a directive like first CGI underscore cache and need to define the zone that in which particular zone this particular location cache will be mapped. So this particular location cache will be mapped inside the zone 1. If you want to define another zone, you can define another location. If you want that multiple location will cache in the same zone, you can do that particular thing as well. So you can define the multiple zone for the multiple locations, or multiple locations can cache in the same zone as well. There is no restrictions in the NGINX. Now we need to define the next directive. Now over here we need to define the another directive like first CGI cache valid, right? After this we need to define the response code on which particular response code this cache will be valid. Then we need to define the time that which particular time that cache will be valid. So all the requests which have the 200 response code, this cache will be valid. The zone 1 cache will be valid for all the response codes which have the 200, and the response time will be the 60 minutes, which we have also defined over here. Now let's save your file, and to test this we cannot test this with the single terminal. because we don't have the multiple machine which can be connected to my NGINX server. We have the single terminal. So how we can test it? So to test this, you need to download the Apache Bench, right? Apache Bench is a tool. With the help of that particular tool, we can hit multiple requests on the server. So let's clear out the console, and you need to execute a command apt get -y install Apache 2 -utils. Hit enter, and you can see it is downloading the Apache Beam tool, and it's done. If you are using the CentOS, you need to execute a command yum install httpd -tools. This is the command which you need to use to install the Apache Bench on your CentOS. This command won't work over here because this is the Unix machine. So I'm going to erase it, but you can use it for the CentOS. Now after this, first let's verify if Apache Beam is installed or not. So you need to execute ab Apache Beam, and you will get options like this. So AB, then we have the options, then we have the request URI, and in the options we have the -n, which will define the number of requests, and -c, which will define the number of concurrent requests. These two options are enough for us. We will use the number of requests and number of concurrent requests. So let's do one thing. Let's clear out the console, right? And we will execute a command curl -i and my URI which I want to hit enter. So you can see I'm getting the 200 response. Let's hit the same thing with the help of the Apache Beam. So we are hitting Apache Beam. You can see with the option -n, we can define the number of requests. So suppose I want to hit 200 requests on my server. With the help of the -c, we can define that how many connection I want to make. So suppose these 200 requests I want to create with the help of the 20 connections. So Apache Beam will create the 20 concurrent requests on this particular and hit 10 requests per connection. It means total 200 connection will be requested with the 20 connections. After this, you need to paste your URI. Simple. Let's hit enter, and we are getting the invalid URL. It means we need to define the port as well. Clear out this. Let's define the port like 80 and define the resource path which is root. Now let's hit enter, and you can see it is working, and we are getting the result as well. So first we are getting the version of the Apache Beam, then it is saying that completed 200, then we are getting a message, then you can see we are getting the benchmark on this particular server. Be patient. We are seeing completed 100 requests, completed 200 requests, and finished 200 requests. The software NGINX 1.19.1, the server host name which we hit is the 130, the path which we hit is the root path. Total document length will be 53 byte. Over here we are getting the concurrency level 20. We have hit the 20 connections. Time taken for test is just 0.048 seconds. The complete request was 200 request was completed. Total data transferred was around 38,000 bytes, and HTML transfer was around 10,600 bytes. The request per second means the request per second. Over here you can see we are getting the data 4,158. It means my NGINX server can process 4,158 requests per second, right? And per request, it will take only 4.18 millisecond to process. So over here, we are getting the complete stats of my server. You can see 50% request just completed in the 5 milliseconds, right? 99% request completed in the 6 millisecond, and 100% request completed in the another 6 millisecond. This is the total time which my request processing took. Now let's clear out this, and we will introduce some delay. So we will open the file again, vi index.php, because I don't have any system where I can put some database query or something like that. So what I will do, I will put some sleep inside my PHP file so that request will be delayed. Over here, I will put some sleep, and to put some sleep, you need to use a syntax like this. PHP, then define the sleep function, and over here you need to define the time. Over here, I'm just defining the 1 second as a sleep time, right? And then closing the PHP. Let's save this. If you will go to the browser, refresh this, you can see the response is taking almost 1 second, right? Every time when I'm hitting this, I'm getting almost 1 second delay. Now let's do one thing. Let's go to the terminal. This was the result before the sleep. Now hit the same command again, right? When we have the 1 second sleep, hit enter, and this time it will take a lot of time. you have to wait until the complete request will be processed, and we will see what happen when every request is taking some significant time. So by this particular way, what we are achieving? We are achieving that we have not configured the dynamic cache on my server, and we have opened 200 requests, and we are assuming that each request have some database processing, so it will take almost 1 second in the process. Then how my server will behave? So you can see over here I'm getting the request results, right? And over here you can see now the request per second processing is loose to 4.75 request only, and earlier this was 4158 request. If each request is just taking 1 second processing time, just 1 second processing time, and 200 requests are hitting my web server, then my web server performance, see, there is a huge difference in the performance. Earlier this was 4158, and right now it is just 4.79 requests per second. Every time my server is making the fpm process, getting the response, making the fpm process, getting the response, making the fpm process, getting the response, and this makes the server too slow. Right now the capacity reduced more than 100 times. Earlier, before the 1 second delay, my server capacity was to serve 4158 requests per second, which is dropped down to 4.79 requests per second only. And earlier the request processing was in the millisecond, 4.8 millisecond. Right now we are getting the request processing in 4179 millisecond. So you can see how bad it is impacting the performance of your server. So how we can remove that particular limitations? For this, if you remember, we have already modified our file, but we have not reloaded the NGINX. We have modified the file as per the cache. Let's reload your NGINX. NGINX -s reload. Right? So we have reloaded the NGINX. Now dynamic caching is enabled on my machine. What I will do, I will execute the same command again. So first, I will copy the command from here, just paste the command over here and hit enter. Let's see what we will get. And you can see the performance is improved. My request processing is basically improved from 4.9 to 39.75. If I will hit the same command again, and with the same command again, you can see this time I'm getting that my server processing time is 10,000 requests per second, right? And per request time is just 1.9 millisecond. How it is possible? It is just possible because of the cache. My system generated the cache. Now every time you will hit the request, you will get the similar kind of statistics. See, the performance is more improved. Hit the same, see, the performance is more improved. Hit the same, see, the performance will be more improved. Right? So this is the way how dynamic content cache can improve the performance of your website. Till now in the performance section, we have discussed three things. First is the static content cache, second in the Gzip, and third is the dynamic content cache. These concepts are very helpful in the production servers, which will really improve the performance of your website, right? If you are not using these concepts, your server will be very slow, but as soon as you will apply these concepts on your NGINX, your website performance will be improved up to 80%, on the benchmark. So you can see how you can improve the performance of your website, how you can improve the performance of your reverse proxy, how you can reduce the resource consumption at the original servers. Let's move further. I will clear out the console, and I will clear out the console over here as well. And we need to verify if the request is basically getting from the cache or getting from the server. For this, we need to modify the engines configuration one more time. So we will edit the engines.configuration file again, right? And after the first CGI inside the HTTP context, I need to identify that the content is basically picked from the cache or from the server. For this, I will define another header, add header x cache upstream cache status. Here is the variable which I will set over here inside the location, right? Then I will save my file. Now I will reload my NGINX. NGINX-s reload, hit enter. I will hit the curl again. And now you are getting one more header inside the response, which is x cache. Here we have the miss. If I will hit the curl again, now we are getting the hit. It means first time when I hit this particular request, there was no cache. But right now it have the dynamic cache, so that we are getting X cache hit. Let's hit one more time. We are getting the hit. Hit one more time. We are getting the hit. Let's modify this a bit. Now I'm going to access the complete file again, index.php. hit again and we will get the miss. C, hit the URL again, we will get the hit. So it means we can assume that we are getting the content from the cache or we are getting the content from the server directly. Now during the lecture we have discussed one more things. We have discussed about the cache labels and we have defined that cache label will be defined inside the temp. So let's go to the temp. Inside the temp you will get some system generated directory for the NGINX. You can see over here we have the system generated directory for the NGINX, right? You can see this is the NGINX service. We need to open this particular directory. So let's copy this, or we will go to cd system, and after this we need to provide the complete path, which is NGINX. Hit enter, put ls. Here you will get the temp. If you will go to the temp, you will get the cache NGINX, which we have defined inside the configuration. We have the cache NGINX. Let's go to the cache NGINX. And inside the cache NGINX, you will get the multiple directories in the terms of 0, 1, 2, 3, AB, 0, 2, 0, 3, 0, 5. If you will put ls, you can see we are getting, let's clear out the console and put ls. You can see we are getting 0, 3 and 5. If I will put ll, so these are the directories as well, 0, 3 and 5, and these directories are basically being created by the www-data, which is the NGINX user, right? It means these directories are basically being created by the NGINX. So we have defined, so if you remember, if I will cat the file configuration etc nginx.conf, you can see we have defined the labels 1.2. It means at a parent level just one directory should be present. So you can, so over here you can see at a parent directory, at a parent level just one directory is present, right? And inside this parent directory we will have the cache. If you will go to the 0 cd0, put ll, over here you will get the cache. You are getting the 9d. This is the second level. If you will get to the 9d, right, and put ll again, hash, here you will get the md5 hash, which is the actual cache value. See, this is the md5 hash, which is the actual cache value. 1 colon 2 means, it means we will define this is the first directory, then it will have some child directory, right, and that will have the cache. If we will go to some another one, suppose I'm going to some 3 number, so let's go to the 3, put ll. Over here we have the 6c, let's go to the 6c, and over here you will get another key. So there is the hash, there is the another hash. What is this particular hash? This is the key value which you have defined, and this is the key value which you have defined inside your NGINX configuration file. The scheme, then request method, then host, then URI. So team, this is the way how you can define the micro caching in your website. This is the way how you can improve the NGINX performance for the dynamic request as well. And we have already seen the drastical change inside the NGINX performance. If we are not defining the micro caching, right, and we just introduce the 1 second delay for the 200 requests, then my server processing power becomes so low that it was just able to process 4.7 requests per second. But as soon as I have cached the dynamic content, I hit the same request, my processing power will increase up to 11,000 requests per second. You can see the difference in the multiple thousand fold. So this is the way how you can define the static content cache, the dynamic content cache, and the Gzip files. This is the way how you can tune your NGINX. Team, if you have not reviewed my course, then I request you please review this course so that other people can also get the help. And I assume you are loving the material which you are learning, so you will rate this course 5 star. So thank you team, thanks for your time. If you have any doubt, any question, please let me know. I will be happy to answer your questions. Hello team, welcome back. Welcome to NGINX training, and today we will learn about the SSL certificate. We will see how we can enable the SSL certificate in NGINX and how we can switch to HTTPS from HTTP protocol. But before going with the lab, first we need to understand what is SSL and why we need SSL. So let's start with. So SSL stands for the Secure Sockets Layer. Secure Socket Layer is a standard security technology for establishing the encrypt link between server and the client. Typically a web server, the website, and a browser, or the mail server or the mail client or the application server. So it means SSL is a medium which will set up an encryption link between the client and server. In the NGINX, we are also learning about the client server model. So we need something by which we can set up the secure communication between the client and server. So that we need the SSL. SSL allows sensitive information such as credit card numbers, social security numbers, login credentials to be transmitted securely. Normally, the data between the browsers and the web servers is sent in the plain text. And in that case, if attackers are able to intercept the data that being sent between the browser and the server, they can see all the information and use that. More specifically, SSL is the security protocol. Protocol describe how algorithms should be used. In the case of SSL, protocol determines variable and encryption, both the link and the data being transmitted. It means all the data, all the links which are being transmitted with the help of the protocol, with the help of the SSL, that all being encrypted. Now let's understand how SSL work as a security protocol. What is the benefits which SSL is providing as a security protocol? So SSL attached with the HTTP and it will make a secure, and you can see a complete protocol which is called HTTPS. So when we are saying HTTPS, it means we are including HTTP plus SSL. HTTPS is a secure protocol which will use SSL algorithm to encrypt and decrypt the data. With the help of the SSL, SSL determines the variable of the encryption on both the link and the data being transmitted. So when we club the HTTP and SSL, we will create a all new protocol which is a very secure protocol, HTTPS. So whenever you are getting the HTTPS, it means it is the combination of the HTTP plus SSL. And as we discussed earlier, SSL is a secure which will encrypt the data which is being transmitted over the network. In the modern browsers, all browsers supports the SSL capabilities. And SSL is also a standard in the market. Whenever you will open any website, all the websites are almost using the SSL. Almost all are the websites are using HTTPS. If few websites are using HTTP protocol, then your browser also warn you that this site is not secure. So all the browsers have the capability to interact with the secure web servers using the SSL protocol. However, to use the SSL, the browser and server both need the SSL certificate that is established a secure connection. So we will see how we can create the SSL certificate and how we can use the SSL certificate to set up the HTTPS connection with my website Brownie. But before moving further, let's understand how SSL create a secure connection. So over here you are getting a diagram where we can see that multiple requests are going from client to server, and for each request server is responding. So whenever a browser attempts to access a website that is secured by the SSL, the browser and the web server establish a SSL connection using the process which is called SSL handshake. So whenever a browser attempts to access the website that is secured by the SSL, the browser and the server establish a SSL connection using a process which is called SSL handshake. SSL handshake is invisible to the user, but that happen instantaneously. Essentially, three keys are used to set up the SSL connection: the public key, private key, and the session key. Anything encrypted with the public key can only be decrypted with the private key and the vice versa. So we will use the public key private key combination to encrypt and decrypt the data over the SSL. Because encryption and decryption with the private and public key takes a lot of processing power, they are only used to during the SSL handshake to create the symmetric session key. After the secure connection is made, the session key is used to encrypt all transmitted data. So let's understand this one by one. So here in the first request, browser connect to the web server secured with the SSL. Browser requests the server identify itself. The server sends a copy of its SSL certificate including the server public key. So in the request one, browser is trying to connect to the server, and in the response which is numbered as 2, the server is sending the SSL certificate including the server's public key. And in the third request, browser will check the server certificate. It will check that it is unexpired and unrevoked. And if the browser finds that certificate is okay, it will create the encryption and sends back a symmetric session key using the server's public key, right? Which is request third. In the fourth request, server decrypt the symmetric session key using the private key and send back acknowledgement encryption with the session key to start the encrypted session. And then in the number 5, symmetric encrypted session is established between the browser and the server. So this is the complete SSL processing. Now let's move to the lab and let's see how we can enable the SSL on our website Brownie. So first we will go to the browser. In a browser, we will try to open our site. So we are able to log in my site. Now if we will go to the address bar, I'm using the Chrome. Over here we can see the Chrome is showing some message. This is non-secure connection. If we will open the network tool using press F12, click on the networks and refresh my web browser, we can see over here we are getting the different requests. Let's open any request. So suppose I'm opening any request like this custom JSON. Over here we can also see that request URL is the HTTP URL. This is not the HTTPS. So how we can make the secure connection enable on the NGINX? For this, let's go to the terminal and let's log in your machine. So we are logging in the machine. Let's go to a directory etc NGINX. Run a command ls and we are getting few directories over here. Over here we will create a directory called SSL. If you want, you can choose any name. I am choosing the name SSL for my simplicity. mkdir -p SSL. Hit ls. SSL directory is created. Once we will create the directory, we will create the SSL certificate. To create the SSL certificate, we can use the OpenSSL library of the NGINX. So we will use OpenSSL request, define the format. I'm defining X509. This is the standard format. Then we need to define the expire time. So suppose I'm defining 100 days as the expire time. Then we need to define the node. And this is going to be a new key. We are going to create the RSA key. The size will be about 2048 kilobyte. Save the key output using the key out. Define the location where you want to save the key output. I am defining the current location etc nginx inside the nginx SSL, and inside the SSL I am defining something like self.key. Then we need to define the public key output, and I'm defining the same location etc nginx SSL and define the self.certificate. Self.cert, hit enter. It will generate the private and public key for you. It will ask few information. We need to provide that information. It is asking for the country code. You can provide anything over here. Suppose I'm from the North America, so I'm providing NA. Then it will ask for the state or province. We will provide LA. It will ask for the city. We'll again provide the LA. Then company or organization name. We are providing level up, organization unit name, development, common name. Team, you can provide any information over here. This is no hard and fast rule that we need to provide some legitimate data over here. You can provide any data which you want over here. Hit enter. It will ask for the email address. I will provide my email address over here and it's done. Now if we will go to the SSL, put LL, we can see we have the self certificate and we have the self key, and both have the data. So it means SSL certificate and SSL public key is being created. Now I need to set up the certificate and public key at my server side. And to set up the SSL certificate and SSL public key at a server side, we need to configure the NGINX configuration file again. So I will clear out the console and I will open the nginx.conf. Here is my conf file. I will make it simple so that it will not confuse you. I'm going to remove all the first CGI processes which I have added earlier, and I will keep it as simple as possible. Suppose I'm going to remove the locations as well. We are going to remove this location as well. So now you can see this is the simplest version of my nginx.configuration. If you want, you don't need to remove anything from your configuration file. I am just taking it as simple as possible so that I can explain each and everything in short. Now first thing we need to understand that HTTPS protocol will not listen on port 80. HTTP protocol listen on port 80, but HTTPS protocol will listen on port 443. So we need to modify this particular listen directive first, and we need to make it port 443. After 443, we need to define SSL, that this is going to be the SSL call. And over here, after the server or before the server, we need to define the public and private key which I have created for my SSL certificate. So first I will define my certificate. I will use the directive SSL underscore certificate. Then we need to define the path of my certificate. So this is the complete path of my certificate, etc nginx ssl self.cert. Close this. After this, we need to define the public key as well, which will server use to send the certificate encryption data to the browser. So we will use ssl underscore certificate underscore key and define the path of your key. In my case, this is etc nginx ssl self.key. In your case, this location may be different. The key name and the certificate name may be different. So you need to configure these parameters, these directive as per your convenience. I will close this file, go to the browser again and refresh this. We can see my site is still listening on HTTP protocol. Now, once you will apply the SSL, I recommend instead of the reload, just restart your Nginx service. So I'm going to execute systemctl, restart Nginx. Hit enter. Nginx service is restarted. Let's check the status. Let's check the process ps-ef Nginx, and Nginx is running. Now we will go to the browser again, and in the browser we will refresh our URL. And this time we can see we are not able to access my site. Why? Because HTTP protocol is not listening on port 80. So what we will do, we will make a HTTPS call. HTTPS, as this is a self-created certificate, so it may possible you may get this kind of error. Your connection is not private. We will go to the advanced. Inside the advanced, and in the advanced section as well, Google Close is not allowing us to proceed further. It means we cannot proceed with the Google Chrome. Let's try to hit some other browser. So we will open the Firefox, and in the Firefox we will try to connect with my website HTTPS over the HTTPS. Let's hit enter, and Firefox is also displaying the warning. What we will do, the recommended way is go back, but we will go with the advanced, and inside the advanced we will go with the accept, risk and continue. Hit enter and see, we are able to access my site over the HTTPS, right? Although we have added the security exception for this particular site, but my site is right now listening over the HTTPS. If we will open the network tool using the F12, and then we will go to the network, let's scroll a bit and we will refresh my site. Now over here inside the domain you can see we are getting a lock over here. It means, and we are getting a message as well. This connection used to fetch this resource was secure. If you will open any GET request, you can see this is a HTTPS connection. This is not the HTTP connection. So this is the way how we can configure the SSL in our Nginx. And why we was getting the error on the browser, because the certificate which we generated, that is the sample personal certificate, right? If you will purchase some SSL certificate, you will not get these kind of error. If you are using your organization license certificate, then also you will not get that particular error. This is the custom SSL certificate which we generated for our testing, so that we was getting that particular error on the Google Chrome. If Google Chrome is not working, you may try the same lecture on some other browsers like Opera, Safari, Firefox, IE, Microsoft Edge. There's a multiple browsers where you can test this lecture. So team, if you have any doubt, any question, please let me know. Thank you team. Thanks for your time. Hello team. Welcome back. Welcome to NGINX training. And today we will learn a bit about HTTP2 protocol. Till now we have discussed about HTTP protocol, which is HTTP version 1.1. But today we will learn about the HTTP2 protocol, and we will see the application of HTTP2 protocol and why we should use HTTP2 over the HTTP 1.1. So let's start with this lecture. HTTP protocol was proposed by the Tim Lee, the pioneer of World Wide Web, who designed the application protocol with simplicity in mind to perform high-level data communication functions between the web server and the client. The first documentation version of the HTTP was released in 1991 as HTTP 0.9. The same version later led to the official introduction of the HTTP, which is called HTTP 1.0 in 1996. HTTP 1.1 followed in 1997, and since 1997, HTTP 1.1 will get a very little iterative improvements. But in February 2015, the Internet Engineering Task Force HTTP Working Group revised HTTP and developed the second major version of application protocol in the form of HTTP2. So we got the next version of the HTTP protocol as HTTP2 almost 18 years later. So let's discuss why HTTP2, why not HTTP 1.1. So the first reason is HTTP 1.1 was limited to processing only one outstanding request per TCP connection, forcing the browser to use multiple TCP connections to process the multiple requests simultaneously. It means whenever we are using the HTTP 1.1, and if we are going to access the 14 or 50 resources from the server, then my browser will open the 50 connections with the server, and a single request will serve only a single resource. So what is the problem over here? Using the too many TCP connections in the parallel leads to TCP congestion that cause the unfair monopolization at the network resources. Web browser using the multiple connections to process the additional request occupy a greater share of the available network resources, hence downgrading the network performance for the other user. So we are getting the two drawbacks, first from the network side and second from the server side. So the main problem is from the network side, that it will decrease the performance of the network. And in result, issuing the multiple requests from the browser also cause data duplication on the data transmission wire, which is turn require additional protocols to extract the desired information free for errors and end nodes. And while we have the one connection for the one resource, the industry was naturally forced to hack these constraints with the practices such as the domain sharding, concatenation, data inlining, and the sprinting. Right? Ineffective use of the underlying TCP connections with the HTTP 1.1 also leads to the poor resource prioritization, causing exponential performance degradation of the web application, growing in terms of the complexity and functionality and the scope. So we need something which will resolve these situations, and we will get the better performance at the network side and better performance at the web processing side. So as I mentioned, that the web browser using the multiple connections to the process additional request occupy the greater share of the available network resources. So we can also understand that particular thing with this example, that if the server and browser are connected and browser is going to access a particular site, and that particular site is demanding almost 100 resource, then browser will issue 100 requests to the server, and in result server also need to send 100 response to the web browser, and each response have the one resource. In short, we can take an example. If we are going to access a particular website, that website have the five resource: one PNG file, one CSS file, one HTML file, and two JS file. Then whenever you will try to access that particular site from the browser, browser will issue five requests to the server. Each request will carry one file. One request will carry HTML, another one will carry the CSS, another one will carry the PNG, another one will carry the JS, and the last one will also carry the JS. So if we have the five resources which needs to be collected at the browser side, browser will send the five requests, and server need to respond all five requests and send the resource which is required by the browser. This is a major drawback of the HTTP1, which is not suitable for the dynamic sites as we have in the current era. So what are the features of the HTTP2? How HTTP2 is better than the HTTP 1.1? And first is the multiplexed stream. It means HTTP2 will create the multiplexed stream by which we can send the data in both of the directions. So bidirectional sequence of the text format frames sent over the HTTP2 protocol exchange between the server and the client known as the streams. Earlier, the iterations of the HTTP protocol were capable to transmitting only one stream at a time. But with the help of the HTTP2, we can create the multiple streams at a same time. And earlier, the iterations of the HTTP protocol was capable to transmitting only one stream at a time, along with some time delay between the each stream transmissions. It means it will make your network more slow. On the other hand, HTTP2 helped server to disintegrate the HTTP payload into the small, independent, and manageable interleaved sequence of frames. This information is then reassembled at the other end. With the help of the HTTP2 help server to disintegrate the HTTP payload into the small chunks. These chunks are the independent and manageable sequence of the frames, and this information is again reassembled at the client end. With this capability, the data packets from the multiple streams are essentially mixed and transmitted over the single TCP connection. With a single TCP connection, multiple streams can be connected. All these streams are carrying a small packet of the response, and there's no order, right? These packets will be reassembled at the client side. Earlier with the HTTP 1.1, transmitting multiple parallel requests use the multiple TCP connection. But over here, we are just creating one connection which is called stream connection. But over here, we are only creating one stream TCP connection, and over their particular connection, we are opening the multiple streams. These streams are carrying the data from server to the client. We can understand that particular thing using this example. So here we have the browser and the server. Browser is the client and server is the application server. And in the response of a request, we are sending the data, but that data is divided into the multiple chunks. One more thing that we need to consider over here, these streams are communicating the data over the binary. This is not the plain text format as it was in the HTTP 1.1. HTTP 1.1 was transmitting the data in the plain text format, but HTTP 2 used the binary format. And binary format enables the exchange of multiple concurrency open independent bidirectional sequence without latency between the successive stream. The next benefit is the HTTP to server push. Server push is the new functionality of the HTTP protocol. This capability allows the server to send additional cacheable information to the client that it is not requested but anticipated in the feature request. It means with the HTTP2, server is just not sending the requested data, but it is also sending the additional data with that particular request. And that is the intelligence of the server is accepting that if these kind of requests are coming, then in the next request or in the consecutive request may client want that particular data as well, and server will also send the additional data. Because right now we are using the streams, so data transmission is very easy. It is not like that we can transfer a single data file at a single TCP connection. And we can understand that particular thing with this example. Server browser is just requested the HTML file, but server is sending the HTML, and along with it is also sending the referred file which is referred with that particular HTML, which is the CSS and the image. Client didn't ask for the image, client didn't ask for the CSS, client just asked for the HTML. But over the HTTP2, server is basically also sending these files because these are the files which are referenced inside the HTML file. This mechanism save request respond round trip, reduce the network latency. Definitely, if we are getting the supportive data in a single request, then client will not send the multiple requests, and server can prioritize the push resources, a key performance differentiator in the HTTP2 and the HTTP1. So this is a very good feature which will create the huge difference between the HTTP2 and HTTP1 performance. If you have a very heavy traffic website, then I strongly recommend you should use the HTTP2. You can also include that particular lecture in the NGINX performance. So you also consider the HTTP2 as the performance booster. The next feature is the binary protocols. So HTTP 1.x or 1.1 used to process the text command to complete the request response cycle. But HTTP 2 will use the binary command to execute the same task. That is why the multiple data stream, the small data packets are possible with the help of the HTTP 2. Because HTTP2 is not using the plain text. It doesn't need to break the plain text and again need to join the plain text at the client side. It will use the binary data. So HTTP2 can create the multiple binary packet, and over these binary and in the binary packet form, it will send your data to the client, and at the client side, these binary will be processed and created into the HTML or text format. So sending the binary packet is also helpful to the network, right? Network need to parse the frames available for the binary, and the actual semantic remain the unchanged. And this kind of implementation is also effective network utilization, because we are not sending the heavy data files over the network, we are just sending the small data chunks over the network within the multiple stream over the same TCP connection. This also eliminates the security concerns associated with the textual nature of the HTTP1, right? Such as response splitting attack. What is response splitting attack? It means whenever your complete response, the complete file is basically transmitting over the network, somebody can get that particular file, change the sequence, and then again submit the file to your response. You will get that file, but that file is basically manipulated by someone. So here with the HTTP2, we are also enabling the security at my network layer. The next feature is the stateful header compression. So what is the stateful header compression? It means it uses the HPEC specification as simple and secure approach to the header compression. Delivering the high-end web user experience require website rich in content and graphics. The HTTP application protocol is a stateless, which means that each client request must include much information as the server needs to perform the desired operation. This mechanism causes the data streaming to carry multiple repetitive frames of information, such as the server itself does not have to store the information from the previous client request. And in that case, website serve media rich content, client push multiple near identical headers frames between the leading to latency unnecessary consumption. So deliver the high-end web user experience requires website in rich content and the graphics. The HTTP application protocol is a stateless protocol, which means each client request must include as much as information server needs to perform the desired operation. And this, whenever server need to send the multiple data packet, it will make the header more heavy, right? So we need to make the more consecutive headers to the client. So HTTP2 implementation will address the multiple header or identical header problem with the HTTP1. Whenever the HTTP1 used to send the large number of headers which are the redundant headers, the HTTP2 used the HPEC specification as the simple and secure approach to header compression. Both client and server maintain a list of headers used in the previous client server request, and on the basis of the previous client server request, HTTP2 will skip the header in the consecutive request and only send the relative data. So HPEC mechanism compress the individual value of each header before it transmitted to the server, which then looks up the encoded information in the list of the previously transmitted header values to construct the full header information. So we will send the compressed header, and that compressed header will look after the previous headers to make it complete, to make itself complete. So what HPEC will do, HPEC will compress the individual value of each header, right? The individual value of each header will be compressed by the HTTP2 before the header is being transferred to the server, which then look up the encoded information in the list of the previously transferred header value to reconstruct the full header information. And at the server side, these individual values will basically look up the previously transferred header and construct the complete header for the request. Let's understand few more benefits of the HTTP2, which is the web performance. So HTTP2 will basically increase the web performance. HTTP2 benchmark results are quite impressive as compared to the HTTP1. Then the next one is mobile web performance, because in the mobile phones we have the small RAMs, right? And the processing, and user wants the fast web performance, otherwise user will not engage on your website. So HTTP2 also helps in the mobile web performance. The cheaper internet, because we are using the less bandwidth, we are using the less network. HTTP2 is also helped in the cheaper internet connections. Expensive reach, definitely HTTP2 have the expensive reach, because in the data transmission the data are basically packed as a binary, and these data which is being transmitted over the streams are not related to each and other. So we can send n number of data packets and we can send large response over the HTTP2 instead of the HTTP1. Media rich experience, which we just discussed, and improved technology utilization. Definitely the multiple benefits also improve the technology utilization when we are using the HTTP2 over the HTTP 1.1. Let's discuss the HTTP2 client support, that which browser support the HTTP2 client at which extent. So over here we have the list and we have the score. These scores are basically from out of 50. The Google Chrome score to support the HTTP2 is 40 out of 50. On the same way, the Mozilla Firefox have the 36. The Microsoft Windows IE have the 11, Apple Safari is just 9, and Opera is 21. So over here we have the scores of the client wise which supports the HTTP2 in better way. Google Chrome and Firefox supports the HTTP2 much better as compared to the other browsers. So this is about the HTTP2. In the coming lecture, I will show you how we can add the HTTP2 in our NGINX. If you have any doubt, any question, please let me know. Thank you, team. Thanks for your time. Hello team, welcome back. Welcome to NGINX training, and today we will see how we can enable the HTTP2 in the NGINX and how we can make sure that instead of the HTTP 1.1 my website will use the HTTP2 protocol. So first we will go to the browser and we will see what protocol is being used by the website. So over here in the Firefox, I'm going to open my website. You can see we are able to access our website. We will open the network tool by pressing F12. Over here we will go to the network and we will refresh the website. The multiple resources are basically being fetched by the server. You can click on any request. So let's click on this particular JS request. Over here we are getting the connection type, which is keep alive, the date, e-tag, last modified. If we will go to the request, this is the request, right, which is saying that the version of HTTP which is being used is the HTTP 1.1. Now we need to make sure that we will use the HTTP 2 instead of HTTP 1.1. And to switch from HTTP 1.1 to HTTP 2, we need to rebuild the NGINX. So we will go to the terminal first. Now we will go to the server and we will identify the configuration of my running NGINX. For this, we will execute a command NGINX -V. So this is the configuration with which I am executing my NGINX. I will simply copy this configuration and save this configuration at some safe place. And after this, we need to go to the directory where we have extracted our NGINX. So I will go to the root NGINX and here is the NGINX directory, port ls, and we have the configure over here. We need to execute the configure again and we will search for the HTTP. Hit enter and here are the modules which we are getting for the HTTP. If we will scroll a bit, we will get the HTTP module HTTP version 2. Enable HTTP version 2 module. So what we will do, we will copy this and we will configure the NGINX again with this particular module. So I will clear out the console. I will execute the configure. We need to provide the earlier parameters which we have copied from the NGINX-V. Or what you can do, you can execute simple NGINX-V like this. Then you can execute the configure. You need to provide all these parameters and provide one extra parameter for the HTTP2. So this was the module --with -HTTP underscore v2 underscore module. Let's hit enter. It will take some time. We have to wait. It's completed. Clear out the console. Execute make. Make will take some time. Make is completed. I will clear out the console again and we will execute make install. It's done. Clear out the console. Let's verify if the NGINX is running. ps-ef grep NGINX. NGINX process is running. Let's verify the parameters. NGINX-v and yes, HTTP module is present, right? It means I have built my NGINX with the HTTP2 module. Now to enable the HTTP2 protocol, we need to modify the NGINX configuration file. So we will open the configuration file via etc nginx.conf. Inside the conf, next to the listen block, we need to go to the insert mode and after the SSL, I will provide one more parameter space HTTP2. That's it. Let's save your file. Verify the NGINX configuration. Configuration are good. Let's refresh the browser one more time before reload the NGINX configuration. So I will refresh it one more time. I will check the request and request version is still HTTP 1.1. Now we will go to the terminal and we will reload the NGINX. NGINX-s reload. Hit enter. We will go to the browser again. Now we will copy the URL. We will open the new tab. Open the network tools. Put the URL and hit enter button. So we can see my website is loading and we are getting all the requests in the network console. Over here we have some CSS, some have the PNG, JPG files, some are the JS files. Let's open any request. So suppose I'm going to open the CSS first and over here we can see the HTTP protocol version is switched. Now we are using HTTP 2. Same if we will open some JPG file, HTTP 2. Any request which you want, you can open that. Suppose we are open for the JS, we are getting HTTP 2. So this is the way how you can switch from HTTP 1.1 to HTTP 2. Team, we need to make sure in some cases Nginx reload is not enough to reflect the changes. In that case, you need to restart your Nginx service, right? So you need to execute systemctl restart Nginx. Although some Nginx version accept the reload, but some Nginx version requires the service restart. So in any case, after these changes, your HTTP protocol is not reflecting in your request. You need to take the restart of your Nginx service. So team, if you have any question, any doubt, please let me know. I will be happy to answer your questions. Thank you. Thanks for your time. Hello team, welcome back. Welcome to Nginx training. And today we will see what is rate limit in Nginx and how we can apply the rate limit in Nginx. So first we will discuss about the rate limit concept, then we will go to the lab. So rate limit in Nginx is something which will limit the amount of HTTP request a user can make on a given period of time. Rate limit is one of the most useful feature in the Nginx, which will limit the user to access a particular request over a period of time. It means suppose a user is accessing a particular request 100 times and we want that user cannot access that particular request within a defined time more than 10, then we can restrict the user with the help of the rate limit. We can understand the feature by this particular diagram. Over here we have some hacker, some malicious user, and that user is sending the multiple requests to my Nginx server, like a denial of service agent attack. It means thousand or million of requests will land on my Nginx server, and these requests will try to access a particular resource on my server. And in that case, if rate limit is not applied on my server may behave strangely because the malicious user or the attacker have sent thousands or million of the requests, and these requests may crash my server or hang my server for a particular amount of time. This will cause me the production downtime as well. So we need to make sure that we will provide the proper security so that it will not impact my production servers. Rate limit used for the security purpose, for example, to slow down the brute force password guessing attack. If you have the brute force password guessing attack with the help of the rate limit, we can minimize that or we can avoid that particular attack because we are putting the rate limit on a particular resource, and that resource on which we are putting the rate limit, that resource will not be accessed more than the rate limit within the defined period. Rate limit also help us to protect from the denial of services attack, which is called DOS attack. So over here, we will limit the incoming request to a value typical for read users and identify the target URLs, that which URLs are basically being targeted by the malicious user or the attackers. Then let's understand how Nginx rate limit will work. Nginx rate limit will use the leaky bucket algorithm, which algorithm is widely used in the telecommunication and packet switched computer network to deal with the burstness and the bandwidth is limited. So what is this particular algorithm? What is the leaky bucket algorithm? So the analogy of the leaky bucket algorithm is like that. So we have a bucket, and if the water is poured at the top and leaks from the bottom, if the rate at which the water is poured it exceed the rate the water is basically leaked, then the bucket overflows. In terms of the request processing, the water represent the request from the client and the bucket represent the queue where the request wait for the processing. And these requests will be fulfilled in the FIFO manner. It means first in, first out scheduling manner. The leakage water represent the request exited the buffer for processing by the server, and the overflow represent the request that are being discarded or never served by the service. So this is the concept of the leaky bucket algorithm, which is very simple. If the inflow and outflow is equal, then server will not reject any request. But if the inflow will increase and outflow is static, then server will reject all the additional request which is trying to access the resource. Now let's go to the Nginx and let's see how we can apply the rate limit on my server. So over here we are on our terminal and we will see how we can apply the rate limit. To see the rate limit, we need multiple requests on my server from the multiple host, right? It means we need some tool which will perform the load testing. In the last lab, we have seen the Apache Beam, but we will use some other tool. If you want, you can use the Apache Beam as well, but this tool will provide the better logging as compared to the Apache Beam. So over here, to load this particular test, we will use the tool called Seize. And to install the Seize, you need to execute apt-get install Seize, hit enter, and it will install the Cs on your box. It's done. Let's clear out the console, and on my server I will try to access some particular resource. So if we will identify some particular resource URI, that will be great. So we will go to the browser and we will identify any resource which we want to access. So suppose we want to access this particular custom.js. This is the path of your custom.js. I will copy that particular path. Let's hit this path curl -ik to just add the header and paste it. Hit enter, and you can see we are able to access it over the NGINX 1.91. Now we will try to access the same resource with the help of the Cs. For this, first sort out this particular path so that I can show you. And over here we will try to execute Cs SIE. Then we need to provide the syntax to Cs. So we will provide Cs -v, it means verbose, -r, define the number of requests. So suppose I am defining 2 requests. -c, define the number of connection, and I'm defining suppose 5 connections, and then define the URL which you want to hit. So suppose I'm going to access this particular resource, so I will provide it over here. So over here we are providing 2 requests from 5 connections. It means total we are trying to put 10 requests on my server which will access this particular resource custom.js. Hit enter, and it's done. You can see all 10 requests are basically processed. We are getting HTTP 200, total 10 hits, availability is 100%. The transaction rate are 200 requests per second, right? Data transferred is this and response time is this. So I was talking about this particular response. On the Apache Beam you will not get this kind of response, right? I would like to show you that how many requests are basically processed and how many rejected. Over here you can see none of the requests rejected on my server. I'm able to access the same resource 10 times in just 0.5 second. Let's clear out the console, and on a new terminal let's log in your server and execute a command top. Then press 1. So over here you can see we are getting the CPU uses and we are getting the memory as well. Now let's go back to the previous terminal, and we are going to open 5000 connection for the 20 request. It means it will hit 5000 multiplied by 20 request on the same resource on my server. Let's hit enter and go to your box. Over here you can see you are getting the spike on your CPU. Right now my CPU is running almost 82%, right? And it's still increasing 83%. It may possible your CPU use will reach to 100% and your server may crash, right? We can see the CPU use and memory use both are basically jumping. And once we executed this command, we was getting some warning that the total number of user is kept to 255. It means the concurrent connection we took 5000, it should be 255. The same result you are getting over here, that only 5100 hits are basically being done. And on the 5100 hits, we was getting the 82% CPU, right? The total response time was 0.38 second and total processing time is 15 second. Let's clear out the console, and this time let's try to make the more number of requests. Suppose I am putting 2000 requests with 500 connections. Hit enter, and still we are getting the warning. Let's go back to the other terminal, and you can see over here we are getting 86%, 85% CPU. So by this particular example we can learn, if you don't have the rate limit on your box, right, then attacker can attack your system and they may completely hang your system. You can see right now my CPU size is consistently 84%. It means my system is performing downgraded. The performance is not like the common performance, right? We will go to the other terminal and stop it by pressing the Ctrl C. 25,000 are basically executed in the 75 second. So let's see how we can apply the rate limit in NGINX. For this we will open the configuration file, and inside the configuration file, to apply the rate limit you need to go to the HTTP context. So we will go to the HTTP context, go to the insert mode, and over here we need to define the rate limit. To define the rate limit directive, and by limit request zone you can define the rate limit directive. And after this you need to define the entity on which entity you want to apply the rate limit. If you will define like server underscore name, then we are applying the rate limit on this particular address. Then we are applying the rate limit on this particular IP address. all the request which is accessible on this particular IP address or the host machine, rate limit will be applicable on that particular rate limit will be applicable on these requests. So this is not a good idea. So what is the second parameter? Second, you can define the rate limit on binary remote address by binary underscore remote underscore addr. This will apply the rate limit on the client IP. It means the client who is sending the request, it will identify the IP of the client and apply the rate limit on the client IP. This is the most common way people do apply the rate limit. But if you want to apply the rate limit on the request URI, you can also define the rate limit on the request URI. So you can define like request underscore URI. By this particular way, you can also define the rate limit on the request URI. Suppose we are defining the request limit on the request URI. After this, you need to define the zone, and in the zone, you need to define your zone. So suppose I'm defining test underscore zone. Define the size of your zone. Suppose I'm taking it 10 MB. Then you need to define the rate to define the rate limit. And suppose if you want to apply the rate limit like 60 requests per minute, you can apply the rate limit like this. And if you want to keep it 60 requests per hour, you can define like this. If you want that one request per second, you can define like this. Once the request limit zone will be defined, you need to go to the location directive. So over here, I'm defining the request limit on the request URI and I'm applying the request limit one request per second. Once you will define this directive, you need to go to the location, and inside the location, you need to define limit underscore request. Then you need to define the zone which you have declared. So I have declared test zone. Paste it here, save this, close this file. Verify the NGINX configuration. The configuration, and we have an error. So we need to resolve this error. And this directive is not a correct directive. This should be like limit request space zone equals to zone name. Now save this. Verify the configuration. Configuration is okay. Reload the NGINX. And after the reload, let's execute the seize command again. So this time, suppose we are executing two requests in two connections. Hit enter, and we can see only one request get executed and rest all three requests was dropped. See, all three requests was dropped, only one request get executed over here. This happens because of the rate limit we have defined. So over here, what is happening? First two requests executed in a first batch because we are defining two connections, and second two requests executed in a second batch. But the processing time was so fast that all four requests submitted within the second, so that as per my rate limit, only one request gets succeed. If you will update it, and suppose we are hitting the request in the 20 connections, right? Two requests per connection, hit enter, and this time as well only one request succeed and rest all of the request got failed because all these requests executed within the less of second time. Let's clear out the console, and instead of the seize, we will execute it with the help of the curl. So we'll execute curl hyphen ik, hit enter, request successful. Let's again hit enter, request successful. Let's again hit enter, request successful. Let's again hit enter, request successful. Every time when I'm hitting the request from my local machine, I'm getting the success code. Why? Because I'm hitting the request after 1 second time interval, right? So that I'm getting the success message. But when Seize is putting the request, Seize are putting all the requests concurrently within the particular timestamp that is less than a second, so that only one request is getting processed and all other requests are getting failed. But this will create another problem. Suppose we have the million of users, and due to the rate limit, it may possible that some valid request, some legitimate request may be rejected. So how we can handle that particular scenario? To handle that particular scenario, we again go to the configuration file, and inside the configuration file, inside my location default block, I will define one more parameter with the request limit, which is called burst. And over here, you need to define the number of requests which you want to be burst. So suppose I'm defining 5 requests will be in the burst. So what is the use of burst over here? The burst parameter define how many requests a client can make in excess of the rate is specified by the zone, right? It means also the rate is specified 1 request per second, but with the help of the burst, we are basically enable the client to make 6 requests per second. Also with the help of the burst, NGINX will keep the request in the queue, right? And it will keep at most 5 requests in the queue, and it will try to process all the requests. Let's see, let's save this, reload the NGINX, and let's execute the Cs again. And suppose this time we are executing 5 requests for 2 connections. Hit enter, and you can see all the requests are basically being processed, right? Also we can see that this request being processed within the 0 second, then next processed within the 1 second, 2 second, 2 second, 2 second, 2 second, and next all processed in the 2 second. Total hit 10 hits, but over here we can see the 10 requests processed in the 9 second. So also this is improving the use case, but this is also making the server slow. We are getting the slowness in the server. So how we can take care of this problem now? So with the help of the burst, also we are getting the solution of my problem, that request will not be immediately rejected. It will take some grace period, right? But this will introduce some delay in my NGINX. So to resolve this problem, we will again open the configuration file, and after the burst, we will define one more parameter over here. Put a space and keep no delay, right? So with the no delay parameter, NGINX still allocates the slot to the queue according to the burst parameter and impose the configuration rate limit, but not by spacing out of the forwarding queue request. It means with the help of the no delay, also with the rate limit, we are processing these particular 5 burst requests within the same slot of queue, but not exceeding that particular queue. It means not exceeding the queue time for the request. Let's save this and execute the same C's code again. Hit enter. Okay, so we forgot to reload the Nginx. I will clear out the console and reload the Nginx. Once reload will be done, we will execute the C's command again. And over here we are hitting 5 requests in 2 connection. It means we are hitting 10 requests. This time we will see that 6 requests will be processed and 4 will be failed. And over here you can also see that processing time is just 0.3 second. Earlier that was 9.8 second, right? So what is happening over here? With the rate limit, which is 1, burst is also adding 5 requests in the same time slot, right? And with the help of the no delay, these 5 requests, these additional requests are basically processed with the nginx in the same queue, but rest all of the requests will be immediately rejected. Why? Because the queue time is not extending, and nginx can only process 5 requests in the specified time queue as per the rate limit. So this is the way how can you configure the rate limit in your Nginx, and how can you make your Nginx server more secure. Team, if you have any doubt, any question, please let me know. I will be happy to answer your question. Thank you, team. Thanks for your time.
Hello team, welcome back. Welcome to Nginx training, and in this section we will learn Nginx as a load balancer. Before working with the Nginx as a load balancer, first we will see what is the load balancer, and we will see how load balancer will make the front-end services more reliable and highly available. So let's start with the load balancer introduction part. First, we learn about the definition of the load balancing. So load balancing refers the efficiently distributing incoming traffic across the groups of backend server, also known as the server farm or the server pool. So basically, whenever we are talking to the load balancing, we are distributing the incoming traffic to the multiple backend servers or multiple front-end servers. These servers are part of the single server group or single server pool. In the current world, we have the modern high traffic website which are serving hundred of thousand concurrent requests from users or client and return the correct image, text, video, application data, that all in the fast and reliable manner. So how it becomes possible? If you have a single backend server, you have a single front end server, and you are getting that much of traffic, then definitely your server is going to hang, your server is going to melt down, right? It means your server will crash and your server will not be able to serve the complete request. So to make the process efficient, to make the web application highly available, we will use the load balancer. And what load balancer will do? Load balancer will distribute the incoming traffic across the multiple servers who are using the same application, who are executing the same build of the application, right? So load balancer act as a traffic cop, sitting in front of the servers and routing the client request across all the servers, capable to fulfill those requests in a manner that maximize the speed and capacity utilization and ensure that there no one server is overworked. It means if we have the 5 web servers as a front end application and we will put a load balancer in front of these 5 web servers, then all the traffic which is coming to the load balancer, that traffic will distribute on all these 5 web servers, right? And load balancer will make sure that none of the one server will be overloaded in all of the 5 web servers. Load balancer also makes sure the failover. It means if a single server goes down, the load balancer redirect the traffic to the remaining online servers, and when a new server is added to the server group, the load balancer automatically starts the traffic on that particular server. So by this particular way, load balancer also makes the web application fail safe. So over here we are listing out few functions of the load balancer. The first is the distribute client request or network load efficiently across the multiple servers. That is the basic and primary duty of the load balancer. Load balancer will distribute the traffic across the available servers for that particular request. And the servers behind the load balancer could be the 2, could be 20, could be 200. It doesn't matter, right? It all depends on the requirement. It all depends on the business requirement and the capacity of your web servers. The second function of the load balancer is ensure high availability and reliability by sending requests only to the servers that are online. Yes, that is the another responsibility or another functions of the load balancer. As I told you, if you have a 5 servers, 5 front-end server in a single group or a single server pool, and you are using single load balancer to redirect the traffic to these 5 servers. If out of these 5 server, one server will go down, right? That server will be offline, then load balancer will ensure that it will not send the traffic to that particular server. Now the question is how load balancer will make sure that the server is online or not. So that is the part of another discussion. When we will make the NGINX as a load balancer, we will see how NGINX or load balancer will ensure that a server is online or offline. The another functions of the load balancer is provide the flexibility to add or subtract server as a demand. That is something we called auto scaling and the auto descaling. It means in the current world, load balancer are also dynamic. In every business, the cost is very critical. If you are using 20 server but actually you need only 5 servers, then we are wasting the money of rest of the 15 server, right? Although in the daytime, in the peak hours, we need 20 servers, but in non-peak hours, in the evening or in the night, we only need 2 server, 4 server, 5 server, or up to 10 servers, which are enough to serve the traffic to my clients. In that case, we are wasting the money on rest of the server which are already running, but we don't need them. So in the modern world, load balancer are also smart and they can scale and descale the servers as per the traffic, right? If we have the heavy traffic, then load balancer will scale up the servers, and if we have the low traffic, then load balancer will descale the server. But to achieve the scaling and the descaling, we need to configure the load balancer in that particular way, right? We need to put up the engineering effort to make the load balancer auto scalable and auto descalable. Here we are not auto scaling and auto descaling the load balancer. We are auto scaling and auto descaling the web server which is running behind the load balancer. So here is a picture which will define the load balancer. Suppose we have the end users, and end users are using the internet to connect my web application. So from the internet, request will direct land on the load balancer, right? That could be the software load balancer or that could be the hardware load balancer. Shortly we will discuss about the software and hardware load balancer as well. Then that particular load balancer will predict the request, right, and send that particular request further to the application servers. If we have the n number of application server, then load balancer will identify the application server who can serve that particular request more fast and more reliably, right? And once the load balancer will find out the server, it will send that particular request to that particular server, and all these processes are very quick. So these are the functions of the load balancer, and the basic function is distribute the load across the application server. It doesn't matter these are the front end application server or the back end application server. Then let's discuss the algorithm which load balancer can use. The basic and famous algorithm for the load balancing is the round robin. In the round robin, requests are distributed across the groups of servers sequentially. It means if we have the three application servers and we have the load balancer, then load balancer will distribute the request to all three servers. First request will go to the first server, second will go to the second one, and third will go to the third load balancer. So requests are distributed across the group of the server sequentially. It is easy for the load balancer to implement, but it does not take care into account of the load already running on the server. It means the implementation is quite easy to implement, but that algorithm will not determine if the server is already overloaded or not. It means all the high processing requests may land on the server too, but due to the round robin fashion, the load balancer is still throwing the request on the server too. So this is the old way. Right now, none of the modern load balancer are using the round robin, right? Round robin load balancing is still the part of the DNS load balancing. When I'm saying the DNS load balancing, it means with the single DNS record, you can configure multiple A-type IPs, right, which are the IP of your application server. And whenever someone hit that particular CNAME record, right, the load will be distributed across the configured application server in a sequence. But round robin is not the favorable part in the software load balancing. The second one is the least connection method. In the least connection method, a new request is sent to the server with the fewest current connection to the client. It means in the least connection method, load balancer will find out which server have the minimum request with the client and redirect that request to that particular web server. Where the round robin does not account the current load on the server, the least connection method does take this evaluation, and as a result is usually drive superior performance. It means least connection algorithm is better than the round robin in the load balancing. And the third one is the least response time method. Over here, the send request to the server selected by the formula that combine the faster response time and the fewest active connection. It means it will also consider the least connection model, plus it will add the faster response time implementation. More sophisticated than the least connection method, because over here we are countering the two factor, even the least connection plus the faster response time. It means which server can respond that particular request more faster, and this method is basically used by the NGINX Plus. So least response time method is used by the NGINX Plus load balancer. Whenever we will configure the NGINX as a load balancer, that will use the least response time method algorithm as a load balancing algorithm. We have few more algorithm, and one of them is the least bandwidth method. This algorithm is relatively simple. The least bandwidth method looks for the server currently serving the least amount of traffic as measured in the megabyte per second. It means it will identify the web server on the basis of the bandwidth, which is basically transmitted between the networks. And last is the hashing method. Hashing load balancing algorithm distribute request based on the key you define, such as the client IP address or the request URL. So whenever you want to define that specific server will use the specific request, right, we will use the hashing method. And with the help of the hashing method, the load balancer will behave on the basis of the request defined for the load balancer or on the client IP. Now let's discuss few related fundamentals with the load balancing. And the first is the session persistence. It means whenever we are putting the load balancer, right, we are sending the request across the application servers. In that case, how we can ensure the session persistence? Session persistence means once a session will be connected between a user and a particular server, that session will be maintained, right? It means once a user will send a first request and suppose it is being served by the server A, then the next request from the same user will be served by the server A, not by the server B. So we are making a persistent connection between the user and the server. So persistent connection is helpful because information about the user session is often stored locally in the browser, right? For example, in the shopping cart application, the items in the user's cart might be stored in the browser level until the user is ready to purchase these items. And in that way, changing the server receives the request from the client in the middle of the shopping session can cause performance issue or the outright transaction failure. In such case, it is essential that all the requests from the client are sent to the same server for the duration of the session. This is known the session persistence. The best load balancer can handle the session persistence as needed. So session persistence is the basic and very necessary part of the load balancer. right? In the Nginx, session persistent can be maintained by the upstream. We will discuss how we can maintain the session persistent and how we can define the upstream in the Nginx. The second fundamental is the dynamic configuration of the server groups. This is also called the auto scaling and the auto descaling. So many fast changing applications require new servers to be added or taken down on the constant basis. This is common in environments such as Amazon Web Services, Elastic Compute Cloud, or Google Cloud Servers or Google Cloud Load Balancing, which enables user to pay only for the computing capacity that they actually are using, while at the same time ensuring that the capacity scale up in the response traffic spikes. In such environment, it's greatly help if the load balancer can dynamically add or remove server from the group without interrupting the existing connections. So we can scale up the servers as a part of the so we can scale up the server whenever load balancer is saying that we are getting the heavy traffic, and it will scale down the server when the traffic is low. So that is called the dynamic configuration of the server groups, and that is the another related topic to the load balancing. And the third one is the hardware versus software load balancing. That is the another part. And right now most of the load balancer which are using in the web applications are the either software based load balancer or the network based load balancer. So load balancer typically come in two flavors, the hardware based and the software based. Vendor of the hardware based solution load, and if we are using the hardware load balancer, then the vendors of the hardware load balancer loads proprietary software onto the machine they provide, right? Which often use the specialized processors, right? To cope with the increased traffic at your website, you have to buy more or bigger machines from the vendor, right? Software solution generally is the cost effective, right? Because in the software solution, if we are using the software load balancer, then definitely we are not going to purchase the load balancer machine from the vendor, and we don't have the dependency on the vendor as well. We can create our own machine, right? We can define the size of that particular machine, and then we can set up the software based load balancing either with the help of the nginx, or we can use the cloud functions or the cloud load balancer, which is also the software based load balancers. And the next thing is the nginx as a load balancer. So whenever the client is sending the request, that request will land on the nginx, and nginx further will communicate to the application server which are working with the nginx as a load balancer servers, right? So over here nginx will work as a load balancer, and nginx is the front end service which will accept all the connections from the customer or the client and forward these connections to the application server. And that is the benefit of the nginx, and how we can and why we are able to use the nginx as a load balancer, because nginx also work as the reverse proxy. And over here you can see this is the basic fundamental of the reverse proxy. The application server will get the connection, forward the connections to the application, get the response, and forward the response to the client. That is the reverse proxy and basic principle of the reverse proxy. So by this particular way, nginx will be able to work as a load balancer, also as a application server, also as a caching server. So thank you team, thanks for your time. I hope you are pretty much clear with the definition and the functions of the load balancing, right? In the coming lectures, we will see how we can use the Nginx as a load balancer. So thank you team, thanks for your time. Hello team, welcome back. Welcome to Nginx training, and in this lecture we will set up a simple load balancer with the help of the Nginx. Before going with the lab, let's see what we are trying to achieve in this lab. So over here we will keep the two application servers, and then we will keep the one Nginx as a load balancer. User will send the request to the Nginx, and then Nginx will send the request to the application server. Here my first application server will be my Brownie site. For the second application server, I will spin up a new machine which will serve a HTML page, which is a static page. And for the Nginx, I will spin up a third machine which will work Nginx as a load balancer. So in this lab, in the load balancer lab, we are going to use three machines, one for the Brownie site, which is already running, and we will spin up two more machines, one for the HTML page and another one for the Nginx as a load balancer. So let's go to the DigitalOcean and spin up two more machines in your DigitalOcean account. So here we are on DigitalOcean and we are already running one machine, Ubuntu custom Nginx. I will create two more Ubuntu machines. So I'm going to create the Ubuntu 18.4 machine with the basic plan of $5 per month. And I will name my machine Ubuntu second app server. Click on create. Similarly, I will create one more machine for the load balancer, and I will name my machine Ubuntu load balancer. I will create one more droplet over here. we can see my all three machines are running. I will log in all three machines in separate terminals. So over here I have opened all three machines in the separate terminals. Over here in the black terminal I am logged in on a Ubuntu custom NGINX, which is the machine we are using since starting of this particular course. In the second terminal, here on the green window, I have logged in Ubuntu second app server, and here on the white background, I have logged in Ubuntu load balancer. So these are three machines which we are going to use. First, let's go to the custom Nginx and let's see if Nginx process is running. So we can see Nginx is running. So let's try to access my website on this particular Nginx. So I will execute ifconfig. Here is the IP. In my browser, I will hit this IP and it is not loading my site. It means we have done some changes in the configuration in recent lab, so we need to modify the configuration to reach my Brownie site. So first we will go to the configuration file etc nginx, and over here we will see we have the configuration file nginx.conf, right? So we will open this configuration file in the vi mode, nginx.conf, and I will make it simple to remove all the unnecessary configuration from here. So I have made it more simple. I'm just using the user, worker, events, then MIME types, and in the server I'm using my server name, then root, then location. I will save this, check the configuration nginx-t, configuration is okay, reload the nginx. Hit enter, reload is done. We will go back to the browser, paste it here, hit enter. And we can see Brownie site is working perfectly fine. Right, now what I will do, I will go to the terminal back, and on both of my other machines I will install the nginx. So sudo apt-get update, execute the same command on white terminal as a load balancer, clear out the console, and now we will install the nginx. So apt-get install nginx, hit enter. It will install the nginx. It will ask for the confirmation. Install the nginx on the green terminal as well, hit enter, provide the confirmation, and let's wait until the nginx will be started. Over here nginx is done. Clear out the console, check if nginx is running, ps-ef, grep nginx. Nginx is running on this machine, on the load balancer machine. Nginx installed over here as well. Execute the same command, ps-ef grep nginx, and nginx is running over here as well. Now what we will do, one application is running over here, which is the Brownie. Over here we have also started the nginx. Let's try to access the nginx on this machine, which have the IP 167.172.161.192. I will put ifconfig. This is my IP. This is my IP. Go to the browser and open this IP over here. See, we are getting the Nginx web page. Now we have the two sites, right? We have the two application server. One is executing the Brownie site, which have the IP ending with 130, and another executing the default NGINX, which have the IP ending with 192. Right? We have spinned up the third server as well, the load balancer. And now what we will do, we will edit the configuration of my third server so that we can execute the Nginx as a load balancer. So let's go to the terminal. And now we are on the third terminal, and now we are on the third node, which is Ubuntu load balancer, right? This node is also executing the nginx, but over here we will configure the nginx as a load balancer. For this we will go to the configuration file vi etc nginx nginx.conf. So over here we have the default nginx.configuration file. I will edit this file and only keep the relevant content, remove the all unnecessary content from this file. So over here you can see I have removed all the unnecessary content from this file. I just keep the user, worker, process, PID, include module enable, events, and HTTP. Inside the HTTP context, I have just using the MIME type to support the Brownie site and access and error log definition. As this is not the handcrafted Nginx, so I'm defining the log location inside the HTTP context. Now to make this Nginx as a load balancer, we need to add few more context over here. And the first context which we need to add is inside the HTTP context. And inside the HTTP context, first we need to add a context called upstream. So upstream is the context which will help Nginx to work as a load balancer service. After the upstream context, we need to define the name of my upstream. So you can define any name. Suppose I'm defining app server. Open and close the upstream. And inside the upstream, you need to define the application server on which you want to redirect the traffic. For this, you need to use the directive server, and the value of this directive, you need to provide the IP address of your application server or the domain name of your application servers. So I will provide the IP of my application server. This is the first application server which is running the brownie site. Put semicolon, define the server again. And this is the IP of my second application server which is running the default NGINX. I will put the IP over here, right, and close this. So I have defined the upstream. Upstream context is the child of the HTTP context. Now, how we can work with the upstream, right? To work with the upstream, we need to define one more child of the HTTP and sibling of the upstream, which is called servers. We need to open and close the server, and inside the server, we need to define the location. Suppose I'm defining the base location, I will open and close this as well. And inside the location, I need to define the directive called proxy pass. So proxy pass directive we have already discussed in the previous lecture, which will help us to redirect the traffic. And as a value of the proxy pass, you need to define the protocol like HTTP, because in my case, I'm listening the traffic on the HTTP, and my upstream name. This is my upstream name. So this is my upstream. I will copy it and paste it here. Close this. So this is going to be the configuration file of your NGINX as a load balancer, right? By this particular configuration, I'm defining upstream. If you want, you can define the multiple upstream as well, right? And inside my upstream, I'm defining my application servers, right? Then I'm defining the server block, and inside the server, I'm defining the location, and inside the location, I'm defining the proxy pass and defining the upstream as a proxy pass. Let's save this. Verify your NGINX service as nginx-t. You can see the syntax is okay. And now you need to restart your nginx. So I will execute sudo service restart nginx. Hit enter. Oh, actually the order should be like this: sudo service nginx restart. Hit enter, and nginx service restarted. Now let's identify the IP address of this machine, and this is the IP address of my load balancer. I will copy this IP address. Now to avoid the browser cache issue, what we will do, we will execute a curl http and define the IP of my load balancer. Hit enter, and you can see I am getting the content of my nginx. Let's hit the same again, and this time you can see I'm getting the different content, and this content is basically belong to my brownie site. See, this is the content of my brownie site. So every time I will hit the curl again and again. This time I'm getting the nginx, and this time I will again get the brownie. This time I will again get the nginx. This time I will again get the brownie. Every time you will hit this particular request, load balancer will redirect the request in the round robin fashion. Why the nginx as a load balancer is still redirecting as a round robin fashion? Because we have configured the simplest load balancer with the nginx, right? We have not configured the nginx load balancer as a advanced, right? In the coming lecture, we will see how we can configure the load balancer as a advanced load balancer. If you want to see, you are getting the logs over here as well. See, here is the curl log from the IP 226, which is the IP of my load balancer, right? If I will refresh this, and I will refresh this as well, right? I will hit the curl command again from my to my load balancer IP. I'm getting the nginx page. The, the log should be present over here, and log is here, right? See, the curl 7.58 from the 226 machine, right? I will hit the curl again. This time I'm getting the brownie. So this time log will generate on the application page. See, over here I'm getting the log from curl 7.58 and the same IP. This is the IP of my load balancer, right? So this is the way how we can configure the load balancer with the help of the nginx, right? So team, if you have any doubt, any question, please let me know. Thank you team. Thanks for your time. Hello team, welcome back. Welcome to Nginx training, and today we will see the default health checks in the Nginx load balancer. So we will discuss about the health checks, and we will see what are the applications of the health check in the Nginx as a load balancer. So let's start with. So health check is something which is a scheduled rule used to send the same request on each member. It means when we are doing the health check will send the same request to the each member of the upstream. Health check sends a request to each member of the load balancer group to establish the availability of each member server to accept the client request. For the same type of the health check, the response from the server is calculated to determine the health status of each member server. The successful completion of the health check needs that server pass normal TCP HTTP connection. It means all the servers, all the application server we have defined inside the upstream, using the health check, NGINX will send the same request to all of the members, right? And then NGINX will calculate the response, what NGINX response will get from these members. If that response is fuzzy, that response is not valid, then NGINX will mark that particular server as a failure or unresponsive. But if the response is successful, if the response is expected, then NGINX will mark that server as a healthy server and send the client request to that particular server. So by this we can understand that health check is the mechanism for the NGINX load balancer by which NGINX can make sure that which server is healthy and ready to serve the traffic and which server is offline inside the upstreams. As we mentioned that health check have the TCP and HTTP connection criteria. So in the TCP mode, health check is performed with the TCP connection request. And in the HTTP mode, which is the standard health check type, health check is performed with the HTTP get and post method. In the NGINX load balancer, the health check generally is the HTTP type if you're not going to configure the specific TCP type. NGINX Plus or the NGINX open source which we are using can continuously test the upstream server to avoid the server that have failed, right? And gracefully added the recovered server into the load balancer group. It means using the health check, NGINX is monitoring the health of the server, right? And if due to any reason the server got crashed, the health check will be failed. In that case, NGINX will not send the traffic to that particular server until that server will be recovered and NGINX mark that server as a part of the server group. So by this mechanism, there is no manual intervention required. NGINX will auto exit the unresponsive server from the server group, and once the server will be recovered by the system administrator or some other approach, NGINX will automatically add that particular server in the server group. There are two kinds of health check in the NGINX. One is called the passive health check and another is called the active health check. Passive health check is available with the open source NGINX, but active health check is limited to the NGINX Plus only. So if you are going to configure the active health check, you must need to go with the NGINX Plus or NGINX commercial version. But passive health check is available with the NGINX open source. So in our lab, we have configured two application servers, right? And we have configured one NGINX load balancer. My first application server was basically executing the Brownie site, and my second application server was executing the NGINX a simple web page, right? Over here, we have the NGINX load balancer, which we was using to send the traffic to both of these servers. Right now, what we are going to do, we will make the Brownie site offline and we will see how NGINX load balancer will behave. Will it send the request to the Brownie site and we will get the 404, or will it redirect all the requests to the HTML web page? So let's go to the terminal and let's see a lab on this. So over here we are on a terminal and here is my Ubuntu machine which is custom NGINX where my Brownie site is running. Here is the another machine, Ubuntu secondary application server where the simple NGINX is running. And here is the third machine, Ubuntu load balancer where my load balancer is running. What we will do, first we will check the NGINX is up on all of the machines or not. So first we will execute ps-ef grep NGINX, hit enter. NGINX is running on this machine. We will check the same command on other two boxes as well. And here the NGINX is already running and NGINX is running here as well. Now if you want to hit the curl command, you can do that particular thing as well. So let's hit curl http, then the IP of my load balancer. This is the IP of my load balancer, right? You can see this is the IP of this machine and this is my load balancer. Once I will hit this, first it may respond to the Brownie site or it may respond to the default NGINX. So first request is served by the default NGINX. If I will hit it again, this request will be served by the Brownie. See, we are getting the content of the Brownie site. If I will again hit the curl, this time it will serve from the NGINX. If I will again hit, it will serve by the Brownie. So what we will do, we will clear out the console, right? and we will stop the NGINX on the Brownie. So we will execute service NGINX stop, check process, NGINX is stopped, hit the command again, curl served by the nginx, again curl served by the nginx, again curl served by the nginx. So you can see over here I have hit three curl command. First is here, right, and this is basically served by the nginx server, and the second is here, this is again served by the nginx server. The third is here, and this is again served by the nginx server. So if you will open the configuration file of your load balancer, right, let me allow to open it via etc nginx conf. Then till now we have not configured any kind of health check. So how nginx is managing the server failure or server irresponsiveness? Basically, if you have not defined any kind of health check, nginx will manage that on, right? Nginx will manage the health check of the server by on. You don't need to configure any kind of health check inside the configuration file of your nginx load balancer. But if you want to go with the active health check, right, and if you want to go with the advanced parameter of the passive health check, then definitely you need to modify this particular configuration file of your load balancer, right? We will discuss about these modifications in the coming lecture, but right now I just want to explain that if you are not defining any kind of health check in the nginx, then nginx will auto determine that the server is unresponsive and it will not send the request on that particular server. The statement that nginx will not send the request to the unresponsive server is mentioned over the internet on the many website, but in actual, nginx will send the request on that particular server as well. In the coming lab or in the coming lecture, I will show you how that particular thing internally work in the nginx. Right, now let's exit out this file and make the process up. So I will execute start, right, service nginx start, check the nginx process, it's running. Let's hit the curl again. See nginx, and this time the third command is going to the Brownie side. So first two command was going to the nginx by default. First curl is here, that again go to the nginx default nginx. The second curl is here, that again go to the default nginx, but the third command go to the Brownie. It means once we will up the nginx server, over here we have up the nginx server, but nginx load balancer took some time to identify that the server is up and running, and it will started sending the request to that particular server. So team, this is the way how health check works in the nginx load balancing. Right now we have not done any kind of configuration changes in the application server or at the load balancer side, but we need to remember that always whenever we are going to define the health check inside the load balancer, we will do the changes at the load balancer side itself, right? No changes will be required in the application server, only change will be required at the load balancer side. So in the coming lecture I will show you how nginx health check internally works, right, and what kind of configuration we can do with the passive health check. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to nginx training, and today we will see the passive health check with the nginx load balancer. So in the earlier lab we have seen how nginx health check will work with the default configuration, but today we will see if we will modify the passive health check configuration, then how it will work and what are the parameters we can modify with the passive health check. So let's start with. So in the passive health check monitoring, the Nginx or the Nginx Plus will basically monitor the transaction as they happen, right? And try to resume the failed connections. If the connection is failing, then Nginx and Nginx Plus will try to resume that particular connection. And if the transaction still cannot be resumed, if the connection is still cannot be resumed, in that case, the Nginx will mark that particular application server as a unavailable or unhealthy, right? And stop sending the request on that particular server. Once the server will be recovered, it will mark it again healthy and include in the server pool of the defined upstream server configuration. So this is the way how passive health check work for the Nginx. So let's understand the passive health check with this particular diagram. So we are executing the two servers, right? And we are executing one Nginx load balancer. My first server is basically running the Brownie site, and my second is running the Nginx default HTML page. Now let's suppose my Brownie site will go down. Then how Nginx will behave in that particular case? So in the earlier lecture, we have a statement that Nginx will not send the request to the unhealthy server, and the healthy server will serve all the requests. And we have seen as well that only the second app server was responding. Brownie side was not responding once we have stopped the Nginx on the Brownie side. But in background, that thing is not true. So now we have a case that inside the upstream, we have the two application server, right? Application server 1, which is the Brownie site, and application server 2, which is the default HTML page, right? And the Brownie site is down. Now user is sending the request, and suppose user is sending the request A, B, C, D, F, and so on. Now, once the first request will come, it may possible that may land to the application server 2 or the application server 1. Whatever the priority, whatever the first server in your upstream, that request will go to that particular server. In my case, the Brownie site is the first server in my upstream. So request A will go to the Brownie site, but Brownie site is down. So Nginx will not get the valid response, right? So this request will be failed. In that case, Nginx will send the same request to the server 2, right? It doesn't mean that the request got failed, then Nginx will pick up the next request and the first request will be dropped. No, Nginx will send that particular request to the second server, and once the request will be successful, Nginx will pick the another request, and again Nginx will send that particular request to the Brownie site. So Brownie site is down, it will failed again. So again Nginx will send the same request to the another server, and if it passed, then send back the response to the user. After the two request or after the defined request, Nginx will mark that particular server as a offline and will not send any further request to this particular site. So this is the thing, this is the mechanism which will happen in the background, right? And once Nginx will mark that particular server as a down, Nginx will send all the requests to the second application server, because we just have the two application server in the upstream. So this is the way how Nginx will work in the passive health check in the background. It will send the request will fail, it will send the same request to the another server, right? It will send the another request will fail, it will send the another request to the same server. Now suppose if we want to modify this behavior, suppose we don't want to send the two requests, or we want to send more request or less request, then how we can achieve it? In that case, we have few parameters which we need to configure with the server in the upstream. The first one is the fail timeout. The fail timeout sets the time during which the number of failed attempt must happen for the server to be marked unavailable, and the time for which the server is marked unavailable. It means if we have defined the fail timeout 30 second or 60 second, then Nginx will send the request to that particular server for the 30 second or the 60 second. It doesn't matter, that requests are basically success or failed. For the defined fail timeout, Nginx will continuously send the request to the unhealthy server as well before making that server unavailable or unhealthy. And once the server will recovered, Nginx will count the same time to make the server available. It means if we are defining the fail timeout 30 second and server is unavailable, then before marking the server unavailable, Nginx will send all the requests to that particular server for the time period of the 30 second, right? And then mark the server unavailable or unhealthy. And suppose the Nginx server will come up and it is successfully processing the request, then Nginx will not mark the server healthy immediately. It will again wait for the 30 second, which is the fail timeout, and after the 30 second it will make the server healthy, right? So you can understand, by default this time is 10 second, so that in the last lecture whenever we make the Nginx server up on the Brownie site, but request was not going to the Brownie site, right? So Nginx took 10 seconds to make that server available. And the second parameter in the passive health check is the max fails. Max fails is another parameter where we need to define the number of the max fails, which will set the number of the failed attempt that must occur during the fail timeout period to the server to be marked unavailable. The default attempt is 1. It means if we are defining the max fails 5, right, and we are defining the fail timeout 30 second, then Nginx will basically mark the server unhealthy if during the 30 second 5 requests got failed. Do you understand my point? If during the 30 second during the failed timeout period max fails request will be failed, then Nginx mark the server unavailable, and same thing will with the server available. The default attempt is 1. right? And default fail timeout is 10 seconds if you're not defining that particular thing. There is one more point. In the earlier lab we have not defined the max fails and the fail timeout, and we have the two servers. Now suppose we have only one server. We have only one server in the upstream. In that case, if we are ignoring the fail timeout and the max fail parameter, then NGINX load balancer will never mark server as a unavailable. So these are the two parameters which you can configure with the passive health check. So let's go to the terminal, and inside the load balancer terminal, let's open the configuration file. Over here inside the upstream, you need to define these parameters. So suppose we are defining these parameters, I will go to the edit mode, and with the brownie side which have the IP 130, I am defining the max fails, and suppose I am defining the max fails like 5. Then I am defining the second parameter which is the fail timeout, which is 30s. 30s means 30 second. If you want to configure it 60 second, you need to define 60s. If you want to configure it for the 5 minute, you can define 5m. So these are the two parameters which I am defining with my upstream, max fails and the fail timeout. Let's save this. Verify the configuration, nginx-t. Configuration is okay. We will restart the service. So I'm defining the restart of my service. Right now, if you will check that nginx is running on both of my machines, right? So if I will hit the curl, so you can see we are getting the response from both of my server. The first curl got the response from the brownie, and second curl is getting the response from the application server 2. And I will stop the nginx on this particular machine on the brownie. So I will stop, check the process again. Process is stopped. Now I will go over here and hit the curl. See, application 2 is responding. Again application 2 is responding. Again application 2 is responding. Again application 2 is responding. It means brownie site is already made unhealthy. Now what we will do, we will start the nginx, check the process. Nginx is running. Go to the load balancer, clear out the console, hit the curl after the 30 second. We are getting the response from second server, and we are getting the response from the brownie site as well. So max fails and fail timeout are two parameters which you can configure with the passive health check. If you have any doubt, any question, please let me know. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Nginx training. In last lectures, we have discussed about the passive health check in Nginx, and we have already seen how passive health check works in Nginx load balancer. Today we will discuss about the applications of the active health check in the Nginx, and we will see the configuration file of the active health check in the Nginx load balancer. So let's start with. So as I already told you, Nginx have the two flavor of the health check. One is the passive health check and another one is the active health check. The passive health check is limited to the open source Nginx, and active health check is available in the Nginx Plus or Nginx commercial version. It means you cannot apply the active health check directives with the open source Nginx in your configuration file. So what is active health check? So in the active health check, Nginx Plus can periodically check the health of upstream server by sending the special health check request to each server and verify the correct response. In the passive health check, Nginx was not sending any special health check request to the servers. Once user will hit the request, that request was being redirected from the ILB to the node, and if node is not getting the response, then it will redirect to the next node, right? But in the active health check, Nginx load balancer is already monitoring the health of the upstream server. It doesn't matter the user is sending the traffic or user is not sending the traffic, right? And that health check is being maintained by the health check request. And I'm repeating again, this functionality is not available with the open source Nginx, right? If you want to adhere the active health check of the Nginx, you need to go with the commercial Nginx Plus version. Health check is the directive which will be used to send active health check request to the upstream servers. So over here I have mentioned the snippet of a configuration. Here we are inside the server context. Inside the server context we have the location context, and we are accessing the location on the root. Suppose we have declared the upstream which is called backend. So first we are going to declare the proxy pass, and after the proxy pass you can see we have the another directory which is called health underscore check. Over here, whenever you are defining this kind of directive, then this defines the server process all the request on the location root, because we are defining the location root to the upstream group called backend. It also enables the advanced health check monitoring with the health underscore check directive. By default, every 5 seconds nginx plus send the request at the root, it means slash path, to every server which are the part of the backend upstream group. And if any communication error or the timeout error occurs from any server, right, it means if we get the response status code outside of the 200 and 399, then health check will be failed and server is marked as unhealthy, and nginx plus doesn't send the client request to that particular server until that server will be live again, or until that server will be healthy again. So by this particular directive health underscore check, nginx is automatically sending the health check request at the root location, because we have defined at the root location, and that request frequency will be the 5 second. Whenever the request will fail, nginx will mark the request, nginx will mark the server as unhealthy, and it will not send the client request on the unhealthy server. This is called the active health check, because nginx is actively monitoring the health of the upstream servers. If you want to send the health check request at a specific port, then you can define the configuration like this. You can define the health check, then you can define the port, on which particular port you want to send the request. So by this particular way, each server which is the part of the backend upstream will get the health check request at port 8080. Then with the active health check directive, we have the few parameters like interval, fails, and pass health check, which can be defined like this. After the health check, you can define the interval, you can define the time interval after this, you can define the fails count, and you can define the passes count. So what these parameters mean to the health check directive? Here the interval parameter increase the delay between the health check request from 5 second to the 10 second. If you are defining the interval 10 second, then in each 10 second that health check request will go to the servers. If you will define it 30 second, then nginx load balancer will send the request in each 30 second, but by default that is 5 second, right? The fails parameter requires the server to fail 3 health check to mark it unhealthy. It means if we are defining the fails parameter, then server will be marked unhealthy after the 3 consecutive failure of the health check, right? By default that is 1. And then we have the passes. It means passes parameter means to server must pass 2 consecutive health check to mark the healthy again. So over here we are marking the server unhealthy after the 3 consecutive failure, and in the same way we are making the server healthy after the 2 consecutive success. So these are few parameters: port, interval, fails, and passes, which you can define with the health check. If you want, you can define the request URI as well. It means if I'm not going to send the health check at the root location, I can define the specific URI on which URI I can send the health check. That specified URI is appended to the server domain name or the IP address of the server of the upstream block. For the first server, the sample backend group declared above, and the server health check request will be go like www.example.com/some path, right? If you have some domain, then it will go in that particular way. If you are defining the IP address in the server, then it will go like 10.10.8.8/some/path. So over here, by this particular way, you are hitting the health check at a specific URI. It means you are defining the health check APIs within your application, right? You can also mention the port, and you can also mention the interval, you can also mention the fails, and you can also mention the pass after the health check as a parameter as well. So these are the part of the health check directive in the active health check. Now we have some more liberty, and we can define the custom conditions as well. So user can set the custom condition that the response must specify for the server to pass the health check. It means whenever we are defining the health check, right, and if you want to verify the response, then on the response you can define the custom condition. These custom condition will be defined outside the server block, and these will be defined inside the http context. The custom conditions can be defined by another context which is called match. So over here you can see we have the http context, and inside the http context we have the match context. We are defining some name like server underscore okay. You can keep it anything, there is no limitation. Then we are defining status code, and we are assuming that the status code will be in between of the 200 and 399. If we have the status code out of this range, then we will mark the health check unhealthy. And also we are checking the body. That body should not have any context or any text like maintenance mode. So you can see with this particular custom condition, we are putting the condition on the status code, plus we are also putting the condition on the body of my HTTP request. Then inside the location block, after the health check, we are defining match equals to server OK. It means we are defining the exact match for my health check for the match which we have defined outside the server context and within the HTTP context. The match directive enable NGINX Plus to check the status code, header field, body of the response. Using the directive, it is possible to verify the whether the status of the specified range, whether the response includes the header or specific body match the regular expression. The mesh directive can contain one status condition, one body condition, and multiple header condition. A response must satisfy all the conditions defined inside the match block for the server to pass the health check. So these are the limitations with the match body. Then you can define multiple headers, but you can define only one status and one body condition. And if any condition within the match block will fail, then health check will be marked as a failed. So team, we don't have any NGINX Plus subscription because that is a commercial product. Although I have the NGINX Plus available, but I cannot create a lab on it because that will require a lot of setup. And if you want to follow that particular lab, then you will need the public private key certificate issue from the NGINX commercial F5 community, right? So I'm not going to create the lab on the NGINX Plus, but I can show you the configuration file, the sample configuration file for the NGINX Plus, so that we can combine all the concept which we have discussed today. So here in my code editor, you can see I have a file name activehealth.conf. So this is the configuration file which I have created for the Nginx Plus. Over here you can see first I'm defining the user, which is the Nginx, then I'm defining the worker process, which is auto. I'm defining the error log location, right, which is the log where error.log. Then I'm defining the events. Inside the event I have the worker connection 1024. Then you can see we have the HTTP context. Inside the HTTP context, first I'm including the MIME type. After then I'm including the octane streams. Then I have defined the specified log format like remote addr, remote user, local timestamp, request status, body status sent, right? And there are few more directive like that http referrer, http user agent, http x forward for upstream connection time, upstream header time, upstream response time, and request URI itself. I am defining this log format as a main, and inside the access log, I am putting this particular log format. So all the logs in the access log will follow this particular log format. This is a very rich log format. If you want to copy it, you can copy it as well. If you want to use it, you can use this particular log format. This is a very rich format, and you can use that particular log format to get the rich logs. Then after this, we are defining the two upstreams. The first upstream is the cluster underscore fnt. Over here I'm defining the zone cluster fnt, which is 64k, so it will keep the zone size up to 64 kilobyte, right? Then you can see I'm not defining the server inside my upstream. This is something new which we are going first. Over here you can see I'm defining the state directive, and after the state directive I'm defining few state file location. See, I'm keeping a state file at a location where lib nginx state cluster underscore fnt dot state. So this is the name of my state file. The same name is defined for the upstream, right? The same name is for the zone. So what does it mean? What this particular state file means? So if you want, you can define the servers over here, or what you can do, you can define the state file and you can define the state directive to link that particular state file. This state file will also contain the same data which we have seen earlier, right? So this state file will contain the servers, right? After this you can define the fail timeout, and you can define the max fails, right? But state file will contain the servers, right? The server, then the IP name or the domain name, then max, then fail timeout, then max fails. You can define the n number of servers in the state file, but this is the professional way to keep the upstreams, right? We will define the server inside the state and we will assign the state files inside the upstream. In the similar way, I'm defining the another upstream which is called cluster underscore back. It has the same parameters, and over here we have the another state file for the cluster dot back. After this, I'm defining the server. Inside the server, first I'm defining the listen port. Then inside the root location, you can see I'm defined the proxy set header, host and host. Then I'm defining the proxy pass, and inside the proxy pass, I'm calling my upstream. This is my upstream one. Over here, you can see I'm not calling the health check, right? I will show you where we are calling the health check. Then I've defined the another location. This time I have the location for the special .php files. And if we have the PHP file, then that request will directly go to the cluster underscore backup stream. So the server which are mentioned in this particular state file, the request will go to that particular server. Then over here we are defining the health check. See, we are defining the @fnt, we are defining the special health check @fnt, we are defining the proxy site header host, then defining the proxy pass, and after that we are defining the health check. And in the health check, we are defining the health check on a specific URI. You want to keep that URI over here on which you want to put the health check. The second health check I'm defining for the backend upstream. You can see over here I have the cluster underscore backend upstream, and in the similar way we are defining the health check. Then we are defining the error page. If we have the 500, 502, 503, 504 status code, then directly render the user on the custom 50x HTML page. Then we are defining the location of the custom 50x HTML page as the etc nginx. So this is the professional nginx.configuration file which you can use with the nginx plus. So thank you team, that's all for the day. See you in the next lecture. Hello team, welcome back. Welcome to nginx training, and this is a new section about the caching subsystem in nginx. In this section, we will learn in details about the caching, and we will see how we can use the Nginx as a caching system. Before going with the Nginx caching system, first we will try to understand the HTTP caching. So we will see how HTTP will manage the caching and what is the caching. So let's start with. So team, whenever we are working on any website, there are few things which comes in a picture. First is the user, and second is the web application server. And once user will try to access some resource, so user will send a request to the web server, and whenever web server will get the response, it will send the response back to the user. In the request, you may ask for the dynamic content or you may ask for the static content. Dynamic content is the content which is basically dynamically calculating at the web server side, and then it is being transferred to the user. If you take an example of the Facebook, then in the Facebook, the number of likes, number of comment, the data of the comment, that is the dynamic content, because the number of like and the number of comment, the data of comment is being calculated by the web server, then it is showing on the user's browser. Then what is the static content? The static content is the image, the profile image of yours, the profile image of your friends, the profile image of your contacts. That is the static data, because we often change the profile image of our Facebook account. So whenever you are loading the Facebook, that page have the static data plus dynamic data. The logo of the Facebook, the fixed content of the Facebook, few HTML page, the background of the Facebook, that all the static data, right? So caching system is something which will manage the static data. So suppose whenever we are hitting the request, we are accessing a data myfile.jpg, and in a response, server will send a response to the client. This JPG file is a static file because server is not calculating that file. Server is not doing any edit or any modification in this file. That file is present on the server. Whenever user is requesting, server is just simply sending that particular file over the network. So using the caching system, we can cache that static data. Now you may ask the question why we need to cache that particular static file. So suppose you are a user and you are refreshing your browser again and again, and you hit the 10 time refresh on your browser, right? If you don't have any caching system, then your browser will send the 10 request on the web server, and all 10 times web server will send the same file to your browser. That is okay, that is not the big problem. Server can handle the 10 request. But think about the big websites. If you have a very heavy traffic websites like Paytm, Facebook, Amazon, Flipkart, then there could be the number of image which basically is being loaded on the single page. And every time you are refreshing your browser, server will get the request for all these static image, right? And will respond back all these static image. And the another possibility is that million of the user log in or use these websites in a day. So in that particular way, server is going to handle each and every request. So server will get a lot of request which is not required, right? Because most of the users are basically accessing the static data. So server don't need to serve these particular request, but server is still serving this particular request because caching system is not present. This will increase the load on the server. Second thing, every time you are hitting the request, you are getting the response from the server, and server is sending the files over the network. it will increase the bandwidth cost. So first drawback of this particular mechanism is the server resource utilization. Second one is the network bandwidth utilization, and third one is the time, right? It means whenever you are hitting the request, server is calculating the request and again sending the response to the browser. So every time whenever you will refresh your browser, you will get a lot of time. If you want to see it, let me show you what I'm trying to explain. So I will open a browser. Suppose here I'm on the Firefox and I'm going to open the yahoo.com. So I will hit the yahoo.com. Let's see how long it will take. So over here you can see it is in progress. The web page is still loading and the web page load is completely done. So over here on this particular web page, you can see you have a lot of images, right? There's a lot of images which is being transmitted over the network. Once I will refresh this web page, see, I'm refreshing it. It is still loading the web page and web page load is done. I will again refresh it and web page refresh is done. Over here you can see many of the image on this particular web page are static. Every time when I will refresh this website, I will get the same image. See, all these images which I'm getting on the front, these are the same images. So server really don't need to send these image again and again whenever user is hitting the request again and again, right? So these are the static content which is not being refreshed every time whenever user is hitting the request, and that data can be cached in the browser or in the caching system so that we can minimize the load on the server. Also we can provide the better user experience to the end user. So how we can solve this particular problem? So suppose we are solving this particular problem. Here is the user and here is the web server. User is sending the request to the web server. That request is basically accessing some static file. So request will be land on the web server for the static file, but in between we will put another server, right? We will within the user and within the web application server, we will put another server. That server will be called as a caching server. So user will send the request to the caching server will accept that particular request, and if this is the first request of that particular static type of data, it means the data which user is asking is not present at the caching system, then caching system will forward that particular request to the web server. If that file is present at the caching system, then caching system will not forward the request to the web server. I will explain it shortly. Right now you can understand that user is sending the request to the caching server and caching server is sending the same request to the web server. In the response as well, web server will send the file to the caching server, and then caching server will basically store that particular file in the local database or local file system. So over here we can see the flow is basically changed. Right now the response is not directly going from the web server to the client. No, request is also not going from the client to the web server. Response and request both from the client side and the server side is basically going to the middleware, that is the caching server, right? And whenever caching server is getting the static data, caching server will store that particular data in the local database or the local file system, and then again forward that particular data to the user. So what is the benefit of this mechanism? The benefit is whenever next time some other user or the same user will request for the same static data, caching server will not send the request at the web server. It means if same user or the other user are accessing the same static data, requesting the same static data, then caching server will read that particular data from the local file system or the local database and return that particular data as a response to the client. Caching server will not forward that particular request to the web server. By this mean, web server will not get all the request, right? Caching server is the middleware which is storing the data, which is a static data, and serving all the request for the client. You can also assume, and the benefit of this model, if you have a very heavy machine and a centralized backend application which is running in a server farm somewhere in the US, right? But you have the end user from the Europe, you have the end user from the Asia, you have the end user from the China, you have the end user from the Japan. It means you have the end user from the different geography, but your web application server, your backend server is centralized, which is present somewhere in the US. So due to the long connectivity, that request may face the latency. So how we can solve that particular problem? If we have a central backend application, right, we have a central backend server, then what we can do, we can put the caching server in each region where we have the most of the users. It means we can put a caching server at the Japan, we can put another caching server in England, we can put another caching server in European countries, we can put another caching server for the China, and all these caching server will communicate to the single backend and front end application which is present in the US. So whenever the European, the Japanese, the Chinese user are basically sending the request, so all the static data for these requests will be served by the caching server. Caching server will not send the request of the European user to the US web application server, right? The same request will be served from the European caching server. So we have that particular benefit as well with the caching server. So along with the caching server, we also have another caching management, and that caching management is present at the user side, and that tool is called your browser. Your browser also have the caching system. If you want, I can show you. So let me allow to open the Firefox, and in the Firefox, let's type about cache. Hit enter, and you can see here you are getting the information about the network cache storage service. We are getting the memory maximum storage size, and we are getting the disk, right? This is the disk what I'm talking about. Let's open the list of cache entries. Here you will get a lot of entries which is basically cached at the browser side. There's a number of entries which is basically cached at the browser side, and over here we can see we have a 16,370 number of caching entries. The total size of this much is KB, and this is the location of your cache. Here you can see we are getting the key of the cache, then we are getting the data size of that particular cache entry, we are getting the fetch count. Fetch count means how many times that particular cache is being fetched by your browser, the last modified date of that particular cache, and the expire date of that particular cache. That particular expire date and modified date and the size and the entry will be independent for each cache. It means here this is the key, this should be the unique, you can't have the duplicate key inside the cache, but that data can be duplicate. You can see if I will upload some another website like rediff.com, hit enter, Rediff is basically downloading. If I will go to the cache and I will refresh this, you can see the cache entries basically changed, and right now we have 16,997 cache entries. It means cache entries are basically increased while we are accessing the Rediff. You can see this is the longest cache entry, which is the JS file. This basically fetched at a one time. This is the expire time of this particular, and this is the last modified. If I will refresh it again, I will refresh the cache as well, the cache count again increased. So by this particular way, every time whenever we are hitting the request, we are getting the cache entries at the browser side. Some of the cache are like this that expired immediately. So your browser is also a cache management tool in your machine, right? The second cache management tool is the middleware server. So this is about the HTTP cache system, right? In the coming lectures, we will discuss in details about the NGINX cache and how we can set up the better caching management system using the NGINX. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to NGINX training. And today we will see the HTTP cache control headers. In last lecture we have discussed about the caching and we have seen how the caching can be managed. Today we will see what are the headers do we have in the HTTP protocol to manage the caching at the client side or at the server side. So let's start with. So in earlier lab we have discussed that we have the user, we have the backend application. Once we will send the request, that request will directly go to the caching server. Caching server forward that particular request to the web server. Web server will forward the response to the caching server, and if we have some static data, then caching server will take that data in the local copy. So this is the flow which we have discussed about the caching, right? So once the user will send the request for the same static file, either that can be the HTML file or the PNG file, JPG file, Excel file, PDF file, there could be any number of file which is a static. So caching server will directly respond user the caching file which is maintained in the local file system. But here we have a problem. What is the problem with this particular caching model? So the problem is, if that particular static file which is being transmitted to the user as a response from the caching server, if that file is basically updated at the backend application, the file which user is asking, that is a static file, that file data is copied at the caching server. So caching server will not send the request to the application server and directly respond that particular file from the local file system. But what happen if that particular file is updated at the application server side? In that particular case, user will get the stale files. User is not getting the updated static file, user is getting the stale files. So how we can resolve that particular issue? How we can make sure that the file which is present in the caching server, that may have some expiry period, or caching server will check if the state of the file is basically changed on the backend server. So how we can do that particular thing? Also with the caching, we have one more concern. Suppose you are working on an application, or you have an application which is showing the data about the stock markets or the banking sector. So in the banking sector applications or in the stock market application, you cannot cache the data at the server side as well as the user side. Because if you are caching the data at the user side or the server side, and you are showing the live stock market stats to your users, then it may possible that your user is not getting the live stats, right? The user is getting the data from the local cache, but in real the stock price is changed. In that case, your user may lose the money. Same with the banking application. With the banking application, you cannot cache the data at the user side or at the server side. If you have ever seen that in the banking application, whenever you will open the internet banking, you cannot go to the previous window by a browser back button, right? Same, you cannot store the password of your banking system in the browser, right? So whenever we are going with the financial applications like the stock market application, the banking application, we need to make sure that the data is not being stored at the browser side. So what we need to do for that particular thing? So whenever application server is sending the response to the web browser, application server must need to inform web browser that that particular data should not be cached. So how we can achieve these particular things? These things can be achieved with the help of the caching header. So we are going to discuss about the caching header. So we have the multiple cache control headers. So cache control header is the HTTP header used to specify the browser caching policies in both the client request and the server response. So whenever we are talking about the caching header, these are the headers of the HTTP protocol. With the help of these header, basically we are defining the policy of the caching either at the server side or at the browser side. The caching header policies include how a resource is cached, where it cached, and maximum age of the before expiry. So same thing we have seen in the earlier lecture whenever we have opened the caching locations of the Firefox, that there were some fields that the expiry date of the caching and the creation date of the caching. Now there are few headers which are present in the caching header. The first is the cache control max age. Cache control max age is the directive in the NGINX configuration file. This directive defines in seconds the amount of time it takes for the cache copy of the resource to expire. It means whenever you are defining the cache control, you need to define the time with that particular cache control, and that time should be in the time unit seconds. After your defined particular time, cache will be auto expire, and after the expiry of the cache, browser must refresh its version of the resource by sending the another request to the server. So this is solving our first problem. The problem we discussed, that if the file is basically stale at the caching side, then how caching server will get the new version file? So whenever we are defining the response header, in the response header we will define the cache control max age. We can define the max age with the file, the static files which we are expecting to be updated over a period of the time. If the file is completely static, that is not going to change, then definitely you don't need to define the cache control. So for example, if we define the cache control max age equals to 120, it means the return resource is valid for the 120 seconds only, after which the browser has to request the newer version of that particular resource, for which resource that particular cache control header is defined. The second cache control header is the cache control no cache. The no cache directive means that a browser may cache a response but first submit a validation request to the origin server. No cache doesn't mean that browser cannot cache that particular content. No cache means that browser can cache that particular data for which in response we are getting cache control no cache directive, but browser must need to validate that particular cache request from the origin server first. If origin server will approve that particular request, then only in that particular case this directive attached data can be cached at the browser side. Otherwise that data cannot be cached at the browser side. The next directive is the cache control no store. That is the directive which can be used for the financial application and the stock market applications. Right? The no store directive means browser are not allowed to cache a response that must pull it from the server each time it's requested. So whenever you will refresh your mobile application, your web page, or you will go to the new menu, always the new request will be generated and server will fulfill that particular request. None of the data can be cached at the browser side or at the server side. This setting is usually used for the sensitive data such as the personal banking details and the financial applications. In the same way, we have the another cache control which is called cache control public. Cache control public is a directive which indicates that the resource can be cached by any cache. Either the middleware server or the server itself or the browser can cache that particular resource. Multiple users can cache that particular resource. There is no hard and fast rule to cache that particular resource. In the same way, we have the another directive cache control private. Cache control private response directive indicate that a resource is user specific. It can still be cached but only by a client device, right? It means middleware server will not cache that particular response. Middleware network layer cannot cache that particular response. Only the specific client, only the user specific client can cache that particular record which server is sending. So these are the caching headers. In the coming lecture I will show you how we can add and use few of the caching headers and how we can practically see that the resource is basically cached or not after adding these particular headers. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to NGINX training. And in the last lab, we have discussed about the cache control headers. Today we are going to execute a lab on the cache control headers and we will see how cache control header will impact the caching at the browser side or at the server side. So let's start with. So here we are on our terminal and we are on the machine Ubuntu custom NGINX. On this machine, we will check if the NGINX is running. So we'll execute a command ps-ef grep nginx and nginx is running. Let's identify the IP of this machine and this is the IP of my machine. I will copy the IP, go to the browser and I will hit this IP. So you can see I am getting my brownie site on this particular IP. It means the nginx is running and currently it is showing me the brownie site. Let's verify on this particular brownie site we have a lot of static data. This image is a static data. This image is also a static data. These icons may be the static data. These icons are the static data. These icons are the static data. The portfolio images are the static data and these icons are also the static data. So on this particular page we have a lot of static data. So let's do one thing. First let's close this, open your browser and let's delete the cache of your browser. Press Ctrl Shift Delete. If you are using the Mac operating system, you need to press CMD Shift Delete and over here we are getting the time range. Let's select everything and from here we are not going to delete the browser history, we are not going to delete the cookies, we are not going to delete the active logins and the search history. What we are about to delete, we are just about to delete the cache. Let's click on OK. Go to your browser and type about cache. Hit enter. Let's refresh this and you can see over here the disk cache is zero entry, right? The Apache cache is also a zero entry and we are not getting the link to open the disk cache. Now let's do one thing over here, open your website. So we are going to open our brownie website. Let's wait until the website will be completely load. You can see the website is loaded. We will go to the cache and refresh the cache page. Now we are
Now over here we can see we are getting the 46 entries in the cache. Let me allow to list out the cache entries. So you can see we are getting the favicon icon png. These WOP files are also the cache files. Here is the welcome banner.jpg. So let's open this png file. What is this png file? So you can see this icon is the png file, right? If we will go back and we will open another files, so we know very well that this is the welcome banner, this is the p1 jpg, this is the custom js, and let me find out some more images over here. So we can see we have the c67 png files, right? So you can see these icons are also png. As I told you that these icons are the png file, the static file. So we can see these are the static files. Let's go back. So on this particular page we have a lot of static data, and here we have the portfolio file, which is the jpg file, right? So we have some png files, we have some jpg files. Let's open this jpg file. So this file is the jpg file, and if I will go to the banner, then I believe the banner is the png file. Yes, the welcome banner is okay. The banner is also the jpg file. These are the png files, which are basically the small icon on my web page. So what I will do, I will go to the NGINX configuration of this particular server. So clear out the console and open the configuration file, cd etc nginx ls, and over here we have the nginx.conf. Let me allow to open this file, and this is the simplest nginx file we have. Over here we have the only one location block. What I will do, I will add one more location over here, so that location will only be applicable on the png files. So what I will do, I will go to the insert mode, or we can do one more thing, we can copy this data and we can edit this data in the local file system. So here we will add one more location header like location, provide the regular expression, and we will call it all the png extension files, right? So we will type like this, all the png extension files, open it, close the location block. Inside this, what I will do, I will add a header, add header, add underscore header, cache control, and I will define no store, because no store is the directive which will don't store the cache at the server or the client side. And before this, I will add like try files. I will simply copy this and paste it here. So I'm adding one more header, cache control no store. I will copy this and put it on my server. After this, I will save this file. I will check the nginx configuration with nginx-t. The configuration is okay. We will reload the nginx configuration. But before reload the nginx configuration, let's execute some command over here. So if we will go to the browser, so these were some cache, right? We have the favicon.png file, and we have the p2 and c3 png file. Let's copy this url and execute curl -i and this particular url. Hit enter. So you can see what header we are getting. We are getting server, date, content type, content length, last modified, connection, and e tag. We are not getting any information about the cache. If the same thing we will execute with the png file. So here is the png file c3.png. I will execute curl -i and paste the url. You can see the same header I am getting for the png file. Now let's do one thing. Let's clear out the console and reload the nginx. So nginx -s reload. It will reload the nginx. Now let's execute the curl command for the jpg file first. So jpg file header is still the same as before the reload. Now let's execute the curl for the png file, and you can see in the png file we are getting one more header, which is called cache control no store. It means we are in the correct direction and our location is working fine. So we have put a new location that all the png file which are available in my site will not be stored as a cache at the browser side. So what we will do, we will again go to the browser and we will put Control Shift Delete on the Windows and Command Shift Delete on the Mac operating system. We will clear out the cache, open the cache again, We can see we have the zero number of entries. Now let's refresh your website, the Brownie website in your browser. You can see the website is refreshed. Let's go to the cache again, refresh the cache, and this time you can see the number of entries are reduced. Earlier we was getting 46 number of entries in the cache, but right now we are just getting 28 entries in the cache. If you will open the cache entries, then here you will not found any png file as a cache. See, css, css, wof, jpg, jpg, jpg and jpg, right? We have the JS and JPG only. No PNG file are basically cached in my browser. Why? Because I have added cache control no store in the response of the PNG file. If you want to verify, you can go to the terminal, copy this JPG URL and find it here. You will find out this particular URL that this image is basically cached. If you will copy this and try to find this, you will not get this URL because no PNG file is basically cached as a cache in my browser. So by this particular way, we can avoid a file to be cached at the browser side. So I believe now we have understood and we are aware that how we can avoid the some specific data to be cached at a client side, at a browser side, or at a middleware server side, right? So this is the way how we can control the cache with the help of the cache control headers. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to NGINX training. So today we will discuss how we can verify the cache file is modified at the server or not. So we are going to discuss about the issue which we have discussed in the earlier lab, where the local or the middleware server have the cache of the static file, but it need to again check that the file is modified at the server end or not. So let's start with. So we was discussing this use case that we have the user and we have the web application server. User will send the request to get the static data, and that request is basically going with the caching server. So if the caching server have the local copy of that particular static data or the file, then caching server will not send the request to the backend server and directly respond that file to the user. But that arises a problem. What if that particular file is being modified at the backend application server side? In that particular case, user will get the stale file or the old file. So how we can make sure that always user will get the latest file from the backend application, not the stale file from the caching server? So this problem can be solved by another HTTP header which is called if modified since. And if modified since header is basically present inside the client request. That is not the server side directive, and that directive is not supposed to be configured in the NGINX configuration file. Every client which is sending the request must include that header inside the request. So once we have the if modified since header in the request will go to the caching server and caching server will check that particular file again with the backend application server. And along with the file, caching server will also send the last modified date of that particular file in a format which I mentioned over here. Last modified, as I'm recording the video on August 2020. So we mentioned Wednesday, August 2020, 15:26:28 GMT. So whenever user is sending the request to get some static data, that request is going to the caching server, and caching server will send the same request to the web application with another header called last modified, and it will also mention the last modified date of that particular application at the client side. If there is no change in the file, then server will directly respond 304. In that case, server will not send the file, server will just return the response code 304, and caching server will serve the local copy of that particular file to the user. But if there is a change in the file, that file is basically updated after the date which is coming inside the request, then server will send the 200 request along with the file. So in this particular way, response code 200 will be served by the server to the caching server, and a copy of the file, the updated file, will also be served as a response, so that the caching server will cache the new copy of the file and then send that particular new copy to the user. So this is the way how web server, web client and middleware server will identify that the file which is basically cached from the browser or the middleware caching server is that updated at the client side or not, right? If that file is updated, then definitely backend application server will send the
latest copy of that particular file to the middleware caching server or the web client. So the header name is if modified since HTTP header. And as I told you, the application of the if modified since header that indicates the time for which a browser first downloaded a resource from the server. This helps determine whether or not the resource has changed since the last time it was accessed. If the HTTP status of a particular resource is 304 not modified, this means the file has not changed and there is no need to download it again. And having that ability allow both the website owner and the visitor to conserve resource at the file does not have the retrieve each time. So this is the header in the HTTP protocol if modified since, which will ensure that the latest copy of the updated resource will always received at the client side. If you want to see it, I can show you as well. So let me allow to go to the browser. So here I'm on the Firefox. I will go to the cache and I will delete the cache. Refresh this after deleting the cache. You can see right now I don't have any cache file. I will go to my Brownie site and refresh my Brownie site. You can see if I will refresh this cache. So once I have deleted the cache, there is no file or no entries in the cache, right? Now I will go to my Brownie site and I will open the network tool by pressing F12, right? Over here inside the network, we don't have any entry. Let's refresh your Brownie site. So if you remember on the PNG file, we have put the no store header in the configuration. So let's go to some JPG files. So let me find out some JPG file, and over here we have a lot of JPG files. So click on any JPG file and over here you can see. So with any JPG file, over here you can see the status code is 200. It means this file is latest downloaded from the application server. If I will open this request, you can see the request status is 200. Okay, this is the transferred size. And over here inside the response header, we are also getting the last modified. See, last modified Wednesday 12 August 2020. So this is the time when this particular file was last modified. But why I am getting the 200 at first time? Because I don't have the cache copy of this particular file on my box. If I will go to the cache, refresh, you can see we have the cache copies. Open the list and let's identify this URL. This is p1.jpg. I will copy this URL from the get request and try to find out it here. And you can see I am getting this particular file in my cache. Now let's do one thing. This is the file which is p1.jpg. Let's refresh your browser again. Let's go to that jpg file p1.jpg and see this time the response code is 304. We are not getting the 200 in the response code, we are getting the response code 304. It means the local cache copy of that particular file is already present on my box, so this file is not again downloaded from the web server. For all the png files we are getting 200 because we have configured no store cache header inside the nginx configuration file for the png files. Also for this file in the transferred, you can see we are getting the cached entry. It means this file is basically cached from the local site. See, we are getting 304 not modified. This time we are not getting the 200 response code. So this is the way how if since modified will work. Now if you will go to your web server and you will change this particular file. Let's go to the server. So we are on our server and here we will put ls. So my website is over here inside the blogging template. I will go to the blogging template, put ls. Here I will go to the assets. Inside the assets we have the images, put ls. Here we have the clients, put ls. And inside the clients there are all the png file. Let me go to the about ls. And here we have the jpg file, but we are not getting the p1.jpg, so I think we need to go to the portfolio. And here we have the p1.jpg. If you will put ls-lrt, you can see this file is last modified on August 12. What I can do, I will rename this file or move this file. So I will copy p1.jpg to like p7.jpg. Hit enter, put ls-lrt. You can see p7 is here and that is created on September 20. Now what I will do, I will remove the file p1.jpg.
right? Clear out the console, ls-lrt again. See, p1.jpg is not present over here, and p7.jpg is here, which is last modified on August 20, on September 20. Now I will again rename the p7.jpg. So I will call it mv p7.jpg equals to p1.jpg. ls-lrt. You can see the p1.jpg is updated on September 20. Now we will go to the browser and we will refresh the browser again. We will go to the p1.jpg file and see p1.jpg status is this time 200. It means this file is got modified after the cached file. You can see for other jpg file we are still getting the 304. It means already cached. See, but here we are getting the transfer data because the response is 200. So if we have updated the resource, although that resource is present at the browser side, but due to the if since modified header, browser will get the latest copy of that particular resource. If you will open this, you can see over here the last modified date is changed, and this time I'm getting Sunday September 2020. This is not August 12, right? So since the file is modified, we are getting 200. If I will again refresh it, we will get the 304 again. See, for the p1.jpg we are getting 304 because this file is already cached. So we have a very few fantastic headers in the HTTP protocol, but we need to know about them if you are going to work with the caching model of the HTTP and the NGINX Web Server. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to NGINX training. And this is a new section about the access control in NGINX. So very first we will see how we can whitelist the server in the NGINX. The another definition we can also learn that how we can restrict or allow the specific IPs in the NGINX. So let's start with. So suppose we have the multiple users. We have the user 1, user 2 and user 3, and all these users are basically accessing the same web server. So we have a single application server, and that application server is basically served by the n number of users. So sometimes you need some requirement, you need some restriction that a specific page of your website should not be exposed to everyone. The specific like admin panel of your website should not be exposed to the end user. So how we can restrict the user to access some specific page on the website? So for this, we can put the restriction on some resources with the help of the IP filtering or the IP whitelist. So suppose we have the first machine IP like 10.3.10.45. Then we have 127.12.30.88. Then third machine have the IP like 35.90.87.00. So every machine have the specific IP that is pretty much clear. So what we can do, so to keep some resources secure from the end user or to allow the restriction on the basis of the IP, we can put the IP restriction in the NGINX. The IP restrictions are also helpful in the multiple way. So let's discuss some real-time example of the IP restrictions or the IP whitelisting in the NGINX. So suppose you have some applications in your production server. These applications are not directly exposed to the end user, but these applications are basically exposed to the internal services of your organization. It means suppose you have some authentication service, and that service is basically exposed to each service which is the part of your software. Then definitely you need to put the restrictions on the authentication web server, right? And what kind of restriction you need to put? And you need to put the restriction like only the IP which are internal to your organization can access the authentication web service. No external IP outside of your organization can access that. So in that case, you can define a range of the IP which will be allowed at the web server side. So let's see how we can allow and restrict the IP at the web server. So NGINX has the inbuilt capability to accept and deny the traffic on the IP basis. If you want to allow the traffic from some specific IP, then you can specific and deny the traffic by this particular context. You can define the location, and after the location you can define the specific path where you want to allow or deny the traffic. So suppose you want to allow the traffic on the admin panel of your website, and you only want to allow the admin panel access from a single IP, then you can define that IP with the allow directive, and for the rest of the IPs you can define deny all. Deny all means only this particular IP 190.99.00.71 will access the admin panel of the website if this location block is defined, and all the IPs apart from this particular IP will get the 403 access required. So let's see the implementation of this particular context. So let's go to the terminal, and in my terminal we will open the NGINX configuration file. Over here in the nginx.configuration file, we already have the location block, and we have the second location block where basically we have defined the cache control. Let's go to the edit mode and update this cache control block. Right, suppose we don't want the cache control and we are going to update it, and over here suppose we are defining the allow to all png files with the IP. Let's find out the IP of your machine. So in the browser, type what is my IP and you will get your IP. This is the IP of my machine. I will copy this and I will paste it here. Right, so I will allow only my IP over here and I will put deny all. What does it mean? It means that the png file will only be accessible to this particular IP. Rest all the IPs apart from this particular IP will not access any png file on this particular NGINX server. Let's close this, but before and verify the NGINX configuration. NGINX-T, right? Configuration is okay, but before reload the NGINX, let's verify the website. So if I will go to over here, right, and I will refresh my Brownie website on the browser, you can see I'm able to download all the images. These are the JPG files, but these files are the PNG files, right? And I'm able to access my complete website. Now let's go to the Google and find some online proxy. Right, here we have the online proxy. Suppose we are going to enter the URL. This is the URL, but before this let's open the logs. So I will open the log tail-f where log nginx, clear out the console. Let's hit enter and let's go to the Firefox again. Once I'm hitting the web server from my local machine, you can see this is my IP 103.47.17190, right, which I have whitelisted in my configuration file, which is still not applicable because I have not restarted the nginx or reload the configuration. Now let's hit the same website from the proxy. So I will click this button and let's see if I will get the website. And yes, you can see I'm getting the Brownie site over here, right? If I will go to the console log, then you can see this is the IP what I'm getting from the proxy 192.99.56.22. It may possible when next time you will refresh this, you will get some different IP. I will go to the terminal, exit out from the logs and reload the nginx configuration. Reload is done. I will again open the logs. Now I will go to the Firefox and refresh my site from my local machine. Right, I'm getting my complete website. See, all the files are basically downloaded. Right, these are the PNG files. This picture, the banner is the PNG file, and this profile is also the PNG file. So I'm not getting any issue. If I will go to the logs, then you can see if I will find out some PNG, then you see all PNG are getting 200 status. This is the PNG, this is also the PNG. They all are the PNG files. They both are the PNG file and both are getting the 200 request. And I will open the proxy again. So online proxy, I will open some other proxy like this fastest free proxy me, or you can open any proxy over here, and over here you can paste your IP. So this is the IP of my web server. I will paste it and click on go. And once you will hit your website from the proxy, if you will go to the console log, then over here you can see for all the PNG files we are getting status code 403, which means access forbidden. Right, so team, by this particular way you can restrict the access on the resources of your web server from the public IPs. Right, so what I need to do, let me clear out the console and open the configuration file. I just need to define the allow and I need to define the deny. Now suppose you want to put multiple IP addresses in the allow, how we can achieve that particular thing? So the one solution is you can define multiple allows over here inside your configuration file. Second thing, you can save your file, go to any location on your nginx. Suppose I'm going to etc nginx, And over here we have few files. Let's create one more file, touch. I will call it whitelist IP. Open the whitelist IP file, and over here you can define the multiple IPs. Suppose I'm defining allow 127.0.0.1 local machine. Allow, define any IP. Suppose this is in your range 192.10.10.10.0 with the CIDR block 24. It means the IP of this particular range with the CIDR block 25. This is the range of the IP. If you are not aware with the IP range CIDR block, you can Google around it that what is the IP range CIDR block. And over here you can see I didn't define my local IP, right? Local machine IP. Now I will save this file. Exit pwd. This is the file location, whitelist IP. Now I will copy this location, open the configuration again, and this time over here instead of the allow, what I will do, will go to the insert mode and I will put include. Then paste the path and provide the file like this, right? Now let's save your file, reload the configuration. nginx-t configuration is failed. It means, and it is saying no such file in the directory. So it means we have defined, okay. So here is the spelling mistake. The file name is WHIT, not WHITE, right? So I will copy the name, open the configuration again, and I will update the file name over here. Save the file, check the configuration again, and this time it is saying that allow directive in the entry number 2. And over here we are getting error because we forgot to put the semicolon over here, right on the line number 1. I will save this and reload the configuration again. The configuration is okay. I will reload my nginx. So nginx-s reload. Nginx reload is done, and this time if you remember we have not defined the local machine IP in the configuration. So this time suppose I will refresh this site, will press F12 and refresh it. Now you can see over here in every PNG file you are getting 403. See, each PNG file is showing 403. If I will go to this file, I will copy the request, open in incognito mode to avoid the cache, and paste it here. See, we are getting 403 access forbidden. Why I am getting 403? Because my local IP is not whitelisted. So team, I hope now we are pretty much clear. This is the way how we can restrict the access to some specific path or some specific file on my server for the public IPs, right? We can whitelist the IP, or we can put the IPs inside the deny as well, so that all the IPs which is defined inside the allow block will access my resources, and all the IPs which is defined inside the deny will not access my resources on the server. 403 doesn't mean that the resource is not present on the server. 403 means resource is present, but this client is not authorized to access that particular resource. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to NGINX training, and today we will see how we can put up the limit access on the resources. It means how we can limited the users to access the resources on my website. So let's start with and understand the limit access with the help of a simple example. So suppose this is the web application server of my website. This server have the download file function. It means in my application we have some functionality where I allow user to download the resources from my web server. If you have the sites which is supporting the online video streaming, which are supporting the online download movie, online songs download, and if you have some website or the application which are related to the medical or pharma, right, and you are basically allow user to download the reports, so there could be the n number of example where user is allowed to download the resources or download the data from your web server. So you may be thinking this is the common functionality, multiple website allow the download function on the website, right? What is the big deal with the download? So let's assume a case. Suppose you have a server, right? And that server is basically connected with the multiple client. Suppose we have a first user, and that user have the 100 Mbps. Second user is also have the 100 Mbps. We have the third user which also have the 20 Mbps, fourth user have the 20 Mbps, and we have the n number of user which have the nth Mbps speed. 100 Mbps, 200 Mbps, 20 Mbps, these are the internet connection speed which user usually have. And as you are using the web server, so definitely you have the network bandwidth. And suppose you have the network bandwidth which is about 10 Mbps. In that particular case, when you have the 10 Mbps network bandwidth and multiple users are basically downloading the resource from your server, in that case the user who have the high download speed, they may get the all bandwidth from your server, right? It means all 10 Mbps bandwidth will be allocated to the users who have the high download speed, and the users who have the low download speed may get the 502 resource error. So this is not the ideal scenario. So how we can distribute that particular thing? So how we can manage that? If user are downloading the resource from my server, either they have the 200 Mbps or they have the 20 Mbps, they will download the file at the same speed from my server, or speed may vary as per the file size or the file progress. How we can achieve that particular thing? That thing we can resolve with the access control on the resources. So in the NGINX we can limit the bandwidth, and to limit the bandwidth we can use the limit underscore rate directive. So over here we have a simple example. So suppose you have some resources at the download location, and you want to set that each user maximum get the 50 kbps speed from your server. The download speed which user are getting from your server may be the 50 kbps. So you can define like limit underscore rate 50k. We can also limit speed per connections. If we want to limit the speed per connection, we can define that particular thing like this. We can define the limit connection zone. Over here we are defining the variable binary remote address which will capture the IP address of the remote machine or the client machine. Then we are defining the zone ADDR, and that zone size is the 10 MB. Then we are defining the limit connection ADDR1. It means one client can only download one file at a time, and the total limit rate could be the 50k or the 500k. Let's understand this with a live example. So we will go to the terminal. So on your terminal, let's go to a directory temp hotels. So we have some files in the temp, right? Now suppose we want to test the download speed of my server. So to test the download speed on your server, you can hit the wget on a particular resource URL. So if we will type wget, and we will provide some URL like http cachefly.cachefly.net 100 MB.test. This particular URL have the 100 MB test file. Let's download this file, right? So you can see the complete file is downloaded in just zero point 0.7 second, right? The total speed what I'm getting on my server is 143 megabyte per second. This is the speed what I'm getting on my server. My server have the download speed 143 megabyte per second, right? Now let's go to the Google, and on the Google let's find out the CentOS iOS image. So I will type download CentOS server ISO, hit enter, and over here we are getting the ISO CentOS mirror list. Let's open this mirror list, and let's open any mirror. And suppose I'm going to open the second mirror. You can open any mirror, there is no limitation, right? And on this mirror we have the multiple files, right? You can see this ISO file is in size of 4.5 GB, this ISO file is in the size of 9.6 GB, this ISO file is in the size of 1.4 GB. So what actually I'm trying to explain, once I try to test the download speed of my server, the download speed is 143 megabyte per second, and I'm able to download the resource from this particular URL at the same speed. So right here on this particular URL, there is no access limit on the resources. And as I told you, if you have the low network bandwidth and you are not basically putting any access limit, then the servers or the client who have the high internet speed, they may completely block the traffic of the resources which have the low internet speed, because the high internet speed connections are basically taking the preference, they are consuming the complete bandwidth of your network, right? Now let's try to execute wget on this URL. So let's copy the link of this URL, copy link address, and put it here. So this is the link of the ISO file of the CentOS 7. Let's hit enter. So you can see right here you are getting the download speed just 300 kbps, right? We are not getting the 143 mbps over here. The download speed is in between of the 300 to 400 kbps. What does it indicate? It indicates that these mirror site, the CentOS mirror site, have the access limit on the resources. Why the CentOS mirror site have the access limit on the resources? Because these are the sites from which million of the users are basically downloading the resource every day. Whenever you are using the CentOS package manager, that package manager is also using the mirror image, right? So there are multiple mirrors of the CentOS, there are multiple mirrors of the Ubuntu, right? And million of the user every day are downloading the resource from these servers. And if these sites or these mirrors don't have the access limit on the resources, then definitely the users like me who have the high internet speed on the server, they can consume the complete bandwidth of the CentOS mirror. And the user who have the low internet speed, they will never be able to access the resources which are available on the mirror site. So right now I hope you are pretty much clear how important it is to set the access limit on the resources if you are providing the some download functionality on your web application. So I will stop this by pressing Ctrl C. Over here we are in the temp, and I will remove the file which I just downloaded, CentOS 7. Clear out the console. So over here we have the file 100 MB.test, which is in the size of 100 MB. If I will put ls-lrth, you can see the size is 100 megabyte of this particular file. Now clear out the console and let's copy the 100 MB test file at some location on my website. So suppose first I will go to the website home directory, put ls. Over here we have the blogging template. I will go to the directory blogging template, right? ls. And over here let's go to the assets. ls. Inside the assets we have the images, put ls. And suppose over here inside the images we will keep that particular file. And suppose over here we will create a new directory, mkdir-p downloads, put ls. We have the downloads. Let's go to the downloads, and download is empty. Let's copy the file from the temp 100 MB.test at the current directory. Hit enter, put ls, and file is here. So you can see if I will execute the pwd, this file is present at this particular location, blogging template asset image download. Now I will go to the DigitalOcean, and on the DigitalOcean we will create a one more droplet. I will go with the basic plan of $5. Choose the password, choose the machine name, and I'm getting it Ubuntu second machine. Create the droplet. Let's wait until this machine will be created. I will copy the IP of my new machine and go to the terminal. In a new terminal, I will try to SSH my new created machine. So you can see new machine is created. I will clear out the console, and over here I will open the configuration file, right? So I will open the etc nginx nginx.conf, and over here you can see in my configuration my server name is this and my root directory is blogging template. So what I will do, I will construct a URL, and URL will be like wget http colon, then define the IP of my server. This is the IP of my server. Then define the path where the file is present which I need to download. So over here I have provided the pwd. Here is the file path. I will don't copy this because this is only present inside the, because this path is only present inside the root, and I will copy the assets, images, and downloads. I will copy this, provide it here, and after this I will provide the file name. My file name is 100 MB.test. I will copy this and provide it here. And let's see what is the download speed I'm getting on the another machine from my server. So you can see from my server, from the Brownie site, I am getting the download speed is about 23.6 megabyte. If you want, you can again try it. And this time again, I am getting around 22.3 megabyte per second, right? So my speed is more than 20 megabyte per second once I have the file at my local system. Now clear out the console, and how we can limit this particular speed. So we will open the configuration file, and inside the configuration file, inside the locations, right here I have the locations where I'm providing the try files and the complete URI. Go to the insert mode and define the directive limit underscore rate. And suppose I'm defining like 100k. Let's close the semicolon, save your file and verify the configuration. NGINX -t. Right? The configuration is okay. Let's reload the configuration. NGINX -t -s reload. Hit enter. Configuration is reloaded. Go to your another server and let's try to download the file again. So this time you are getting the speed which is nearby 100 kbps. You can see the download speed is not jumping more than 100 kbps. Why this speed is not jumping more than 100 kbps? Because we have restricted the limit on my server. If I will again modify the limit, and suppose this time I will set it limit 500 kbps, save my file, reload the configuration, go to the another server, clear out the console, and let's try to download the file again. So you can see this time I'm getting close to 500 kbps. Why? Because I have set that limit on my server. So this is the way how we can limit the resources on my NGINX server. Now suppose you want to provide some liberty to your users. You want to provide a liberty like 25% size of your file will be downloaded at the network speed of the user's speed, and rest of the file size will be downloaded as per the defined configuration. So we can configure that particular thing as well. So we know very well that my file size is 100 MB. And if you are aware that most of the resources which are available on your server, they have the size more than 100 MB or more than 500 MB, then you can put some kind of configuration over here. Let's try to open the configuration file. Before the rate limit, let's try to edit the location. Before the rate limit, I will provide another directive like rate limit after. And over here, I will provide some size. Suppose over here, I'm providing the 30 MB by 30 M. It means up to 30 MB, user will be able to download the file at the network speed, at the user's network speed. And after the 30 MB, user will get the limit rate 500 kbps. If I will save this and try to reload the NGINX and verify the NGINX configuration, it's okay. Reload the NGINX. Reload is done. I will again go to my another server and try to download. So over here you can see first I am getting 40 Mbps, 7 Mbps, 4 Mbps, 2 Mbps, and gradually it is decreasing and come up to 500 kbps. You can see the 30% file is downloaded at the high speed, and after the 30% it becomes on the server defined speed. So this is the another feature which you have seen in the multiple website, the website which have few free access and then they are asking for the premium membership. They have these kind of functionality. For the free users they will provide the limited access, but for the premium members they will provide the high quality content or the high download speeds, right? So this is the way team how we can limit the resource in the web server, in the NGINX server. So thank you team. See you in the next lecture.